Though you understood, no? Because yesterday I was full tension when lights. Otherwise, I'll be here, then we'll see. Because you have come over here. But somebody should. We'll take it. I just think I'm not going to take it. No, you need worst condition, which otherwise they will advise. If they don't, we can. Because inauguration was important.
Praveen Yamula.
Hello, sir.
Praveen, yes.
ಆಯ್ತು ಸರ್. ಅದೇ ಈ 4 ಮೈಕ್ ಅದೊಂದು
ಇದೆ
3 ಅಲ್ಲಿ ಬೇಕಾಗುತ್ತೆ.
ಕಂಟಿನ್ಯೂ ಸರ್. ನಮ್ಮ ಮೈಕ್ ನಂಬರ್ 8
ಇಲ್ಲೊಂದು
ನೀವು
ಇಲ್ಲಿ ಇಟ್ಬಿಡಿ. ಆನ್ ಸ್ಟೇಜ್ ವಿ ನೀಡ್ ಒನ್. ಇಟ್ಸ್ ವರ್ಕಿಂಗ್.
ಅಲ್ಲ ವರ್ಕಿಂಗ್.
ಏನ್ ಮಾಡ್ತಾರೆ ಅವರಿಗೆಲ್ಲ ಈ ಕಡೆ ಇಲ್ಲಿ
ಫಸ್ಟ್ ಯಾವ ತರದ್ದು
ಈ ಕಡೆ ಒಂದು ನೋಡಿ ಈ ಕಡೆ ಒಂದು ನೋಡಿ ಯಾರು ಯಾವ ಸ್ವಲ್ಪ ಕಾಣಲಿಲ್ಲ ಇಲ್ಲಿಂದ ಪ್ರದೇಶ ಕಾಣಲ್ಲ ಅಲ್ಲಿಂದ
ಇಲ್ಲ ನಾನು ಚೇಂಜ್ ಮಾಡಿದ್ದೆ.
ನೋಡಿ
ಇಲ್ಲ ಕಾಣಿಸುತ್ತೆ.
ಇಲ್ಲ, ನಾನು ಸ್ವಲ್ಪ ಈ ಕಡೆ ಗ್ಯಾಪ್ ತಗ್ದಿದ್ದೆ. ಕರೆಕ್ಟ್ ಆಗಿದೆ. ಹಾ, ಯಾಕಂದ್ರೆ ನಾನು ಇವ್ರು ಕವರ್ ಮಾಡಿದ್ದೆ ಸರ್, ಇವ್ರು ಬರ್ತಿರ್ಲಿಲ್ಲ.
ಎರಡು ಬರಲ್ಲ ನಿಮ್ಗೆ.
ಇಲ್ಲ ಬರ್ತಿತ್ತು,
ಇದು ಬರಲ್ಲ ಸರ್.
ಈಗ ಬರ್ತಾ ಇದೆ, ಈಗ ಬರ್ತಾ ಇದೆ.
It's coming, sir. It's coming.
ಗೊತ್ತಾಗ್ತಾ
Both are coming.
ಬರ್ತಾ ಇದೆ. ಈಗ ನೀವು ಕುತ್ಕೊಳ್ಳಿ, ಅಚೇತ್ ಮೇಲೆ
ಕಾಣಿಸ್ತಾ ಇದೆ. They are live, sir.
ಪರ್ಫೆಕ್ಟ್ ಆಗಿದೆ. ಲೈವ್
Yes, sir. It's live. They are live.
ಯೂಸಿಂಗ್ ಮೈ ಡಾಮ್.
Yes, sir. ಅದಕ್ಕೆ ರೆಕಾರ್ಡ್ ಆಗಿದೆ.
ಆಗುತ್ತೆ ಸರ್.
It's set up.
ಅಲ್ಲಿ ಲೈವ್ ಬರ್ತಿದೆ.
Oh, very good.
5 ನಿಮಿಷ ಡಿಲೇ ಮ್ಯಾಕ್ಸ್.
ಅಲ್ಲ ಅದು ಓಕೆ. ಇದು ಮತ್ತೆ ನಾವು ತಗೊಳೋದಕ್ಕೆ
ವಾಯ್ಸ್
ಎಲ್ಲ ಆಗುತ್ತಲ್ಲ.
ಅದನ್ನು
But also you should tell. ಅನೌನ್ಸ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಈ ಕಡೆ ಸ್ವಲ್ಪ ಮುಂದಕ್ಕಿಡೆ ಗೋಡೆ ಕಡೆ ಸ್ವಲ್ಪ ಮುಂದಕ್ಕಿಡೆ.
No, pull it from down.
Yeah, that's one point. One shot, you have to make sure you tell us.
Yeah, sure.
We'll help you.
Sure.
ಅನೌನ್ಸ್ ಮಾಡೋದಂದ್ರೆ
ಏನಾಯ್ತು ನಿನ್ನೆಲ್ಲ ಬಂತು ಅಷ್ಟು ಚೆನ್ನಾಗಿ.
You can watch in this screen and hear this.
Yes, yes. Someone has asked for IC features.
Yes, sir. Sir, I mailed you the link, sir. Today's link I mailed you.
It's coming different now. Coming different, sir. There's a good chairs are there, nice chairs.
Number ಏನಿದೆ? Number ಏನಿದೆ? 8.
Only people.
I'll get it.
Actually, my laptop is okay, sir. Open your idea. Okay. ಯಾವ್ದ್ರಲ್ಲಿ ಇದೆ ನೋಡಿ?
ಇದ್ರಲ್ಲೇ ಇದೆ.
Yes, sir.
Take PPT from sir.
ಲೈವ್ ಸ್ಟ್ರೀಮಿಂಗ್ ಲಿಂಕ್ ಕೊಡಮ್ಮ.
ಕಳಿಸ್ತೀನಿ.
ಯೂಸ್ ಮಾಡಿ. ಅಲ್ಲಲ್ಲ ಲೆಟರ್ ಅನೌನ್ಸ್ HTTP ಅಂತ ಕೊಟ್ರೆ ಅವ್ರಿಗೆ
ಓ, ಇಲ್ಲಿದೆ ಸರ್.
ಬರ್ಕೊಟ್ಬಿಡೋದು.
They only. You can connect it
ಕಾರ್ಡ್ ಇದೆಯಾ ಅಲ್ಲಿಗೆ?
ಅಲ್ಲೇ ಇದೆಯಲ್ಲ ಸರ್?
ಇಲ್ಲಿ ಕನೆಕ್ಷನ್ ಇತ್ತಲ್ಲ,
ಹಾಂ,
ಇದೆಯಲ್ಲ.
ಅಲ್ಲೇ ಇದೆ ನೋಡಿ. ಕಂಪ್ಯೂಟರ್ ಲ್ಯಾಪ್ಟಾಪ್.
Wire ಇಲ್ಲ. You can connect it here only. Slight changes. Yeah.
अनुज सही है?
क्या?
सही है?
एक मिनट You cannot see this link out loud. ಅಲ್ಲಿದ್ರೆ ಬೆಟರ್, ಚೆನ್ನಾಗಿರುತ್ತೆ.
ಗೊತ್ತಾ ಇಲ್ವಾ? ಗೊತ್ತಾ ಇಲ್ವಾ?
ಹಳೇದೆಲ್ಲ ಡಿಸ್ಕಾರ್ಡ್ ಮಾಡಿದ್ರು, ಮಿಕ್ಸಪ್ ಮಾಡ್ಬೇಡಿ ಮತ್ತೆ ಸೆನ್ಸ್.
ಆಮೇಲೆ
ರಾಜು
ಎಲ್ಲ ಕರೆಕ್ಟ್ ಆಗಿದೆ. ಒಂದು ನಿಮಿಷ ಇದೆ. ಅದು ಯಾವ್ದ್ರಲ್ಲಿ ಇದೆ? ಎಂಟ್ರಲ್ಲಿ ಇದೆ. ನಿನ್ನೆ ತಂದಿಲ್ಲ. ಅದು ಸೌಂಡ್ ಬರುತ್ತೆ ಅದು ಸೌಂಡ್ ಬರುತ್ತೆ ಅಂದ್ರೆ ಇದು ತೆಗಿ ಬರಲ್ಲ. ಸರ್ ಏನಿಲ್ಲ ಬರುತ್ತೆ ಮಾತಾಡಿ.
ಇಲ್ಲಿ ಬ್ಯಾಗ್ ಎಲ್ಲಿ?
ಬ್ಯಾಗ್ ಅಲ್ಲೇ
ಇಲ್ಲೇ ಅದರಲ್ಲಿ ಕೂಡ ಬ್ಯಾಗ್ ಕೂಡ
ಅಣ್ಣ ಬ್ಯಾಗ್ ಕೊಡೋಣ. ಅಣ್ಣ ಇದರಲ್ಲಿ ಇಕ್ಕಣ ಬ್ಯಾಗ್ ಯಾರು ಬ್ಯಾಗ್ ಇಲ್ಲೊಂದು ಬ್ಯಾಗ್ ಇತ್ತಲ್ಲ ಏನಾಯ್ತಣ್ಣ? ಇಲ್ಲ ಅದಲ್ಲ O-0 ನೀ 0 ನಾವು ಯಾರು
हाँ कौन सा आईडी 548-244-872 696 WGB.
ಇಲ್ಲಿಂದ ವಿಜಯ ಕೇಬಲ್ ತಗೊಂಡ್ರಣ್ಣ? ಇಲ್ಲಿಂದ ವಿಜಯ ಕೇಬಲ್ ಅಲ್ಲಿಗೆ ತಗೊಂಡೋದ್ರ? ಅಲ್ಲೇ ತಗೊಂಡ್ಬನ್ನಿ ಅವರಲ್ಲಿ. ಇದು
AC ಆನ್ ಮಾಡ್ರಪ್ಪ ಅನುಜ್, AC ಆನ್ ಮಾಡ್ಬೇಕು. 15 ಮಿನಿಟ್ಸ್ ಬಿಫೋರ್ ಸ್ವಿಚ್ ಆನ್ ದಿ AC.
ಎಸ್ ಒಂದು ನಿಮಿಷ.
AC ಆನ್ ಮಾಡ್ರಪ್ಪ ಅನುಜ್, AC ಆನ್ ಮಾಡ್ಬೇಕು. 15 ಮಿನಿಟ್ಸ್ ಬಿಫೋರ್ ಎಸ್
So we request you to submit the pendrive right now. Room number
AC ಆನ್ ಮಾಡ್ಬೇಕು.
ಕಳಿಸಿದಾರೆ ಯಾರಾದ್ರೂ? ನನಗೇನು ಕಳಿಸಿಲ್ಲ, ಒಬ್ಬರೇನು ಕಳಿಸ್ದಂಗಿದ್ದಾರೆ, ನೋಡ್ತೀನಿ ಮೇಲ್ ಚೆಕ್ ಮಾಡ್ಕೊಂಡು.
Cordless silver.
It is important.
Why would they have such a huge switch for something that's so small?
Yesterday also they Maybe introduce you.
Then I'll walk.
You sent this PPT already. That's called forward. Right, Suresh Kushal. On his way, he's already sent to PPT. On his way or what?
Good morning, everyone. Welcome to the second day of the 3-day national seminar. We will begin the session in a few minutes, but I have some announcements to make. Firstly, I would like to take this opportunity to thank our event sponsors: AICTE, ICMR, Himalaya, Aspartica, FNBR, Sidecare, SBI, Monsanto, Karnataka Antibiotics and Pharmaceutical Limited, BBC, CIII, ICTE, Ozone Scientific, SADA, ADA, Cital, Airlift Container Line, Disaster Innovations, BBN Instruments, Foresight. Secondly, we are honored to announce that the entire event is live streamed by Biotechnica Live TV. We will be putting up the link in some time. And also, please take a look at the stalls put up outside. They have very exciting products like the Gene Gun PCR. Here it will be. Thank you. As said by Benjamin Franklin, without continued growth and progress, such words as improvement, achievement, and success have no meaning. A very good morning to one and all present here. I, Naomi Vinod of 4th Sem BE Biotechnology, will have immense pleasure in taking you through the day's proceedings of day 2. I request one and all to kindly switch off their phones or keep them in silent mode. We begin the plenary talks. I now request I now request our main chairperson, Dr. V. Balasubramaniam, to occupy the dais. May I now request Dr. C. Rajendra Singh, Professor of the Department of Biotechnology, to kindly take over the session.
Good morning, one and all. So once again, I welcome you to the Day 2 National Seminar on Innovation, IPR, and Entrepreneurship Opportunities in Biotechnology. I have very pleasant duty of introducing the chairperson, Dr. V. Balasubramaniam. He is very well known and one of the most distinguished scientists at the occasion demands, and here is the brief about the Balasubramaniam. Dr. Balasubramaniam has received his PhD as a Mary Christie Fellow from the University of Wisconsin-Madison, USA, in medical microbiology and immunology, and then as a Harvard Youth Postdoctoral Fellow at the Albert Einstein College of Medicine, New York, USA, and has nearly 40 peer-reviewed publications. Dr. Balasubramaniam was previously Director, Infectious Business Unit at Cerebrals Research India Private Limited, where he led the discovery of new combination for the treatment of tuberculosis. Prior to this, he spent 2 decades in infection research and antibacterial drug discovery at AstraZeneca India Private Limited, where he established the in vitro immuno research for the infectious diseases measured in PKPD cells or anti-TB drugs, and led the discovery of the clinical drug candidate for the treatment of tuberculosis. Bala served on the board of AstraZeneca India Private Limited as Executive Director. He has served as a principal investigator in several prestigious research grants from the Wellcome Trust, Bill and Melinda Gates Foundation, European Union Framework Program, and DPT Government of India. Dr. Balasubramaniam is currently founder and president at Bugworks Research India Private Limited. So with this brief introduction, I request Dr. Balasubramaniam to take over the presentation. Thank you.
Good morning, all, and thank you very much for this lovely words introduction. Thanks, Professor Nagendra, a good friend who this is an opportunity to interact here. But I've always told him that it's fun to be here. I love to be with students. This time he spared me the trouble of actually giving the talk. So for that, I especially thank him. We've got 3 speakers this morning, probably going to touch 3 different aspects. So before I introduce the speakers, I would just want to take 2 minutes in terms of touching upon a couple of aspects. One on 2 of them on a somber note. The first is that this morning, I think it's in the newspapers that in the context of the budget, India spends 0.8% of its GDP in research, which is abysmally low. If we want to be in the top nations and claim ourselves to be the leader among nations, some of the benchmarks are, for example, China spends about 3%, Korea spends about 4.1% of its GDP. It is a sad state of affairs that our government, our national spending is actually quite low. And even within that, a large chunk of it actually comes from the government. So private sector funding in terms of actually investments into R&D is quite low. And it's a chicken and egg story. The chicken and egg story is that one could argue why we do not have a culture of spending more on research is because we are so proud of our jugaad culture, which I think is the worst term ever. A thing that I hate. Absolutely. Because jugaad tells you it's short-term, localized fixes, it has no long-term vision, it does not build the nation. And yet we've been so damn proud of that bloody word. If there's one thing that I want you to go out, this conference is throw that word out and do something useful. Innovation can happen only when we think in terms of long term, in terms of thinking global. It is not about fixing problems locally. It will obviously fix problems locally, but we have to think globally. And that's when we become actually leader of nations. It is very pertinent to me that we're talking about innovation on this day, which I don't know how many of you remember, that On this day, the greatest innovator of the political struggle of the 20th century was born here today, 1948. I think it is absolutely fitting that we talk about innovation because innovation is not necessarily invention. Innovation is how you do it differently and with phenomenal impact. The best example from India is probably Mahatma Gandhi. And with that, let me take the pleasure of introducing the first speaker today, Dr. Praveen Vemula. Praveen is a very good friend of mine. We work in the same campus. He started his education from the Osmania University, PhD from IIC in bio-nanomaterials, subsequently at City University of New York, and then at Harvard, MIT Division of Health Sciences and Technology. He's an absolutely brilliant scientist. I have the pleasure of actually working with him in an informal way. And he currently works on a variety of aspects such as biomaterials, bioengineering, and we will look forward to his talk on 3 adventures in bio-entrepreneurship. Praveen.
And I refuse to sit there.
Thank you so much, Dr. Rolla, for your kind words. And good morning, everyone. Even before I start speaking anything, I have a disclaimer. Calling me to talk about entrepreneurship and bringing Dr. Bala as the chair here, that is absolutely risky. Okay? So I don't know what I'm doing here. So, but like on the other side, whatever I'm missing, I think you can add like a lot more about it during discussion. I think with that, even I don't mind if I don't cover many of this. Then we are back at plan B, right? So yeah, thanks a lot for giving the opportunity to invite here to share some of our thoughts in science entrepreneurship. Today we'll discuss about some of the key parameters that play a major role in practicing science entrepreneurship efficiently in translational science. When you say translational science, right, by definition, largely developing innovative technologies, convert them into viable product to solve unmet clinical needs to improve the healthcare. That is in a very broad accepted manner. But it's irony that majority of the biotechnology or majority of the discoveries made, they're shown in the laboratory. They're not able to cause this valley of death to reach people to solve unmet clinical needs. Right? However, this gap can be bridged through productive collaborations between academia and industry with multidisciplinary expertise coming together. One can develop very breakthrough technologies. Even after developing technology, one has to practice very successful entrepreneurship program to convert this technology into a viable product to reach to the clinic. Right? So, if you see all over the world, right, the global, only a small fraction of academicians practice translational science. In that, even a small percentage of really set up a successful science entrepreneurship program. So the question is why? So is there any common features? Are they is the entrepreneurship taught, or are they acquired the skill set, or during their journey? And what to see what are the common parameters play a major role to make them what they are doing successfully. So to discuss them, to discuss those points, by observing, I have fortune to work with some of the best, translational scientists in the world, and by observing them for over decades to see how they are practicing and putting our own examples together. So I formulated a 4-step rule, right? So these are the 4 parameters we see common in any successful science entrepreneurship we see. But on the other side, these are my personal opinion, based on the observations and what our experience, right? So you can either take it or debate about it, right? So then we'll go through each point, right? The first one, you have a great idea, right? But it's very subjective, right? Everyone's idea is a great one, right? No one say, hey, I have a bad idea, let's pursue it, right? So then how we decide which is great idea, which is normal idea? I think ideas shouldn't be judged based on only complexity of the technology, but rather the idea which address the huge unmet need, right? You can even develop a simplest possible solution for the biggest impact problem that you're working on. I think that is qualified as a great idea, rather than you can come up with a very intelligent solution for a very small problem, right? So then we are developing technologies based on your great ideas. There could be like two ways, right? One is one product of technology versus a platform, right? So in the one platform, like you have one problem, then you develop entire technology custom designed to solve that particular problem. It's great, it works very well, right? But if you're thinking about ventures, okay, a startup or so on, it's always good to generate a platform technology, which means like you have a problem, you generate a technology which solves this problem A, definitely. But you have the technology in a flexible manner that you can tweak around your technology, it could be able to solve multiple other problems, right? So that's a platform technology. So having a platform technology is always handy and lucrative to start up any venture. Because your first venture definitely, most probably will fail most of the times, right? In entrepreneurship, you need always a backup plan. So the second point is like having a broad patent, right? It's absolutely critical to protect your intellectual property that you mentioned what you made, right? So that's why like we need to have as strong as patent possible, and more importantly, like the patent, what it does. So it gives you the right to practice the invention what you have made, right? So in that context, it is absolutely critical to have a blocking patent as well, which means like it to prevent others to do the same thing what you have invented. So it's absolutely critical to have a broad blocking patent which decides like the fate of your venture it is going to be. And how do you develop that is like, having like, a proper due diligence about your own technology and read a lot of prior art and to understand what has been done and what you have developed. And this is where I think we tend to have this inventor biasness, inbuilt biasness, right? I think like whatever we develop is great, but like we need to be absolutely critical about to see what has been done, whether whatever we are developing is an incremental change to the existing systems or it's a completely disruptive technology. So this is where we have to be absolutely critical and honest to decide or judge based quality of your technology is going to be. That's absolutely critical. So once we have that, like having a publication in top-tier journal, right? So again, like it's a subjective, right? Like it's not that like all the good work goes to only top-tier journal. You see like fantastic work published in second-tier, third-tier journals as well. So of course we should not judge the science based on where it has been published, but rather just the quality of science itself. But then why we need to try to push to the top journals, right? So it has twofold advantage. One is like, you take all these top journals, they build a credibility over a period of time because they set up like a very rigorous peer reviewing system. Even if you want to go there, like you need to raise your bar of the technology. They'll push your edges to bring the bar to very high. So when you get it there, like, it's automatically brings you the credibility for your technology. And second, it gives the visibility, right? Like because all the media and tend to pitch the technology that has been published in the top-tier journals, and and you also have much wider readership and so on. So automatically your technology will get the visibility and free publicity, right? So that is absolutely critical. And the fourth point, having a great team, and it is all about like people and people and people and people. If I want to tell like if I have to arrange in a priority order, this goes to the top than anything else. Because you can develop a very disruptive technology, absolutely fantastic idea, give you a bad set of team, they can kill you overnight. Absolutely, right? But like if you have a right set of team of people, even 10 ideas fail, they'll make sure that 11th idea will be succeeded. So it's absolutely critical to see what kind of people you work with, what kind of people you bring on your team. And especially if you're thinking about startups, right? Startup is like more about failure than like tenacity, how you go after it. It's not only just skill set you should look for, but it's also your personalities. Because startup is all about like 3-4 people coming together. They make sure like how things will go on. So they should buy your vision. You should share the common vision, but absolutely complementary skill set. You never bring what you are good at it another person because you can do what they can do. So you should bring someone like who does much better than you, like what you don't know, right? So with that, like these are the 4 parameters we keep seeing like majority of the entrepreneurship program, especially in translational science. So what I'll do is like I'll take like 3 examples. I'll walk you through our own example to see which works, which didn't work, and why. Okay. The first one I'll talk about developing efficient antibacterial coatings, not very successful story. The second one will developing these new materials for cleanup oil spills. It's a small twist in the story, we'll discuss about it. And third one is developing nanomaterials to prevent skin allergies, right? So the first example, we're developing antibacterial paints, right? As you know, like when you have this all over public places, you're prone to get acquired surface contact-based infections. And like that's why like it is absolutely important to have a common or safe surfaces, right? Imagine like having like any public places having this complete antibacterial coating, and which can especially reduce all the surface-based contact infections. And people have been trying to develop this efficient antibacterial paint for a long period of time. So, and one of the best methods people have been adopting is like, silver nanoparticle based paints, because as we know, silver nanoparticle have very efficient antibacterial properties. And people have been trying to develop synthesized particles and dope into the paints and been trying, but like it wasn't very successful for multiple reasons. One is like if you go back and see the synthesis of this nanoparticle, right? This is very common way of synthesis, like take the metal salts and reduce them and protect them, like to prevent your respiration and protect them with the coating agents. But during this entire process, like you need like multi-step synthesis, like you need like highly toxic reducing agents and organic solvents and so on. Lab scale they are okay, but like if you want to like to scale up to ton scales, it becomes very difficult. Not only that, even of having that, like you take these nanoparticles and blend with the paints, and often it's a physical mixing, so you don't get homogeneously mixed paints, right? Like so, you don't want to have patches of antibacterial activity on the surface. You really need to have a homogeneous surface. So, because of these reasons, like things didn't really kick off. So we thought, like, how can we solve this problem? So we set it up some of the benchmark. One is like try to avoid any toxic agents and the organic solvents, all these bulk solvents, and avoid all the multi-step synthesis and so on, right? And your process should be energy efficient, because see, like in a lab, you can heating 100 degrees is not a big deal, right? But like if you're thinking about setting up that for in a chemical engineering, if you go to set up that entire ton scale process, that immediately increase your cost of production by before. So there are like many steps that we need to think through in that process. So that's why we want to take out the energy efficient or energy consuming process, and also it should be amenable to have the bulk production and should be cost effective and so on. So then we thought like where to start from to put all this together. We thought like we'll go and understand the chemistry of the paints itself, then see whether we can draw any inspiration from there. So typically, if you see all the drying oils and paints, like they have like full of like abundant of polyunsaturated hydrocarbons. So because of that, when you paint them on the surface, they are completely sticky, right? Wet and sticky. But like what happens like after a couple of days, you see completely becomes dry, right? So they undergo this art oxidation, a simple drying process. What they do is like they capture oxygen and use the sunlight and makes the free radical. And once the free radical generates, they start attacking and other double bonds. So all the double bonds get cross-linked. Once all the double bonds consume, then your entire wet paint becomes completely dry film. Right? So that's a typical fundamental chemistry what we have. And interestingly, if you see the synthesis of the nanoparticle, people have shown that like if you have appropriate synthesis of free radicals, when you have the metal salts, they can reduce and generate the metal nanoparticles. We thought like, can we just combine these two? Because naturally anyway, when your paint is undergoing the art oxidation process, they are generating the nanoparticles. Free radicals. So if you have a blend of your metal precursor for the nanoparticles, that in situ they can reduce and form the metal particles. So for that, like simply you optimize doping with appropriate metal salts, and once you coat them on the surface, you can see like when you have the silver and when you have the gold, and upon the drying process, they completely form in situ generated nanoparticles. Since they are in situ generated, they're nicely homogeneous, and the byproducts that generated during the art oxidation process stabilize them and keep them tight. and we extensively characterize them and using. And this is like almost like kitchen chemistry, right? You can just convert any paint into antibacterial paint by using this. And we also went and tested their ability to show antibacterial properties. Here, like for example, each dot represents a bacterial colony. And when you see, like when you don't have anything, or when you have only paint without any nanoparticle, you can see the growth of bacteria. But whereas when you have the nanoparticle, you don't see any antibacterial at all. So it's true with the gram-positive and negative both bacteria. So we should like we could able to generate the simplified manner to have this much large-scale production of this antibacterial paints. And like it's been published and like it came into news and so on. We went and like got the patent as well. So if we come back to our checklist, right? We could able to develop very simplistic manner, efficient technology which could solve one of the need. And we could able to get a good journals, good publications and so on. But like although we got the patent, like I said, that's the weakest patent ever written. That was our first patent to write, like we had no clue how to write a patent, how strong we should do, like what are the things we need to take care. Because of that, like we had a patent, but what's up? Nothing. Okay, that's very bad patent. So that is one, and of course, like a team, like none of us had any prior experience. We have no clue what is the technology that is going to, or what is the next process. So often we think that we have developed fantastic technology, people should find me and develop further, right? That's never going to happen. That's you have to try, which we didn't have the skill set at that time. So because of lack of these two aspects, your innovative technology remained as technology until today, right? So that's why I say, like, as a scientifically, it's a very successful story, but as a translational, it wasn't. Like it's simply their story.
So scale-up was a problem, you mean?
No, scale-up, we could make scale. In fact, like our entire laboratory was painted with this one, just homemade one in the lab.
So where was the commercialization?
It's the commercialization after that, because like we didn't know how to raise money, even the next step whom to contact, how to put a startup together, or going to the companies to doing a window shopping, right? Giving them like a low window, like have a great wish to license that. We had no clue what other steps we need to take. So that's why, like, and we didn't even go to like the people to professional entrepreneurs or to bring them into the to start this.
Still, it is an unmet need, right?
It is. I don't know. Recently, if anything came up, I don't know. But at least 5 years back, nothing was done. Yeah. So that brings us to second story where we develop novel materials to clean up oil spills, right? So as you know, like when oil spills occurs, it's a huge disaster, and like there's millions of barrels go waste, and like they damage and stuff. So the reasons why this could happen, right? It could be like accidents of the ship, or simple leaking from the ships, or like having accidents during drilling and on this oil rigs and so on. So, but once the calamities happen, and they completely pollute the sea, and not only sea water, but it comes to the land, and the entire beaches and lands also get polluted. But more importantly, like all the marine organisms also under a huge stress based on this. Right? So then, to solve this problem, like there are like a few methods for people have been practicing even today. Some of them are like having manual cleaning. If you do the small spill up, you take the boats and pump your entire oil from there and do it. One is like limitation with this one is like a highly expensive process, and like this is remained to like or confined to only small spills. You cannot go for the large spills. And the second one people practice is the burning. You just confine them into a surface and just burn them, right? But like imagine that such large hydrocarbons you're thrown into the air, like how much you're polluting the air. Instead of seawater, you're polluting the air now. And again, like you can't recover your oil back, right? You're just burning them. So the mostly practiced method is, you take the surfactants and spray them on this oil spills. So what happens is when you have the surfactant, throw them on, it breaks oil into emulsion and the droplets get inside. So actually you're not solving the problem, but rather you're hiding the problem, right? taking oil from top and you're sinking, and you enter undersea marine organism is dead because of that, right? So that's why it's a huge unmet need. So then we thought like, what can we do about it? Like, can we develop some technology which can solve this problem? So the simple idea is like we came up with the phase selective gelation. So gelation is the process where you convert a liquid into solid, right? So for example, what we can do, we can take the appropriate chemical molecules which can self-assemble together. During self-assembly, they start making these higher order nanostructures. Once they form these nanostructures, grows into microstructures, they rigidify entire your liquid into solid, right? Then the question is now, our whole idea is like, you have two liquid phases, right? Invisible liquid phases, oil and water. And if you can develop a system which can selectively take only oil and convert them into gel, right? As simple as it is. Then you can take entire solidified gel-based oil and scoop out like your water and take it out, right? Then you'll have the clean water. So for that, like we designed some of these amplifiers. What they do is like when you throw these amplifiers, they start gelling only these molecules together. Not this, thank you. So when you have like, see like water have the high base and like now you have a thin layer of your spilled oil. Now just you take your compound and spray on top of this oil. What it does is like it starts self-assembling and it captures only oil and convert them into rigid solid gel. And that gel can be easily taken out from your water and like you have completely oil-free water left there, right? So in that way, like, but now we are converting oil into solid, right? Now we are taking out. So what we can do is, and these gels were designed in such a way that they are reversible in man, okay? You can use a simple heating process. You convert your solid oil into liquid, right? So because of that, for example, now we have this phase, you convert this entire top into solid oil like this. Now you take this, just heat it up. You can completely distill out your entire oil back, collect your oil back. That means if you have an oil spill, take them, collect on the seashore, you put it in the distillation center, you can collect your oil back, right? So then we went and quickly tested, did the cost analysis to see how much this process it happens, whether it's economically viable and so on. And this is the amount of US dollars required to clean up 1 gallon of oil, right? Manual is like completely out of the box, like it's too expensive. And the lowest is the just burning oil, burning in situ burning. With whatever the analysis we did, we came up with the number like this is almost as low as the in situ burning one, right? That means this is the cheapest way to do it. But not only that, none of these ones provides any oil recovery. But whereas here you can completely recover your oil back. So economical also is going to be the great product, right? Then again, like went and published, and it's I think this was timed. Unfortunately, it was the same time when the Gulf oil spill was happened. So there's like so much media attention and all that. Hey, and we went and now I think we learned a little bit the patent writing skills by then, and we started writing, got good patent. And if you come back to the checklist, right? So we were able to again, like solve a really unmet need, come up with a simple solution, and now we are at the decent patent, and of course, like we are a good publication and media attention, so on. But again, like we had a lack of team, and as I told, like it's not only skill set that decide like who should be in the team, but it's also the same vision what you mind for, right? So and we have completely lack of that. And we were sure that if we go with this team, like even spend 3 years down the line, we're going to fail. So that is bound to happen. So then we have to really take a hard judgment call. In fact, like for this technology, right, like our US Kentucky governor, she gave like $3 million tax-free money for a startup if you set up startup in their fund. But like still, we have to add a very hard call to take off this. So But as told, like, entrepreneurship is all about change, right? We have to adapt to the change because every day you might have a surprise. So then what we did is, like, as I mentioned earlier, it's a platform technology, developing platform technology critical, right? So what we did is, like, if you take this technology, it's a simple converting a oil into gel, right? So we tweak that technology a little bit further, and we use for the cosmetics and the food industry applications. And again, like, we patented that, and immediately we could see huge response from the companies who wanted to license that. So we simply licensed to these companies, and, like, we washed off. We didn't go for any venture. So that's why I say, like, although it's scientifically, it's again like a very successful story, and we didn't go to where we intended to start it with, but, like, we could able to take a course correction, and went to just a licensing deal. We went and came up with that. So with that, it brings to the third example where we developed this nanomaterials to prevent skin allergies, right? So we all are exposed to metal, whether we like it or not, and especially nickel, because from all the accessories, jewelry, cell phones, whatever, any metal object you touch, you're getting exposed to metal ions. So what happened is, like, everybody has a different threshold to tolerate this metal ions. Once you cross that threshold, even a minute amount of metal exposure brings you a severe allergic reaction. So it's called contact dermatitis, right? So then people have been trying to develop a system to solve this problem, but the only way people are trying is, like, using these topical steroidal creams. That means you don't prevent your infection or inflammation, but rather you're treating the allergies, right? And getting exposed to topical steroidal for life, it has its own detrimental effects. So, how we can develop this technology? So, we thought can see, right? Nickel is a simple divalent cationic metal. So, when you get exposed to, it crosses the skin, and it goes and binds to this toll-like receptor 4, and it causes this homodimerization, right? So that dimerization, because of that, it activates this downstream pathway, and then start releasing the pro-inflammatory cytokine and so on. So that causes for your delayed type hypersensitivity. So if you simply chemical way, if you think, like, if you can somehow prevent nickel going through the skin, you can prevent these allergies, right? You don't have to really play with the complex biology at all. So then idea is, like, can we develop a powerful ligands which can bind to this nickel to scavenge them? So, and we are not the first ones. People have been trying to do that. Like, there are a variety of very strong chelators, small molecular chelators people have tried. But unfortunately, none of them work when you go further, because all of them, themselves, they can go through the skin. These are small molecular chelators. So when you bind them, actually you are increasing the deposits of your metal, then actually diffusing. That's one of the reasons none of them could able to translate further. So then we thought, like, if you can develop a chelator, but, like, you don't allow them to go through the skin, probably can able to solve that. So for that, like, again, like, few benchmarks is, like, one is you have, of course, it should be best chelator, and we use the phosphates and carbonates. I'll tell you the reason why we choose them. And second is it should not penetrate through the skin, right? And there's plenty of literature is there that, like, if you have the nanoparticle which are, like, more than 30 nanometers, they don't go through the skin. If it is damaged skin, it's a 50 nanometers, so on. So we thought, like, if you can develop a nanoparticle based on these compounds, which is higher than 70 nanometers, we might able to keep it on the surface, but, like, they scavenge, but they don't allow them going through the skin. So that's the whole idea. And again, like, since you're going to use every single day, it should be non-toxic, non-irritant, and so on. So because of that, we chose the compounds from generally recognized as safe compounds. That means they have already been used in human for various other reasons, and they're found to be safe. By putting all of them together, so we came up with a simple calcium carbonate, calcium phosphate. We take these large doses as a calcium supplement, right? So then what we did is we formulated them into nanoparticles, and if you see the surface of this nanoparticle, they are like negative surface charge, which means they might be able to bind to the cationic metal ions. And then we went and tested their ability to prevent going to the skin, right? So for that, like, this is the plain skin, and when you coat this nanoparticle based cream, that's how it looks. And we divided this into 3 groups, where like the first group, you have this nanoparticle based screen. You apply that, and top of that, then you add your nickel solution. And after overnight, okay, you can image them from the transversal to see how deep the nickel went through, okay, how deep it penetrated. And as a control, you use like just base screen without any nanoparticle or any just naked screen. So then after doing that, like you can use this EDAX, a technique called EDAX. From there, like you can see the amount of nickel went through the skin, right? So here, red signal represents the presence of nickel, and green signal present in presence of calcium, right? And in these 2 cases, if you see when you have the particles, and nickel is just confined to only on the surface of the skin. But whereas in the absence of these particles and throughout the skin is completely deeply penetrated, right? Which is clearly suggesting that it can act as a physical barrier and scavenge, prevent them going to the skin. And again, if you see the presence of calcium, we are suggesting that particles all remains on the surface of the skin. Then we wanted to see whether all this nickel was bound to this particle. If does, can we remove from a simple washing? So we did a simple washing after binding to this, like it's a reminiscent to you taking shower and so on. And then you image them, again you can see all the calcium is disappeared. That means all the nanoparticles are completely washed off. But along with all the nickel that was bound to also completely removed. And you don't see any penetration of any metal ions at all. But whereas in the absence of that, already it's deeply penetrated, so you don't be able to remove that. So it is clearly suggesting it can act as a physical barrier, right? Then we went and tested whether it can really prevent the allergies itself. So then we developed the animal model where like 14 days you sequentially expose these animals to nickel and they get sensitized after 14 days. And after that, yes, even smaller exposure can evoke severe allergic reactions to them. Then these ones made into 2 groups and applied and exposed to nickel with without nanoparticle. And where you can see in the absence of nanoparticle, this is dermatitis score, that means the level of allergy. So it keeps increasing when you don't have the nanoparticle, but whereas in the particle you don't see that. Maybe images can do a better job. So this is in the absence of nanoparticle, we can see as we expose by day 5, day 4, you can see a complete damage of the skin and inflammation. But whereas in the presence of nanoparticle, you don't see such skin damage at all. So which is clearly suggesting that this can act as a physical barrier and scavenge metal ions and prevent all the metal associated dermatitis, right? So again, like it went and published and like it's got media attention, and then people started like reacting to media. That's a good thing to have. And we're like, this is to show that like how many number of people are really needing this technology, because as a scientist, like it's like very encouraging, right? The idea what you're thinking of, like really it is going to people like who are really in need of. But as an entrepreneur, there's like a free markets that there be potential customers for you if you develop a product. So then we went and patented this technology, but not only that, we tweaked around a little bit and developed an umbrella of patents around this. Then if you come back to your checklist, right? So there was a completely first-in-a-class based technology we could able to develop to solve this contact dermatitis problem. And of course, like we had a really strong patent. I think we educated a little more ourselves and also developed a portfolio of patents. And again, we had publications and so on. But this time, like we knew like what went wrong in the previous ventures. So, and we cautiously put effort to build the right team. Then with that, like we went and started a startup in France, Scientific. And this is our first CEO and this is the first 3 employees of the company. Now we are 44 employees of the company. And then we did the first in human clinical trials, and all the commercial formulations have been formed, and we launched in like 12 countries now. And like even in human trials, like we had like fantastic results. If you see the severity of this person had, and he started using like within 2 weeks, and you can see completely clearance of the skin, and 32 weeks you don't see at all. Right? So just to step back in a minute and see like typical drug development how much time it takes and how much how much investment needs to go in, right? So, but not necessarily every technology is be like capital intensive or time taking, right? So if you can appropriately design your technology and pick the problem, one can shrink this entire development period. So I thought I'll take a minute and I will just walk you through like what is the timeline we took for developing this entire right from the idea to the market, right? So this entire thing started in 2009, literally over a cup of coffee, because like our senior colleague, we all used to go for coffee. This guy is a married, and like, but he never used to wear wedding ring. So we used to make fun of him. Why you want to make your wife mad? Why did you wedding? So then he told like he has this contact allergy, and whenever he wears his wedding ring, like it's completely inflamed. He gets inflammation and he cannot wear it any further. So, and of course, for obvious reasons, he cannot change the wedding ring, so it doesn't work. So then, like, with our background, can we develop some technology to solve this problem? But, you know, over a cup of coffee, we talk so much, like many things, we don't take everything serious. And also, like, literally, that was the first time I ever even heard about metal allergies and contact dermatitis. So we don't even know what is there, what is done, why people are not able to solve. So we took almost like 6 months to read about everything, to see like what is the technology, like why people, what other people attempts are made, why they fail, and what is the need. So once we understand that landscape, we thought like probably with our background we might be able to give it a try. So then we decided at 2010, and by 2011 like we could able to publish this and attend that. And then we took almost 1 year to set up, find right people, set up people to form the company, to bring them into our core team. And in 2013, we went and did all the clinical trials, and in 2014, we launched them. Right? So literally, like, you know, less than 6 years, 5 years, like we could able to right from this one. So this happened like because like it took like small changes and precautions during the development. For example, a simple reason is why do we need to catch a carbonate, right? I mean, organic chemistry, if I don't synthesize, I feel bad, right? I could have made fantastic new molecules which can be much better than calcium carbonate, right? But we restricted ourselves from not to do, because if it is completely new material, we would have end up spending so much time and money doing the safety trials, clinical trials, and so on, extended period. Just because like we chose the calcium carbonate and with the safety data, plenty of data is available, we could able to convince the regulatory bodies that it is safe. So just one cautious measurement can save so much. So that's every step we will take that. We have to keep looking at that. And if you just simply thinking about impact, right? Of course, we got publications, patents, and created 45 jobs and so on. But more importantly, like improve the quality of life. The idea of what we think that can come to the reality and solve the problem people who are suffering. I think that is the driving force for any science entrepreneur we have. Right? 2 minutes. Sorry. So then the question is like, is it like a one-time hit? Like, is the 4-step goal is like, or like can we come all points together? Can we duplicate this, right? So for the like the last 4 years, like looking back, like we started developing a couple of more platform technologies. One is like, you know, it's very hard to treat inflammatory disorders because inflammation is never like steady state. It goes on and off, on and off. It's very difficult to find out when it comes, what is the severity of the disease. So in order to solve that problem, we developed a new concept where instead of we tuning when to release the drug, the disease itself controls when to release the drug, how much to release the drug. By using that technology, that concept, we should be able to show that it can prevent all the organ rejections and protect them from the rejection without having any side effects. And we published a science translation paper on that, and we showed this efficiency works in rats and pigs. And the second platform technology, what we developed is, again, inflammation is the patches, localized inflammation, right? Right now, there is no technology to go and deliver the drugs only site of the inflammation. It goes everywhere in the body. Because of that, you have severe side effects. So we developed a technology where it goes and screens the surface. If it is healthy surface, it doesn't interact. But if it's inflammation surface, it sticks there like a specific glue and release that drug. So because of that, we've been able to solve like, you know, treatment of our IBDs with a very inflammation targeting manner. It's again like we published another science translation medicine paper based on this. Again, we put the both patterns together and we formed another startup like in 2 years ago. This is our first team of the people. Now I think in 8 months we'll be going to filing a first IND for the clinical trials. So as I said, entrepreneurship, I think it's an attitude more than a skill set. I think how much you're willing to learn. And of course, every entrepreneur should make their own path, because even for you, first example might be very different than your second example. You have to relearn everything. So with that, I would like to thank the amazing group of people who works at INSTEM, who did most of the phenomenal work here, and also wonderful collaborators, my previous mentors where I worked with, and all the funding bodies which supported us. And thank you for your kind attention. I'll be happy to take it.
Thanks for being absolutely brilliant.
It needs a standing ovation.
It's absolutely fascinating. How often do we come across someone, as brilliant, just pronounce them the way? He's actually done such spectacular work. We happy to take questions, right? What we're going to do is we're going to switch the program a little bit. We'll take a few questions, break for tea, and then come back to the next two speakers. So please, the proof of that he's inspired you guys is when you ask questions. Good.
Hello, sir. I just have a few questions. You have used caption company for the nanoparticle synthesis. What process you have used for the synthesis of calcium carbonate nanoparticles?
It's a precipitation method we have used, but we didn't even bother to optimize in ourselves. So what we did is we gave to a company, we gave the sizes of the particle that we need. One is we had we did extensive size dependent studies also, 100 nanometers, 500 nanometers, micron, 3 micron, to see which one works best. The reason why we didn't try to optimize in lab is we know that if it goes, we have to go for process optimization in future. So rather than doing the later stage, we just gave the contact traces organization also. So they optimized entire synthesis in a very kg scale synthesis in the beginning itself. So in that way, we could kill 2 birds in one single shot.
You said that your process you are using it for some food applications.
Yes.
Could you please give some examples?
Yeah, so basically, if you take in food industry and all right, emulsifiers plays a major role. In various processes, you need emulsifiers. Even a simple butter now does need emulsifying process. So some of our amplifiers have such properties. The compounds for the technology what we develop, we can use them as a best emulsifier. So that's where we license that.
Thank you, sir.
What was so unique about this combination of calcium carbonate, calcium phosphate? Works with any combination of similar things?
No, in fact, this is not combination. Calcium carbonate separate, calcium phosphate separate. Either of them both.
Oh, I see.
So can we use this calcium carbonate on calcium phosphate for phytochemical?
For?
Phytochemical nanoparticle. Plants. So separation of nanoparticle from phytochemical.
Yeah, so you want to use the phytochemistry to make this nanoparticle?
Yes, sir.
I don't know, could be, but you see, again, maybe this is little offshore, but we can discuss. For example, we see a lot of examples where we would make silver nanoparticle, gold nanoparticles, variety of nanoparticles by using different phytochemicals, right? The first question for me, is why? So, why do we need to use the phytochemical? Versus I have a chemical process where I can especially control the size and shape so absolutely correct. Why can't I use that versus where I get completely heterogeneous population with the phytochemicals? Unless we have a very well reasoned and completely advantage using phytochemicals, I don't know whether we need to even adopt that.
So we are having several tablets like aronacin and astrogin, so which are useful for anti-cancer treatments. So actually, I have prepared a nanoparticle from silver, but silver is it gives some. There are some drawbacks to the silver nanoparticles, so which causes harm to the human cell. So my question is, so whether I can prepare with the column, what you said.
So the calcium carbonate, I need to check the chemistry little more because depend upon what phytochemical source we are using, it it depends on all of them. But theoretically could be possible, but unless we sit down and write on the paper, we don't know.
Really a blessed to hear your statement, sir. Thank you for giving an answer.
But that.
Good morning, sir. My name is Sandeep Kumar. I am a student of MSc Biotechnology from Rivers University. So my question is, you talk about the chemical being used for the cleaning up of phosphorus. So can you tell me about the chemical formulation of the compound and what is the mechanism that is used?
Yes, formulation I showed is a simple open chain sugar, okay, and both sides you attach two fatty acids. Okay. So we designed a self-assembled gels, right? Self-assembled by definition, what they do is they use intermolecular interactions to come each molecule together, right? So they use hydrogen bonding, hydrophobic interactions, like van der Waals interactions together to form these nanostructures which grow into micron structures. So the structure optimized in such a way that you have good balance between your sugar hydrophilic moiety versus your tail's hydrophobic moiety, and that's also important with the polarized amplifiers or where you put your hydrophilicity should be the middle or should be the end and or the reverse manner. So we have to optimize all that. That's how we design systematically to come up with it.
And so what about the concentration as to for particular area of the soil also, how much of the concentration of the chemical is?
Best gels forms between 1 to 1.5 weight %. So there we can get really strong gels. Less than 1%, in fact, 1 to 1.5%. And not only that, we tested different salt concentration because we're talking about sea, right, not fresh water. So all the salt concentrations and also temperatures, because it can happen in tropical countries versus in cold countries. So to manage to have this steady dilation properties at various temperatures, cold to higher temperatures, and all the salt concentration, thick oils versus thin oils, all that can happen.
Also, by using this chemical, does it not affect the water on the surface of the sea?
No, not at all. In fact, that's one of the reasons we designed these amplifiers is because this breaks into sugar molecule and fatty acid. In fact, fish would love it. That's the food for them. So I don't see it.
We'll take one last question here.
I just had a query. Now, extending this self-assembling gels that you have used for oil spill clearance to, is there any possibility, I mean, it's perhaps in the realm of hypothesis even as you know, you have the problem of freshwater lakes in our own city, and there is the problem of so it's perhaps it's a little far-fetched as well, but it hasn't been contemplated.
No, so if you step back and see, the technology does work, and absolutely we can clean any oil spill. That's the confidence we can tell. But we don't have a company or a process to set it up and take that further. So that's where we had to take our choice at that time, whether should we pursue that or instead of wasting our 3 years, we could have made 1 or 2 millions each, spend 3 years, but but rather we wanted to go with find some other technology where we make sure that we'll be succeeded. So that's the reason we shelved at that time. It wasn't progressed with. Yeah, so but the technology available if someone wants to license it, can be licensed and taken up. But we haven't set it up any company at our place. Yeah.
Sir, thank you for the wonderful talk. So you are mentioning about this metal irritants. So just I wanted to know, are there any plastic irritant in the sense one of my classmates is a cardiac surgeon, orthopedic surgeon. Whenever he uses gloves, he'll get allergies. So just I was thinking, are there any as such innovations across these plastic irritants or allergy things?
In fact, they do have some. In fact, I don't know in the plastic exactly what metal they have. For example, people who use leather, they get chromium and cobalt, and they get exposed and they have severe allergic reaction. And cement, when people are cement workers, like construction workers, they develop this chromium-based allergies. And this technology works for all the metal associated.
Because of that, we stopped doing surgeries for orthopedic patients.
Okay.
So we used to get
nitrile gloves. I don't know. I have to look into the exactly what is the allergen there.
Okay.
Thank you. I know this can go on. This is fascinating. Thank you so much. Absolutely great. Absolutely 15 minutes. We have to be back here.
Hello. Definitely thanks.
So assemble back within 15 minutes, please, quickly. Have tea and come back.
Sir, coffee.
Sure.
Coffee as well. And it's good,
Yes, don't need that. Yes, it's all done. So we just set the So presentation load. Yes, everything is putting. Everything is. We already sent us the PPT.
Hello sir, how are you? Also, I can connect my laptop and confirm everything is fine. Yes, yes, sir. Yes, sir.
You have questions?
This is the slide in
HDMI, right? Yes.
All the oral presentation participants are kindly requested to go to room number 017 and submit your pen drives, please. Do not delay it, it will begin shortly. The people who should give the oral presentation today, your names are put up on the bulletin board next to the registration desk. Confirm and submit your pen drives.
I came by yesterday.
Yeah, it's fine. I'll just keep it to it, so we'll automatically put it in. I'll keep it on like this, not the screen. Then keep it like this. Or turn it like this and keep it on that side. No, so it's like this. I'll start the PPT. Just start the after that. Mine is anyway third. Yes, after this and after this is like third. After that, one more presentation. Yes, sir. Okay. Just keep it on like this. We'll start it. Huh? अभी नहीं सेकंड टॉक अभी नहीं है
ನೀನು ಇವಾಗ ತಾನು ಕುಡಿತದ ಬರ್ತೀನಿ ಎಷ್ಟು ಕಮ್ಮ
I don't. You will take out. You will take out the card.
जैसे वो है ना बच्चा डाल देना उसको उसमें बता दो और उसका नेक्स्ट में स्टॉप
ये ना कलर में चल
वो आएगा नहीं आराम से
Myself, I'm from Tirupati.
I'm waiting for the guy to come and get orange. Either. There are like coffees getting cold here. Can I? Thank you.
Oh, you like to know?
It's cold enough.
It's oil.
Oh wait, is it a devotional thing that you can't do it? Or
Is it broomstick? In there?
cotton swabs, like be scientific.
Very sweet though, man. I've been seeing your mic switch off for that. No, there will be announcements to make after call, so don't switch off the mic. Okay. Suppose you switched off the mic and I became Godzilla instead of myself. Yeah.
I switched it on afterward. No, that's ये ले कॉफी प्लेट उठा लेंगे
उसको नीचे देना प्लेट को
David, what's wrong with
That's what you said, right? I would rather make more defined chemical process than my to control aspect. Hey, this is a furnace, man.
I'm sorry, sir.
Not working, huh?
The issue is these two produce sounds, and the ones in the back is like the audience say they don't want it because they're feeling questions.
We'll on the fan.
Yeah.
We'll on this fan.
We can go there.
This fan we can switch it on.
Yeah,
That's the only way I can, but I don't think it'll work.
Just a mic. Wait, mic. So mic.
Yeah. See, this is working.
It's a furnace.
Just keep it.
It's such a shame because, it's very pleasant outside.
Right.
Right now?
Is there any way that somebody can give a 5-minute warning? Please.
Just a minute.
Hello?
It's fine. No? Just let your mouse.
No,
It's not working. Why is it?
it's working. उसमें share down नहीं था ना?
Yeah.
वो वहाँ पर दूसरा लगा।
Okay, so these are like for adding tools like this is
This is for front and this is for back.
So it's not something. Can you speak?
Hello?
This fine.
Thank you. Yeah. You have to clear that out.
वहाँ उनको मैं देखूँ मैं आपस में वहाँ पे और एक कौन सा जगह यहाँ पे
जियो हॉटस्पॉट भी ट्राई कर रहे हैं
Good. Perfect. Awesome. Awesome.
Oh, yeah.
Yes. Please search for. Yeah. 3 seconds. Don't go. Welcome back.
Yeah. Is it audible back there? I hope all of you have rejuvenated a nice cup of tea or coffee. So, it will be a great pleasure to introduce our next speaker, Dr. Narayan Suresh. Very different from the first one who was a practicing scientist. Here is a science reporter who also brings, obviously, what this state obviously brings a nice external watchdog for us and he could keep us all honest. Today, Narayan brings a lot of experience. He was with the Times of India, and most of us here know him for his long stint with Biospectrum, a magazine uniquely dedicated to biotechnology. And recently, he is the COO of ABLE, which is a body which stitches together a lot of biotech enterprises. And good morning.
Morning, sir.
Hope you have had a good cup of coffee or tea.
Yes, sir.
So, ready to listen for these 1 hour. Or should I make it longer? So I've been coming here, I think Dr. Nagendra has pulled me in for more than 10 years, almost every year I've been making a pilgrimage to MIT during this time of the year. So thank you, Dr. Bala, for a good introduction. Yes, earlier I'm a watchdog, now with the table I have pushed up. Well, I pulled up to get the government to do all the work. So I was asked to talk about ABLE. ABLE is the Association for Biotechnology-Led Enterprises, which is founded when the industry also started in 2003 by people like Kiran Mudalgasha, Dr. Vijay Chandru, and a few others got together. Again, they wrote the plan for an envelope at a restaurant, and then they formed the association. It was just started to be, because NASCOM had done wonders for the software industry, so these people thought industry biotechnology is coming up, and so why not something similar to push biotechnology, and that's how they started. So before we come to what exactly we do at ABLE, so you're all biotech students. Can I ask some of you, why do you all do biotech course? What do you want to achieve by doing a biotech course? Anyone? Come on. I think one answer. Others will come. Come there and put one and ask you. applied biology. Huh?
It's applied biology.
Applied biology. Okay, applied to do what?
To help people and do more things to help society.
Good, good. Okay, so you're not the right civil services. Good. So in the first part of the talk, I'll just give you why biotech, because a lot of us are asked this question: what is so great? Why do you come down about biotechnology, and does it really do anything, or just hide what you read in the newspapers? Of course, this is a longer presentation. I will stick to the first and last part of it: why biotechnology, and then come to what we do at AIIMS. So now we have come to a stage, globally or within our country, that we cannot live without biotechnology, because biotechnology is touching all parts of our life. I'll just show you. Just look at this picture. There are three different elements. There's a very little Canadian girl. Other one is a typical being we have sometimes. There are very too much in a hurry, eat some fast food, but and then you see people queuing up for food, the fuel. So this little girl, just 4 years old, she had a form of leukemia, and she was given just about 2 or 3 months to live. But a company, Novartis, which is based in Boston, of course, MNC, they developed immunocell therapy. So that it was the first one, August 31, FDA approved the first gene therapy based on this T cells. So what they did was the girl was admitted to the hospital. So the genes are taken out, reprogrammed, and put it back, so that she now gets to live. In fact, as part of the approval, US regulator has mandated that Novartis should monitor her for next 15 years. That means she will live 15 plus years or more than that. It's just the first of gene therapy approved globally. And then subsequently, there are few other startups and others have. Of course, this was also developed by another company which Novartis bought. There are half a dozen companies working on similar treatments, and a few others have also subsequently got approval. And this is just the kind of work biotechnology interventions can do and it's already started. Of course, it's very expensive. It's about 3 crores plus is a treatment. But today, we have mechanisms. There are philanthropic organizations, patient advocacy groups, and others, plus insurance, and everyone make sure that anyone who needs such a treatment will not go away without taking it. So, cost is a different factor, but it's about $900,000, but it will be taken care of. And then, first year itself, there will be about 150 patients treated for this, and there are globally about 40,000 patients will be there. And then once you start doing it at a big scale, the cost will further come down, and usually Indian companies will also start doing this. So this is another company, Yescarta. This is the one I talked about. This is also got an approval. So in the food, one of the things we all, early mornings it's very cold here, but daytime the temperature is double, and we are all facing various effects of climate change, even at the local level. So high level of urban flooding and many others, they're all climate changes. So then people have looked at how carbon dioxide load is going up in the atmosphere, and more carbon in the atmosphere means good for the plants. The photosynthesis should take place. But when we look at the study in Harvard, they found that beyond a point, carbon dioxide levels in the atmosphere is actually a bad thing, because it does not. There is a phenomenon called carbohydrate dilution, because more and more carbohydrate gets into our cereals like wheat, rice, or many other pulses, which essentially crowds out the essential nutrients. So magnesium, iron, and many other things which we get through our normal cereal, it just gets reduced. And they say if we continue to grow food crops under current conditions, sometime we need to have biofortification. We have to artificially ingest some of these essential minerals. Otherwise, we'll end up with billions and billions of unhealthy people in the world if the climate change continues. This, apart from all the other side effects. Yeah. So there isn't bioelectrification. Fortification is the only solution for tackling in the long run, because the effects are now visible in reduced mineral levels. So then about the fears. So this is the company Synthetic Genomics. It was Craig Mentors, one of the dozen startups he is the inspiration for and he is working on. So they have managed to use an algae and double the oil content from 20% to 40%. You can see how much that kind of, if it becomes a reality, how the biofuels pricing and efficiency will change, and then you can. So one of the reasons today is even with the mandated 14% compulsory biofuels, we are nowhere close to more than 2 or 3%. So we are not able to do the blending or even if we want to use it, it's not available also simple because so here again, biotechnology will play an immense role. Of course, we are talking about electric cars replacing all cars in India by 2030. But we don't know whether that is the right solution because electricity has to be produced, and electricity, unless the solar power is used in a big way, even coal-based plants from where we get bulk of electricity is again polluting and it has other side effects. So what is the role of biotechnology today? It's playing in the world. It will heal the world. There are hundreds and thousands of new treatments under development literally, and today most of the new drugs approved globally are the biotechnology based drugs as opposed to conventional drugs. I won't go through detail because your presentation available here. So other than this, biotechnology will feed the world because without, of course, we are talk about, you all know about the genetically modification of modified foods, about 15, 25 products are approved, but that has almost come to an end because of the resistance. Now CRISPR and gene-edited foods are the future because some of the first products used based on CRISPR tools will come out by 2020 also. In fact, the plant food products will come out faster than the CRISPR-based medical medicines. You can just read about that is the technology of the future as far as agriculture is concerned. Then fuel the world. So I already talked about. So heal the world, feed the world, fuel the world. Without these three, we cannot live. Our civilization cannot go on for a long time. And all the three are the backbone. This is provided by biotechnology. So let me just quickly touch upon what happens. And so biotechnology itself is there are 5 distinct fields, not just one: biopharma, bioagri, industrial services, and bioinformatics or bio-IT, where all the tools, a lot of tools are developed right here in Bangalore. So globally, there are about 28,000 companies. And then one thing unique about biotechnology is that it happens in clusters. You cannot just go and set up a biotech company anywhere else in the world. You need, like Bangalore is one of the recognized 53 clusters. There are Hyderabad and then Mumbai, Pune region. There are 3 national capital regions. These 3 or 4 clusters. Similarly, globally, biotechnology happens like this only in about 54 clusters. Of course, there are many other clusters are coming up, but they will take a long time because various other things associated with it has to be in place before it becomes a common biocluster. Most of the clusters are in the West and in the US as well as there are very few in India and Asia. About 12 of 24 are in Asia. So globally, there are 28,000 companies. About 20% of these are publicly listed. They raise money, and they continue to invest.
there are only about 2 or 3 dozen companies globally, biotech companies make profits. All others are investing 10 to 15% of their revenues back into R&D. Of course, in India, there are only a dozen companies are listed in the public markets. Abroad, even companies loss-making or if they have a good technology, they can list and investors value it. So, our story, India's story is that it's almost 20 years since the first company started, Shanta, biotech company Shanta Biotech with the hepatitis B vaccine. And then later, 89, 90s, a lot of companies were started by Indian entrepreneurs, people who came out of IISc and many other places. So today there are about 2,000 companies. And then startups, like in IT, the startups are also count in a big way. As of last year, when we able counted, there are about 1,000 plus startups. I will give a little more detail. So some of the prominent names, I think the lady on the left, all of you are familiar, but there are equally prominent and other people like Cyrus Poonawalla, the Serum Institute of India in Pune is another icon for very quite icon. Dr. Krishna Ella is an agriculture scientist who runs Bharat Biotech, one of the top vaccine manufacturers, and just 2 days back they got rotavirus vaccine introduced, made in the country. So we all hear about Biocon. Biocon is one of the 4th largest insulin producer in the world. Where it started from a small way, and you can see how their achievement, how many patents and how many products registration. And then just 2 months back, they got cancer approved. First once a biosimilar approved in the US. So similarly, there are about 200 biotechnology products made by Indian companies are available to India. Of course, when you go to buy a medicine or any other product, we don't ask if it's a biotech or non-biotech product, but this is we look at the origin, and so 200 plus products. The Serum Institute I mentioned is the world's largest producer. They produce more than 1.2 billion doses of various vaccines, mostly pediatric vaccines. And then every second child anywhere in the world gets the first vaccine made by Serum Institute in Pune. Now they're investing to almost double the capacity to close to 2 billion doses they make. Any product category they enter, no other manufacturer can compete, and they just give up in Europe in all their multinationals. So US FDA approval is a gold standard. So the second largest number of US FDA approved manufacturing facilities, not just in biotech, across pharma, R&D, cotton, will agree about. So about this, we look at the size of the industry. So it's about 42 billion and growing at about 19%. 60% as the pharma products, and agri and others at another 40%. Why it's important? Because today at this, it's just not biotech, the larger bioeconomy where biotech is the key ingredient. So we are employing about 1 million people, and when it becomes our target is 100 billion by 2025. So then we expect this industry, the larger bioeconomy, to employ close to 10 million people. High value jobs. So last year we don't know the count of how many startups are there, and we did a count, and so this was the time to video headline last week. It's the largest biotech capital. So we counted 1,022 companies which have just formed within the last 5 years. Of course, since biotech takes a longer duration, government has given, central government allows up to 10 years as a startup definition for biotech to get various benefits. State of Karnataka allows, say, 7 years, but for this study we looked at only last 5 years the companies formed. It got close to $3 billion investment. Investment have come into this sector in the startups in the last 5 years. But half the companies are formed in the last 5 years, the last 3 years. You can see about 2/3 of these companies are in those big cities. The map. So Bangalore is close to 200 companies. There are a dozen companies right here in this campus, or just so stone's throw from here. CCAM, Force, CCAM, Instant, they all host another 40, 50 companies, and Bangalore Bio Innovation Center in Electronic City hosts another 20 companies, and so there are 200 biotech startups right here in Bangalore. And what's interesting is that that means 3,000 new entrepreneurs have come into the. So don't ask for jobs, start companies. These are all just 3,000 new entrepreneurs in biotech, and about 1,000 of them are women. And of course, most of them are in biopharma, agri, biopharma by far the largest activity based on. So why it's happening? Because there are a whole lot of the incubators, facilities, startup policy, funding, mentors, and you name it. And today, if you all you need is a good idea, because the rest will be taken care of. And then, so April also does some of the colleges. You mentioned each of this campus itself, 40, 50 NCL venture circle in Venture Center in Pune hosts 40, 50 companies, and all these places. Or even private university like AIT has 20 plus companies in the last 3 years. So, coming to able, so it's Association of Biotechnology-led Enterprises. Now we are changing it to Association of Bioeconomy-led Enterprises, because we thought more than biotech, we should talk about the larger bioeconomy. It was formed in 2003, and next month we'll be celebrating our 15th anniversary, the function in Bangalore, March 15, 16. So the almost 200 plus companies are our members. There are education institutions like MBIT, about 40, 50 top colleges and universities are our members. We just provide the ecosystem for everyone to come together and network, exchange ideas, organize events, and also take up issues related to the industry, to the government, and get the policies changed and incentives. These are all essentially the role of any industry association, which also do. But you do a little more than that also. So all this biotech companies. So it's not just one Biocon or Serum. You can see there are already some 200 brand names listed here. So when you are looking out, all those who are not going to pursue higher studies, there are just not one or two companies. There are hundreds of companies. So we promote biotechnology every year in the US. There's an largest international biotech conference. So every year it changes from different city. Last year it was in San Diego. This year it's in Boston. So we make reports on biotechnology and then release it there, and then give a one-stop information for biotech industry to the world. Down there you see there's a regular incubator, innovator, startup meetings we organize. This was the meeting in August. Bioeconomy conference. Then we do a bio investor conference regularly every year. We bring those who are seeking funding, startups and others. And then a lot of people today have funds, or a lot of people who have exited the company or who have done well in the biotech sector. They are also flush with funds, and they are all willing to help fund new companies. So startups have become a fashionable word now, but Able started it, encouraging startups in 2009 onwards. So we have a program called Best Biotechnology Entrepreneurship for Student Team. We ask college students in those who are pursuing biotech to form a team of 5 submitted ideas, and the top 20 ideas are shortlisted by jury, and they call for a 5-day workshop where we help them to convert these ideas into business plans. And then we've been doing it since 2009. These are some of the pictures from those. And from every year, so then on the last day they make a presentation before another jury, and the top 5 of these ideas are picked, and they get 5 lakh cash prizes from it's a government of India Department of Biotechnology funded scheme. And then subsequently most of them get apply and get that big grant up to 50 lakh from BIRAC. So some out of the 32 winners in the last 7 years, some 18 companies have come out, and some of the prominent companies are like Pandaram Technologies. You were read it 2 months back. It was selected as the Entrepreneur of the Year by the Economic Times. That was a student idea from IIT Chennai, and then they won this prize, and then subsequently they formed the companies. Or there is a company called C6 Energy, which is again based in Srikamp, which is converting seaweeds into fuels and plant growth hormones. That was again a student idea from IIT Chennai. So the next edition, the 9th edition, we are doing 2 weeks from now. We just finished the selection, the 20 team from University of Kashmir to Kanyakumari, Assam to Bombay. There are 20. They are the shortlisted teams. I'm sorry to say that, or I very unhappy that there are very few applicants. In fact, last 3 years into the program, there is not even a single shortlisted company or the ideas from any of the biotechnology colleges in Karnataka. We talk about innovation and all this, but there's not even one which is qualified for shortlisting. Of course, the message goes out, we talk to them personally, but nothing. Because Kashmir to Kanyakumari, students have applied, student institutions are there. Now, in fact, the able has proposed to Karnataka government that we have to do something more, because and we'll come up with a program to encourage students like you all to also look at ideas other than just trying to get a job. So we soon will announce a program, because it's very unfortunate, because all these 200 startups here are all formed by students from various IITs and various all over the country, but right here the students have not submitted any ideas. So there is another program we do that is also called Voice for BT, which is a public speaking contest on biotechnology. We have been doing it along with Neuroscience for 5 years, again to create awareness about biotechnology. And then we do a regional contest. It's open to college students. About every zone, we select some 25 colleges. There's an anchor institution in that area, and then we do the winners, all 3 winners from each zone, and all of them are given a 6 months internship by Neuroscience, and most of them have got absorbed in the last 4 years. This year's 2017 edition, we have done all the 4 zonal rounds, and this Friday we have been the national finals in Bangalore. Here, at least here, we have got students from Samaya and many others have got prizes. So this is one of the winners from last year. She was from Baramulla. So I can go. We have time now. Okay, I can go on and on, but essentially, what the message I want to convey is that a lot of things are happening in biotechnology. Of course, the size is never the same as IT, because there are 10,000 startups in IT. We have 1,000, but that's the 10% of biotech, 10% of software industry. But today is the right time, right opportunity for able the senior members we have a mentors itself, and then anyone can walk in and get all advice on what next to do on various aspects. Because when you are starting companies, it's just not funding. Funding is one aspect. More than that, people look forward to the expertise, contacts, networks of the established area, because with a phone call, they can connect you to people around the world for any tricky problems you run into. So this is just the right time. So all those who are not planning to continue the studies, look at startups. Even Government of Karnataka has a biotech skill enhancement program. Earlier it was called Biotech Finishing School. From this year, they just launched the Biotech Skill Enhancement Program, because those who just completed graduation can apply. Right now the call is gone out. Then 300 students will be selecting, and 50% of the seats are reserved for students from Karnataka. So they get a stipend for 1 year. So 6 months, there are 18 institutions, academic institutions included in the program, and there were 35 companies. So you do a 6-month part in the academic institution, because there are specialized program curriculum we evolved for it. And then the next 6 months you work in the company attached to it, and then so 1 year program, and then you get a PG diploma, and then the companies also get to evaluate the students. So this program has gone on for 5 years as BTFS, and some 800 students have got placed under this program. And so we are just starting it as a biotech skill enhancement program for the Government of Karnataka. You can just go and look at the ABLE website, or even Kevin's ITPT department website. You will get the details. The call is it's what applying. So,
thank you, Dr. Maran. Great overview, but more importantly, I think he's challenged all of you. I think it's a great wake-up call. Because it is quite depressing to hear that, while we claim to be the biotech capital of the country, we don't have any from your generation competing. So hopefully in the coming years that will change. Questions, clarifications, please. We have time for a couple of them at least. I think they're all shell-shocked with the fact that you just told them. We can do better, guys. Our responsibility is to catch this guy who's done it so many times. Well, I suppose we move on. Thank you.
Thank you so much. I now request Dr. Balasubramanian to kindly present a memento, token of our appreciation. There's a small announcement. Participants of the oral presentations are requested to report in room number 017 immediately.
We lose a 5. What? How many of them we lose?
Probably about 4.
Yeah, I said 5.
Kindly report in room number 017 immediately. Thank you.
Gives me a great pleasure to invite the final speaker for the morning session, Professor Dinesh, from a completely different background. He is from the Department of Electronics and Systems Engineering at IISc. Started his career at ITI, and then he is now at the Institute of Science. Got a big smorgasbord of expertise, ranging from mechatronics to telematics to power sensors, biomedical engineering, and so on. We look forward to your talk, sir, in terms of how you're going to inspire these students in terms of bridging engineering to biotech.
Good morning, all of you. First of all, I should thank our department here for inviting me. I am an engineer. I don't believe in compartmentalizing knowledge. So for me, I'm nomadic basically. So I interact with different people, different backgrounds, and then my passion is to develop products. I will today possibly present the scenario of product development in India. I belong to Indian Institute of Science, this is my department. See, this product design is something like mountain climbing. There's no rhyme or reason why should one climb mountain. But the pleasure one gets climbing over there is so enormous, people would do it. Many of us would like to spend time in having coffee or tea somewhere, cafe coffee day or somewhere, and spend our time. But there are some heroes who will climb up. Okay, so it needs passion. Without passion, you cannot develop a product. And I'm talking about products, not from the biochemistry angle, but from the engineering angle, who interacts with biochemistry people and electrochemistry people and doctors. We have come up with several products. So I'll just share some of the experiences with you. See, product development creates itself relates to prosperity in the country. Without product development, no country can progress. In fact, it's not a biological product, but I can still share with you. See, recently, a few years back, we signed an agreement with France for fighter planes, each plane costing $3,000, 3,000 crores, without space are separate. Imagine 27 planes, how much would it cost? And France is not even as big as Karnataka. Should we not have done it ourselves in the past 60 years? We could have done it. But somehow this product development has not really taken off in the country. In the past 2 years, we have been talking about it. And country can progress only if you can develop product. Either it is bio product, engineering product, any type of product. And in India, especially in academia, I'll just talk about the product development, different phases. See, it starts with inspiration and idea, and we analyze, do simulation, experiments, and we come out with lab proof and some concept work and industrial prototype and production. This is true with even biological product. And it gets into obsolescence. See, in India, in academia, we analyze, simulate, get the papers published, and go back to next inspiration. We don't get into these portions at all. The product and finish a project, and we start with new project. So product development has not been part of academia at all. See, this is our national symbol. In fact, I wonder why and how Ashoka, Emperor Ashoka, who thought of this concept, probably he must have visualized product designers in India. See, imagine. See, one is electronic, mechanical, another line is electrical, civil, physics, biology, medicine, all these things. Each line looks away from each other. They don't interact. We are looking at lines interacting with each other. Without interaction, how do you make a product? See, product development is a multidisciplinary work. So unless people work together, have mutual respect, you cannot develop a product. It's not possible at all. So I will deal with few case studies. About 5 years back, I had gone to CMC Vellore. One Dr. Usha Madheva, the highly respected person for PD orthopedic. You don't find ladies orthopedic surgeons, very rare species. And she is a PD orthopedic surgeon. And of course, there are reasons why. In fact, I did ask her, how is that she is an orthopedic surgeon? And why not ladies take up that profession? She was explaining that. So, she came with a problem. That was the first time I interacted with her. She said that children suffer from this clubfoot problem. That is a congenital problem. As soon as the child is born, the child's feet are bent inwards. And if no care is taken, the child will have to walk the same way, and then these bones become very hard and it cannot walk. So, this is a normal feet. So, if the child is reported to the hospital, possibly, at the age of 3 years or 2 years, the bones will have already formed and they're already hard. So, what they do is they do surgical procedure and then make the feet straight. And this being a congenital problem, the feet has the tendency of bending inwards again. So the child has to wear a brace which will keep the feet away from each other at a particular angle for 3 years. Then the feet become alright. So in fact, when the child is reported to have this problem, within few days after the birth, immediately they cast. The bones are still very soft. They cast it within 15 to 20 days, the feet become alright. But again, the casting is removed, again the feet bend inward if proper care is not taken. That is nothing but brace. Brace is made up of a plate, an aluminum plate, two shoe fit into that with a particular angle. There are different things that are available in the market. Don't you think this looks like this medieval torture device? Imagine yourself wearing two shoes fitted to each other and you cannot move your leg like this. Especially children, always will be kicking around. And if you restrict the feet, they start crying. So the problem was that once they wear this and the parents are taught how to put it on the child, they go home and the child starts crying after some time. Parents are so loving, they remove that and then keep it. And after 3 months, the parents are supposed to bring back the child and show that to the doctor. So, what is done is, the parents put it on and then bring, and then they lie. They say, it was on all the time. So, the doctor can easily make out the child was not wearing it. Is there any way that we can monitor the wearing back of the brace? So, that's what the requirement was. So, then the other thing was looking at the children wearing this, they can only do like this, they cannot do like this, which is very natural for children. So we started working on, one thing is monitoring the brace and monitoring the wearing of the brace, and second thing was whether the brace was put properly or not. That is compliance monitoring. And the third one was, is it possible to give larger degree of freedom so that the child can still crawl and do all sorts of things as natural as possible. So, see, any project, like you have today, our friend presented about this idea how it became a commercial product. The same way in engineering, we come up with certain specifications. So, it has to sense the presence of weight, log data for every hour for 4 months, low power consumption, battery operated, tamper proof, vibration proof, and water resistant, data downloadable to PC, practically invisible to patients, and indicate proper wearing of the shoe. So these are all some of the things that we listed. These are risk specification. So these are the 3 regions if you could monitor and log. If feet are touching in these regions, that means the child is wearing it properly. Plus, sometimes it also happens that some portion of this feet is not touching the insole of the shoe. Then it is not maintaining the compliance. So, this was the basic block diagram of the system that we envisaged. So, we built the sensors and this electronics behind that. The entire thing could be embedded into the shoe the child wears. And when you connect this using USB, we could get the report as to how the child was wearing it. See, you see 2 bars here. It's not a 4-bar linkage in mechanical engineering. So with this, child was able to move its leg. It could also move here, this way, sideways. So we found it during clinical trial, children who could not roll over with an American brace, With this, within 5 to 6 seconds, they could roll over easily. And this brace, we have used real aluminum alloy, which can withstand that kind of forces and all that. So it is very light, much lighter than what exists elsewhere. And when we took this, we designed it and then took it. The problem must have been third or fourth version. We were so happy, we gave so much degree freedom. And the doctor looked at this. So we were proud. Me and my students, we went to same Civello. And the doctor was not at all happy. She said, Dinesh, it looks very dull. Children won't like it. See, this is interdisciplinary. Her sensitivity for children and all that is very nice. So we had to make it attractive. Actually, this was the first version we made. Second thing was, child with this brace can easily hit its forehead. This bar can hit the forehead. We never imagined that. She showed me that how they do it. So it had to be nicely buffered so that this won't hurt the child. And also we made a lot of pictures on this, colored pictures, so that child likes it. So this was a graphic user interface that we developed. So it gives a complete detail of child's name, mother's name, age, everything it gives. And as soon as the doctor logs into that, this is shown, and it can also show whether the foot is touching properly at various places. So these two places it's not touching, whereas here it is touching. So all this graphic user interface, which will tell you that day-wise how the varying pattern was, and within a day how was it varying. All this is on hourly basis. See, after the several months of development work, we took the brace and she said, the doctor, children will break it. I smiled at her, I said, how can I break it? It is aluminum, you cannot break it. But within 1 week after we gave it, this was the way in which it was brought to us. Then we had to go for an aluminum alloy which is used in aerospace applications, which is very hard, which can take that force. See, children exert so much force, that's impact. I will show you that video a little later. So, this is how the child wears it. And see, this was the first time the child was given this. The child was so happy, it could crawl. See, that's okay. All of us have done this, sir. You don't know, you don't remember. Okay. So, we called it Padmapada. In fact, the name was given by Dr. herself. Padmapada is lotus feet. So, and we patented this. And this technology has been given to industry for manufacture. Actually, about 300 to 350 children are cured of clubfoot in the past 3 years. And it is going through multicentric field trial in 10 centers, including Ceylon. So workshops have been conducted, and these people are.
What's the duration they have to wear?
They have to wear it for 3 years.
Oh, still there.
First 2 years, 24 hours, and next 1 year, depending on the improvement. But the feet become alright. So it was given Energy Award just last year. This is one project that is going on in my lab. See, if you want a wheelchair for a patient, you ring up the nurse or the ward boy. It takes around 1 hour to 1.5 hours to get a wheelchair. We wanted to make wheelchair like Uber. If the dial number, wheelchair should complete. Maybe it's a crazy idea, huh? But we started working on that. See, we built entire electronics, everything, and these are all sensors which can help the wheelchair guide itself. So this is the first version that we made, which is 80% autonomous. Now some more work is going on this. Probably by the end of this year, we will come out with improved version. So it has obstacle avoidance and guidance, and it can guide itself in the corridors with laser rangers, and it can integrated walls and then it can guide itself. And this also can be operated through manual means. So now I get into different domain. This biochemistry or electrochemistry. See, myself and Professor Lakshmi Narayan from Raman Research Institute, electrochemistry person, name to recall with me. And we had Professor Shankaran from Biotechnology Center and Anna University. We three of us were just discussing in one of the meetings. We were planning to do something that touches society in a big way. Milk is something that every children drink. So, in fact, it is so much adulterated. If you buy milk in some places, 70% of it is adulterated portion and 30% is real milk. And it is generally adulterated with vegetable oil, detergent, urea, shampoo, and so many things. Think of anything is there in nature. So we wanted to make a device which, very in a simplest way, without any any other requirement. I just dip it should tell you whether it is adulterated. This was my requirement. So we started working on that. About 1.5 years or 2 years, we did work and we came out with some solutions. But those things didn't lend themselves for an easy or user-friendly application. So finally we came up with an idea and we implemented this. We called it Milk Tester, and this has been transferred to a Gujarat-based industry, and you can find it in Amazon also. We started selling it. So this is a very simple device. You just repeat, it will tell you. We actually measure impedance and then detect the next process. So I don't get into the details. See, one of my students, after finishing the MTech from IIT Kanpur, she came to my lab. She said, on what problem shall I work? I believe researcher, he needs problem. But in our country, you have so many problems. There is no gaps or problem in the country. You can find any problem and then start working towards them. You don't need to really search for the problems. So I said, you go to CMC Vellore, stay there for 10 days and come back. So she stayed in Usha Madri's lab. So she came back, she said, sir, we should do something for the spastic children. So spastic children, there are different levels of spasticity. At some degree of spasticity, children can use this kind of walker. This one is posterior walker. Then they hold and then walk. So the children need some support so that they don't fall down. But at the same time, they also exert their body force on that. Around 30% force is applied on the walker. They rest on that. Plus, they are able to initiate gait, walking gait, and then slowly they walk. See, this is a typical way children walk. See, the child is struggling to pull this walker along. There are 4 wheels for this. He is struggling to push it. And our idea was, see, most of these walkers, they use it on plain surface within the house. It cannot use it on animal surface. And you cannot walk on lawn, road and all that. And ramp, you can forget it. We wanted to develop a walker which will allow the child to walk on any surface, including ramp. This was the idea. So we developed this. It's an adaptation of existing walker. We built a sensor array here with intelligence in that. So that what it does is it measures the contour of his body with respect to his body frame. It finds out whether the intent is towards moving towards right, left, or moving forward. So from this, it can find out whether you're moving forward or left. Then the back wheels are motorized. It will actuate in such a way, it will just keep following the child wherever the child goes. So these were all the floors that were used for clinical trials. It has gone to clinical trials already on some 16 children, and everybody they use only 30% of the energy required for using passive walker. This we call it robotic walker or active walker. So this was a ramp record. those with 15-degree inclination. So this without any training, the child was given, the mother was there. So we just tried it. She started walking. See, so easily, she's not at all pulling it. The walker is following her. So this is a patented technology, and my student is completing her thesis shortly, and she will submit it. So this is another thing. When I visited Dr. Usha Madhuri's lab, I found that in the ward, so many children and adults, they will put this thing. There is a technique where, it was developed by Dr. Isaro. When you have in one leg, shorter than the other leg by 1 inch, what they do is they break the bone, and then they keep the bones distracted. So the bone has a tendency to go inward. So in the process, you can lengthen the bone. Same thing is true that you can, if there are some deformities, you can correct that. So this I saw that. But my question was, see, how do they distract it? There are the nuts here. They have to use a spanner and then turn it. So the first 5 days, adults, they have tried how to do that. Every day, some once, twice or thrice in a given time, they should rotate so many times. So my question was, if that person is greedy and maybe 1 week's distraction he can do in 1 day. So she said it's possible. Is it possible to avoid it? So then we worked on automating this. We just the doctor programs it, automatically this distraction takes place, and we have developed the system, entire system, and it is going for clinical trial shortly and animals. We developed a drug delivery system, insulin pump, which is much economical compared to imported ones. And I will get into this. We developed the drug delivery pump. This is a drug delivery pump and electronics for controlling it. And this was the conceptualized thing. And this is a device that we made. And it went through clinical trial successfully. That is animal trial. But human trial, we will go through probably maybe a year or 2. So we also developed this painless needles. Say, all of you know this skin, the nerve endings are here. If we can stop the needle, prick and stop the needle above this, it doesn't give pain. So we developed painless needles, which are around 300 microns long, and the diameter is around 150 to 170 microns. Hollow needles, array of needles, so you can put it as a patch and you can deliver that. So actually we are working a collaborative project with PGH Chandigarh. They have taken the responsibility for animal and human trial, and we are developing the needles. All 25 drugs are there for children. All those drugs could be delivered through this painless needle. This is a patch you can put and deliver the drug. So this is another thing that we developed, the antibiotic device, which will for urinary tract infection, you will find out which is antibiotic that is sensitive for this. So this has already gone through trials at Coimbatore, one of the leading labs, recognized labs. About 500 samples have been already tried successfully, and this is becoming technology, and some industry has come forward to buy this. So I think I have covered my time. Thanks a lot.
Thank you so much. Fascinating. That's another amazing journey of product development. I know this is not. He probably spoke more on aspects which you maybe cover in your curriculum. Questions? Otherwise, I'm going to pull up names. So you're safe. Look, I want to ask you, there are lots of products that you showed in terms of development. Is there a commercialization strategy that you have?
Yeah, see,
what was that? How did that pan out? How did this actually become commercially successful?
Yeah, I'm part of National Healthcare Hub, which is there at Anna University. Started for DST, NHHID. So the idea is that academia will develop some product, and they have industrial tie-up. So many industries also participants in that. So they invest some money to start with them based on the lab prototype. And finally, the technology transfer to the industry. That's the idea. And I play a role of product designer. That is I have a lab funded by DST. We call it Product Realization Center. So if some university or some lab comes up with a concept, for example, that anti-diagram which I was talking about, that was developed at Anna University. It's a 5 years work of student. So he comes out with this. In the lab, you use all test tube, everything, but you cannot use that in a clinical lab. So what we do is we automate that. So we took up that automation and then we did that. So this is product realization, the concept to product realization. Then we have to handhold the industry, because the industry will not have the expertise to manufacture those devices. So we have to help them so that connect people.
Get the right one.
Right, yeah.
And in terms of, I know the solutions, every one of them that we spoke had a start point which is very, things which are emotionally impacted in the neighborhood. But all of them probably have a global implication.
Yeah.
So if we looked at in terms of what could be a potential reach, and one of the key things that has always plagued Indian products, and it's not meant as an offense, is the last mile issue, where the finesse, which unfortunately plays a lot of premium, because the one who's buying looks at the packaging, looks at the finesse of it. How do you actually deal with that in terms of that last mile issue?
Yeah, see, this food race, for example, we had that international market in mind. We developed all the package, everything. The package itself will come to around 20% of the total product.
Sure.
So, the doctor says, many of our poor people, and we have our own societal product. I think ladies should know that. The moment the child is born with this club foot, the lady is driven out of the house. It was a shock to me to know that. And till that child becomes alright, she is not admitted into it. So the lady has to afford that kind of product. So we made two different products. One for the high-end market, another for low-end market. So low-end market functionally it's the same thing. There's no difference. But you have to have you have a fully loaded car. But for the car you have other audio and other things which will add up to the cost. Similarly, you have rear packaging and so many other things will add up to high-end that we have to do.
Thanks, that's great.
Thank you so much, and this was really a very touching talk. It's so nice to see that we give back to society. Thank you so much, sir. On behalf of the organizing committee, we request Dr. Balasubramanian to kindly present him along to Dr. Suresh. We'd like to join hands and thank Dr. Balasubramanian for this wonderful session. And I request my to kindly present the memento as a token of appreciation.
The session was good because of the speakers. No credit here.
That's some announcements we made. First of all, let me take a moment off to thank our sponsors, AICTE, ICMR, Aspartica, SBI, Monsanto, SiteCare, Karnataka Antibiotics, FLDR, DBC, CIII, ISTE, Ozone Scientific, Zastra Innovations, Sadada, Cytol, LF Container, BVM Instruments, and Innova Foresight. The poster presentations, the posters have been put up in the foyer, so request all to kindly take a look at the poster. And the oral presentations
will be 20% 95. I give you the details. Next to the airport 20.
as well as the foyer.
will make the travel.
We request all we request one and all to kindly reassemble in the seminar hall by
Give your
1:15
mobile
for
number
practice.
and
Thank you very
email
much.
ID. That's all we need. Just you don't have to write. So I'll send you the details. So then you can do that. I will take leave. I'm also leave.
Professor, brilliant, sir. Thank you, sir. What an inspiration.
So I'll send you the mail. I'll go back to the office. So block your date for 15th.
When is it?
15th Feb. Just check the diary. Yeah, so I'll send you that.
Thanks.
That I don't know. ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಮೀಟಿಂಗ್ ಇದೆ ಹೌದಾ ಹೇಳಿದೆ ಹೌದಾ
May everybody, the lunch is being served outside. So finish your lunch. Take a look at the stalls. We have very exciting products, the gene gun, the PCR machine, so on and so forth. Take a look at that. Take a look at the posters and come back and reassemble here at 1:15. Please spread the word. Thank you.
What are you doing now?
Speaker here.
What do you mean? You don't need speakers now, there are subtitles and everything over for people when you say voice panel discussion.
Oh.
Let's go.
Hey.
Wait. No, it's too much in front. It is there to meet each other. What is wrong with you? Is it
more efficient?
It's slant. No, they did that so that they can see in the live stream for people who are standing on the podium. So that's why that has been changed. So this is okay. We'll play some tech video.
It is
playing. Here you go. Oh, this has to be done.
Is this working?
In the notepad side. Cheers.
But at least it can show the game's property of radioactivity, another color data, orange. Before World War II, it was common for manufacturers to surrender dinnerware to use uranium oxide in colored glazes. The compound produced brilliant reds and oranges, which were really attributes, if not for the radiation they emitted. Of course, radiation was something we were unaware of until the late 1800s, let alone the associated cancer risks which we discovered much later. During World War II, the U.S. government confiscated all the uranium used in the development. However, the Atomic Energy Commission released restrictions in 1959 and depleted uranium returned to soil medicine. The U.S. EPA
So go to the fact. Who's the just really one second. Wait. Keep the schedule under the schedule under number 5. It's like beside. Okay, who left their bouquet here? Who left their bouquet here? Then it's Narayan. Do we have to go give it to them, ma'am? Huh? Did he leave his bouquet? It is because when I gave it to him,
ಬಟ್ ನನ್ನ ಲ್ಯಾಬ್ದೆಲ್ಲ ನೀನೇ ನೋಡ್ಕೋಬೇಕು. ನಾವು ಇದೆಲ್ಲ ಆಫ್ ಮಾಡ್ಬೋದು. ಇದು ಓಕೆ. ಲೈಟ್ ಆಫ್ ಮಾಡಿದ್ರೆ ಪುನಃ ಆನ್ ಮಾಡ್ಬೇಕಲ್ಲ ಸರ್? ಲೈಕ್ ಐ ಆಮ್ ನಾಟ್ ಕಂಟ್ರೋಲಿಂಗ್ ದಿ ಲೈವ್ ಸ್ಟ್ರೀಮ್. Then it's of no use. ಅಲ್ಲೆಲ್ಲ ರೆಕಾರ್ಡ್ ಆಗುತ್ತೆ. Unwanted stuff. You have to disconnect and then wait for them to connect again. 150 or game will work. Very importantly, if you will put it there and I should what this one laptop. ಇಲ್ಲಿ ಸರ್ ಇಲ್ಲಿ ಫಾಲ್ಸ್ ಇಲ್ಲ ಏನು ಇಷ್ಟೇ ಬಾಕ ಅಡ್ಡಾಡ್ತಾ ಇದ್ದಾರೆ ಅದು ಇದು ಫಾಲ್ಟ್ ಇದು ತಗೊಂಡೋಗು ಆಮೇಲೆ ತಗೊಂಡೋಗು ನಾನು ಒಪ್ಕೊಂತೀನಿ ರೈಟ್ ಸೈಡ್ ಟೇಬಲ್ ಇದೆ ಥರ್ಡ್ ಒನ್ ಕನೆಕ್ಟರ್ಸ್ ಆಮೇಲೆ ಇನ್ ಕೇಸ್ ವೈರ್ ಬೇಕಂದ್ರೆ ಒಂದು ಎರಡು ವೈರ್ ಇದೆ ಸರ್ ಆಯ್ತಾ ಆಮೇಲೆ ಅವೆಲ್ಲ ತಗೊಂಡೋಗಿ ಏನೇ ಇಡ್ಬೇಕು ನನ್ನ ಲ್ಯಾಬ್ Hey, you decide here is Vijayta resume who is correcting resume. You are given so if she may, 150, she may sleep for 10 minutes. That's what they're making about some raw was there. In fact, actually, I wanted to talk about site care and cancer awareness. If people have put me in what is that film? Ajay. They are not coordinated. They made for 6 months. Then now that Vijayta is coming, she will be part of panel. Or if you want to talk 10 minutes, put site care later.
So 155.
But two different stops also.
These butterflies. Yes.
These are blue morpho butterflies, maybe the prettiest butterflies of all. Blue butterfly emoji. The blue color isn't from a pigment. Blue comes from the shape of the one scale itself. How this works, we see way out the big scale, seasonal ridges, spikes across the scale.
I couldn't locate.
Those ridges are shaped like persistence. The arrangement of branches is what gives morpho wings their blue color. When light comes in, some bounces off the top surface, but some passes into the layer on the bottom surface. But most colors of light, waves reflecting from the top and bottom will be under phase, but you can't stop. And that way is blue, but blue light is just the right wavelength. Reflected light waves are in sync, and that color makes it to our eye. This hall of mirrors only lets blue light escape. There's no pigment at the base or stray red blue light, make the blue even more pure. That's how we get this awesome iridescent blue, the microscopic structure of the wing itself. All this happens because of the way light bends when it moves from air into the material. If we fill all those tiny gaps with something other than air, like alcohol, the blue disappears. Technically, this changes the index of diffraction, but in ordinary that means blue light is no longer bent the right way. The microscopic light filter is broken. Until the alcohol evaporates, color returns. But these butterflies live in the rainforest. Do you think they would lose their color anytime they got wet, right? Well, watch this. These wing scales are made of a material that's naturally water resistant. They stay blue in any weather. What about this blue jay feather? If you look through it, the color completely disappears. Blue each feather bristle contains light scattering microscopic beads, spaces of everything with blue light is allowed. Only the shaded feather structure we find in butterflies, these feather structures are more messy, like a foam. So instead of changing, the colors more even in every direction. Peacock tail feathers, again, is the shape of the feather, not pigment. The feather structures here are more ordered, like a crystal, so it's lighter from certain angles. There's even let's keep this peaking. Even that color is made by the adding and subtracting light waves thanks to structures in the skin. And yes, even your blue eyes are colored by structures. Outside of the ocean, almost exclusively, the bluest living things make their colors in microscopic structure. Each one is something different. No vertebrate, not a single bird or mammal or reptile that we know of makes a blue pigment on its body. In fact, there's only one known butterfly that's got the coat for making a true blue pigment.
Blue as a pigment in nature is incredibly rare, but there's one exception so far that we know about, and these are over here called the olive ones. They have evolved a blue pigment, and they're not very common, and we don't know very much about them, and I don't know any other blue pigments.
That's a really special butterfly. The body is almost all of nature's made from structures and non-pigments, like everything else. I've asked this question to several scientists and several others. Here's their best theory so far. At some point, way back in time, birds and butterflies evolved to go and see blue light, but they hadn't yet found a way to paint their bodies that color. If they could, we could have gone from early beetles to Sergeant Pepper's beetles. It meant new opportunities for communicating and survival. Creating some blue pigment out of the blue would have required inventing new chemistry, and there was no way to just add that recipe to their genes. It was much easier for evolution to change the shape of their bodies ever so slightly at microscopic level and create blue using physics instead. They solved a biology problem with engineering. What I love about this is that these colors have fascinated curious people for hundreds of years. After looking at peacock feathers through one of their first microscopes back in the 1600s, Robert Philip These colors are what we call pastel. Even isolated notice there was something unusual about these blues. Scientists had studied ever since, not only because the science is interesting, but because it's beautiful. Thanks for watching. Stay curious.
Okay, all right. Oh, without any question, I can do this a long time. Okay. So there was a dance. The butterfly wasn't there. How come?
मैं राम को लाया था उनको मैं हिलाऊंगी प्रैक्टिस सबका लाने सारे प्लेयर्स रन पर और ये सिक्स चलो ना मैं कितना खेलेंगे मेरे लोग से बुला आ गए 5 तेज मार पर भी हमारी कोशिश जारी है कौन को विनाश जब तक मिस्टेक वगैरह हो जाएंगे ना और बीमार मत पड़ना प्लीज 30 दिन की मेहनत मैच का दिन आ गया मुझे तो फ्री राइड मिली नहीं है बस
What was on today?
सब कर बन गया चार फिर से बीमार
In the 1800s, Michael Faraday gave a series of Christmas lectures to kids at the Royal Institution in London. One of his favorite subjects to talk about was fire. Faraday was particularly interested in candles because inside their delicate flames, they hold some amazing lessons on how fire really works. Now, you might have seen fire described like this in chemistry class, but the chemical formula doesn't explain what fire is any more than the recipe explains what chocolate cookies taste like. The first thing we notice about a candle flame is all those colors. How things glow because of the black light they use. As we talked about in our video about the color of the down at the bottom of the flame, it's hotter, so it glows blue, and in the middle, it's cooler, so it glows yellowish, orangish. Inside of that flame, there will be hundreds of chemical reactions taking place. The oxygen in the air and the carbon and hydrogen in the candle don't do anything all by hand. It takes a little outside to get it started. The solid fuel is vaporized by the heat, ripped into small chunks. This is called pyrolysis. You can't have a flame without it. Sometimes it gets dark and long around the wood. There's no fire. That's what vaporized wax is coming off the candle, but it hasn't started to burn yet. The hydrocarbons and oxygen in the air slam into each other, and their atoms begin to rearrange. Sometimes electrons in those atoms get into an excited state. When they come back down again, they give off light. That's why the bottom of the flame glows blue. Now all the carbon in the candle gets converted to CO2, so leftover carbon atoms come together to form the particles of soap. This glow is soaked through the Eventually, the tip of the flame almost suddenly burned away, or like all the carbon dioxide and water floating off into the air. You can investigate all the different parts of a flame yourself just before you see that. Up here we find water vapor. In the yellow part of the flame, soot. And now just next to the wick, we can even recover unburned wax. Please look. Wait, what was I talking about? Oh, right, shape. Gravity pulls cold, denser air down, makes hot air rise. This buoyancy gives flames their familiar shape. But if we light a flame at 0 G, say on a space station, it'll look very different. All the chemical and quantum reactions make a flame glow cold, and where it meets the air. So even though they look like solid cones, and the flames are actually water.
Completely. Because
not the molecular ripping apart that makes flames. The formation of new molecules and new bonds is what creates heat. And that heat drives the chain reaction forward, vaporizing more fuel, slamming more molecules into one another, and making the fire burn on. Our species has been gathering around fire for thousands of years, telling stories, asking questions over a flickering flame. And it's part of what made us human in the first place. Stay curious.
How far will $10 take this year? Learn from experts around the world. Explore 10.
Physics like to show us the universe's basic building blocks, and biology likes to first understand itself. But chemistry is where all fun happens. We have thousands of chemical reactions going on inside us every second. But it's the ones we master with our hands in labs, workshops, factories, and kitchens that made humans what we are today. A few chemical technologies made such an explosive change in how we live, they follow a very trajectory. There are 6 chemical reactions that change history. Fire, our first foray into chemistry, for better and for worse. Whether it's animal, vegetable, or whatever's in Hot Pockets, cooking our food makes it easier to digest. We get more nutrition for a lot less work. But there's a different bit of chemistry that turns food from simple nutrition into something fun to eat. In 1913, a French chemist named Louis-Camille Maillard described the most delicious reaction that I know of. Pretty much everything we cook, including sugars and amino acids, react at high temperatures. The result is, well, hundreds and hundreds of complex flavors. It's what browns really hamburgers was crispy crust like pizza with golden edges on French fries. Sorry, I got a little carried away there. Anyway, sure, harnessing fire made food more digestible, but the Maillard reaction made more fun to eat and to drink. Because really, where would you be without roasted coffee? They say sticks and stones can break bones, but if your ancestors didn't figure out how to do bronze, they were really murdered by someone who did. The only pure metals that Earth has any metal are copper, gold, and silver. Unfortunately, they're all able to make the cookies. 5, 6 hours. Copper elements like tin.
ಏನು ಕೆಲಸ ಮಾಡಬೇಡಿ ದೂರ ಹಾಕೊಂಡು ಮಾಡಿ ಅವ್ರು ನಾವು ಏನು ಗೊತ್ತಾಗಿಲ್ಲ ಹೇಳ್ತೀವಿ 2 ಗಂಟೆ 2 ಗಂಟೆ ಮೇಲೆ ಮಾಡ್ತೇನೆ ಹೇಳ್ಬೇಕು ನೋಡಿ ಸರ್
Let's get any plans to a nice smart system where people will do food for everyone, giving others free time to explore arts, events, government, and even science. By harnessing fermentation, burning sugars, gases, alcohol, and gas, creating such tiny creatures they had no idea they existed. Turn fruit, vegetables, grain, even vegetables, tastier and last longer. You know what's also nice? Fertile water. For those that can visit the wrong street or around the last fermentation is antimicrobial alcohol. Considering water used in actual milk, it's no surprise that they came up with this in the past. But nobody wants to sit in the smelly even in ancient Sumeria. Tablets dating nearly 4,000 years ago there show formulas for mixing water, alkali ash, and oil or animal fat in making soap. Plant and animal oil for trying this one. This all one is attracted to water and the other attracts easy non-water. The resulting chemical mix is using water or all those things. Newsflash, computers are a big deal. And your cell phone or smartphone have to be like chips. Silicon is super easy to find. It's used in chips. Out here, it's in the 1990s. Pure solid silicon is a massive billions of separate crystals. It looks cool, but everywhere these crystals meet is a place of semiconductor action. The Chauncey process is a message. The silicon is remelted and a single crystal is lowered in and smooth. This first crystal is aligned in a growing solid mass. The single ready to be sliced and diced.
Everything
that's alive needs
so next session we need a picture, was it?
Yes, sir. Next is the panel discussion.
What time?
1:30 in the evening. Schedule. So Uta around was from 1:15 to 7 hours.
The panel discussion ಯಾರು ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತಾರಲ್ಲ
ಏನು ಮೇಡಮ್ which we can then turn into an infinite stuff. So why is this number one? Fertilizer. For the first time, farmers didn't rely on the crop rotation or show the family now provided with nitrogen. Inexpensive chemical fertilizer let many people grow abundant food for the first time ever. The world grew so much food, in fact, that the global population was more than quadrupled. Revolution. 450 million tons of nitrogen fertilizer is sold every year. Cars and cereal are the only thing industrial nitrogen. Nitrates are necessary.
ಒಂದು 50 ಇರೋದು ಪ್ಯಾನೆಲ್ ಡಿಸ್ಕಷನ್ ಒಂದು ಕಾಲ ಅಂತ 115 ಇಲ್ಲ 50 ಹೌದಾ ಸೊ 50 ಅಂತ ಕೇಳಿಸಿದ್ರು ಮಂಜುಷ ಅದು 150 150 ಗಣಕ 150 ಇಲ್ಲ ಮ್ಯಾಕ್ಸಿಮಮ್ ಲಂಚ್ ಬೇಗ ಬಿಟ್ಟರಲ್ಲ ಬೇಗ ಲಂಚ್ ಮಾಡಿ ಸ್ವಲ್ಪ ಆಟಕ್ಕೆ ಊಟ ಮಾಡ್ತೀವಿ 12 ಕಾಲು
direction. For a while, like this folks were the only light today, stars is the only glow we can see in the night sky, but in every direction, hiding in the background is the first light, the earliest picture of the universe that we can see.
ಅಲೆ ಭಾಷೆ ನೋಡ್ರಿ ಅಲೆ ಭಾಷೆ ಸಾಕಿತ್ತು
ಇಲ್ಲ ಯಾಕಂದ್ರೆ ಸ್ಕೂಲ್ ಕರೆಕ್ಟಾಗಿ ಬರಬೇಕಲ್ಲ.
Y'all use technology to understand how it works. Consider a great price. It's not much of a price.
ಅದೇ ರೈಟ್ ಸೈಡ್ ಲೆಫ್ಟ್ ಸೈಡ್ ಅಲ್ಲಿ ಒಂದು ಕಡೆ ಬ್ಯಾಕ್ ಒಂದು ಕಡೆ ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಅಲ್ವಾ?
Make a bite. 1,000 of those make a little. 1,000 of those make a few bites and terabytes. Although we don't understand how astronomically huge they really are. Terabyte seconds is 32,000 years. Far beyond these scales, one of which
ಅಲ್ಲ ನಿಮ್ಮ ಹತ್ರ ಒಂದು ಕಾಪಿ ಇದೆ ಯಾಕಂದ್ರೆ ನಿಮ್ಮ ಚಿಕ್ಕಲ್ಲಿ ಒಂದು ಕಾಪಿ ಮಾಡಿ ಇಟ್ಕೊಳ್ಳಿ.
all the videos on YouTube are about 500 megabytes, whereas companies like Google
ನೋಡ್ಕೊಂಡು
we're saying so much about this challenge to you.
ನಾವು ಹೇಳ್ತೀವಿ.
It's estimated as many books press ascribed to all the previous 1,200. Today, on the other hand, we double our store of information every 3 years. Consider 2007. All the data we've ever saved everything was estimated at 300 exabytes. By 2013, that number really goes to 100 exabytes. The total amount of data dawn of civilization in just 6 years. This acceleration will no doubt continue to accelerate. Radio telescopes that make up a square kilometer array generate an exabyte of astronomical data every 4 days. In several years, we'll probably live in a world that deals with zettabytes, one of which on our rice scale. This isn't about
ನೀನು ಡೈಲಿ ಇದ್ರೆ ನಿನ್ಗೆ ಏನು ಅವಾಗ ಈ ಕೂದಲುಗಳೆಲ್ಲ ಅಪ್ಪ ಬೆಳಿಗ್ಗೆ ಎಚ್ಚೋಡಿ ಏನಾದ್ರು ಗೊತ್ತೇನೋ ಕೂರ್ಸ್ಬಿಡೋಣ ಅದಕ್ಕೆ ತಗೊಂಡು ವಾಪಸ್ ತುಂಬ್ರು ನಾನು ಸರ್ ಇಲ್ಲ ಸರ್ ಶ್ರೀನಗರ ನಾವೆಲ್ಲ ತಾಂಡ ಬಿಟ್ಕೊಟ್ಟಿದ್ದೀವಿ ಏನು ಬೇಡ ಸುಮ್ಮನೆ ಈಗ
It was faster to make, and it contains much more detail. But once we could capture this force of motion, our observations became even more meaningful. They also consisted of more data. At first, only 12 or 20 images, but as we increased our resolution, by that experience, small amounts of time and detail, we create a ton of data. The maybe big data is in our DNA, literally. Sequencing the first human genome, reading just about every letter, roughly cost $3 billion in 2001. Today, the same sequencing costs about $1,000. Cheaper, but it might seem to be cheaper to sequence the genome than to store on a magnetic storage device. Beyond the challenges of processing and analyzing all this data, which are huge, a more practical problem: where are we going to keep it all? 100 years from now, it's estimated we'll be storing 42 gigabytes of data every year. Using technology that companies like Google use today, these enough data centers to cover the surface area of 12 Jupiters. But DNA itself might hold the answer. Harvard researchers have been able to write entire books of DNA, and the molecule has the potential to hold petabytes of data, just a few seconds of living material. That doesn't explain how we'll read it, write it, or even store it, but if we'll become data deluge, we will need something new. It might be a whole definition too. This episode was followed by as thousands of courses and tutorials on subject for video animation design, all courses are taught by experts. They have every whether you want to make something amazing, or a new job, or just a better job that you already have, you gotta learn as a course review. It's okay to be smart viewers who get a 10-day trial and access. Just be sure to use that URL to come to research and see you next week.
ಬರ್ತಿಲ್ಲ ನಾನು ಒಂದು 5 ಗಂಟೆ ಆಗುತ್ತೆ ಅವ್ನು ಹೋಗುವಾಗ ಚಿಕ್ಕ ಅಮ್ಮ ನಾನು ಫಸ್ಟ್ ನೀನು ಬರ್ತಿದ್ದೆ ಮತ್ತೆ ಯಾಕೆ ಇವಾಗ ಮದುವೆ ಬರೋದೇ ಇಲ್ಲ ಬಂದು ಔಷಧ ಏನೇನು ಬೇಕು ಇಂಜಿನಿಯರ್ದೆಲ್ಲ ಬೇಕು ಅದಕ್ಕೆ ಇಂಜಿನಿಯರ್ದೆಲ್ಲ ಬೇಕು ಅದೆಲ್ಲ ತಗೊಂಡು ಕಾಸು ಬೇಕು ಹೌದಾ ಸರ್ ಬನ್ನಿ
Welcome to 2018 edition, inspired by the Dream Soccer. It's 1888. The obituary reads, Alfred Nobel, inventor of dynamite, a merchant of death, is dead. Except that Alfred Nobel was still very much alive. We just read his own mistaken obituary. It wasn't exactly matter. So we decided that day that we would leave a different legacy, and so the Nobel Prize. So after realizing that pretty much everyone hated him, Alfred Nobel set aside money in his will to fund prizes that still bear his name today. But with each year they get a bit more controversial. Do the Nobel Prizes still make sense in the 21st century? The Nobel Prize has been awarded pretty much annually since 1901. According to Alfred's will, the men who have conferred the greatest benefit to mankind. The subject of chemistry, physics, is God in medicine, literature, and peace. Win one, and you're known for life as a lord. A nod to the Greek custom of placing a crown of laurels upon a hero's head. Except today, instead of shrug back, a big shot title. But that's pretty much all his will says about it. Like, here's some coin. You guys go to the bank, take interest, take some talented people each year. It's not a whole lot to go on. So the Nobel Prize Foundation, based in Sweden, established a few more rules that Al didn't lay out specifically in his will. First, you have to be nominated by the experts in the field, and you can't nominate yourself. Second, you have to be alive when they award to you, because nobody likes to support shows where somebody shows up to accept on your behalf because they're too recent or something. And third, the prize can go to a maximum of 3 people. And it has to be individuals and not institutions, although they fudged that one a little bit. Now there's 2 more rules than that, but the rest of it. And for the most part, those rules work out pretty well. I mean, the Nobel Prize winners in science are some of the greatest minds who have ever lived. And they deserve to be rewarded. Except for you, young inspector, 1926. You were just flat out wrong. So how do you win a Nobel Prize? Something awesome, like discover antibiotics, like blood, or quantum physics, like Tyson. And make yourself a white male, which 59 perfect. take the question of working harder candidate and see how that's working. Check out this infographic by Georgia Lincoln Research. I've got some pretty eyebrow-raising consistency in who gets the Nobel Prize. Now, I'm not saying these people deserve the Nobel Prize. This is simply raising more than they want just because they're white and male. But if you look at what as far as this year's science, well, sure, since their inception, only 15 women have won Nobel Prize in the sciences, Marie Curie twice, because she's just that badass. Women are underrepresented on Nobel laureates in the sciences, plain and simple. I mean, why do you have to say the name? Do I? Alright, Rosalind Franklin. Okay, they got her next to the town. She passed away in the hospital. One for the double list. But what about Jocelyn Bell Burnell? What about Louise Slater? That's explained. Now, except for the size of the pile of Swedish trumpet you get, much has changed about the awarding of Nobel Prizes. But this begs the question, or questions, is it time to overhaul the Nobel Prizes? I mean, do they really represent how science is done? In the early days of the Nobel Prizes, they were often awarded to lone researchers working on big questions with very little money or equipment at their disposal, which is because most science at the time was done by lone researchers working on big questions with very little equipment at their disposal. This is also the era that gave birth to the myth of the lone genius. Science is not done by people sitting around going, and then coming up with great ideas and just letting hands off and walking away. Science is a slow process. It's not only about creativity, but about collaboration and combination of ideas. My job with creativity was just connecting. Thomas Edison knew that his success was not magical genius, but the product of the severest kind of mental and physical condition. In 2009, a group of leading scientists categories, because it turns out that 1901 is not actually that much today. Take computers, for instance, something that didn't even exist in alphabet. They're kind of important how science is done. And so much of what we do is part of large multinational projects involving thousands of individual scientists and huge projects. How do you give a Nobel Prize to them? Like really? How do you do that? Because they deserve it. Nowhere is this controversy more obvious than in the 2013 Nobel Prize for Physics, more than 5,000 authors appeared in papers confirming the existence of said program last year. Yet, just 2 of the 6 theorists were given the Nobel Prize, which means at least 5,004 people left out of the I don't like having to tell people that Joan Salk got the Nobel Prize because she's going to find the right category. I mean, really help you not get polio. It's not like you can't add new categories. The Nobel Prize for Economics is not actually a Nobel Prize at all. It's awarded at the skill set. Why not Nobels or almost Nobels for math, environment, or computing? The myth of the lone genius doesn't aid our pursuit of science. It fools us into thinking that there's something different about these people that win, like they were born on Krypton or something. I've had the honor of meeting about a half dozen Nobel Prize winners, and they are stunningly, perhaps alarmingly, normal people. One of them is even really weird and but I'm not going to do. Now, there's plenty of other awards for specific subjects, but the Nobel Prizes are as they should represent the best of the world that they reward. The Nobel Prizes are chosen by people, and that means that they reflect the community that rewards them. In the case of women, since they're underrepresented in science in general, their Nobel snubbings are really just a symptom of a greater problem. To the Nobel Prize folks, you've done great work over the past century, but consider this your statement of vision. What legacy do you want to leave? I want to know what you do. Are the Nobel Prizes still relevant? And what should the Nobel Prize in the future look like? And should we have a Nobel Prize? And maybe I could. If you want to know more about the Nobel Prize, check out Molly Oldfield's book, The Secret Museum. There's a link in the description below.
Oh, guys, don't you read the news? You're the universe like a hologram. Everything is connected between machines. Everything you need to know about popcorn, but we're afraid to find out. Large hadron collider and then devouring black hole. Reading breast and prevent cancer. Alcohol more harmful than heroin. When it becomes pregnant in the mouth, ABC with that methylene deposit. Science figures out how cats even as an antidepressant.
Okay, sir.
One thing for years. I know you're thinking, those sound like something I have now. But unfortunately, those are all real science that I've found. I didn't have to look that hard. Some of them are a bit overblown. Some, well, maybe they're pushing an agenda. Some are actually just yes. We didn't know what's good science and what's bad science. You're reading science. That in mind, I'll give you my tips for how to read science. Is the headline the article in question? It's not really right for my feathers or something. Although, there appears to be a sometimes good review. It's different. Don't touch our question. I'm here to answer the question. We're going to go on with wondering things, and you are the one who's going to give me the information. It's really a very simple deal. When you start to run along with a question, it kind of makes you wonder what you're talking about. It's almost weird. Zebra stripes in the street. Explain. Actually, explain or maybe explain. Maybe I understand. Well, after considering number one, maybe it's best to just skip that line altogether. Yeah, skip that line. You know the difference between a press release and current. And really, one is hopefully fact-checked, balanced, analyzes both sides of the story. The other one is marketing material. There's a lot of websites out there that package press releases that look like real news, and it's important that you look different. Press releases aren't untrue by design. It's important you take a big grain of salt. You would go to a car dealership and take the sales report for everything. You kind of go along and do research. I just want to reiterate, because I see this stuff shared all the time. Press releases are not news. Look for warning words. These are the words that will tell you there's a little bit of uncertainty in the article, or maybe they don't know as much as they're letting on. Words like link, correlation, association, possible. Study suggests, or my favorite, scientists were baffled. Scientists baffle all the time, but they don't write research. And they certainly don't sit around with reporters going, oh, you know, what is this? Baffled, but no. You write an article about it? Is the scientific method being applied? Take time to check what you're reading is true, or was it presented at a conference? Is this just some scientist talking to people? Well, why are your reviews promoting science? What about pretty well considered? Good journalists and writers don't research something like a hypothesis. They'll score that work and others for good supports over these, and they'll look to outside sources sort of ask yourself, if someone's getting paid financially for me reading this article, you're reading that news on any commercial news website or advertisement. The answer to that is somebody wants you to read that. That's not necessarily a fact. You need to make money, so it's operation. That's according to the press release, more importantly, are there going to be inside there? The society is so complicated that absolutely just great. That's actually my favorite thing science. Right about it. That should go all they should still apply to critical mind. Honestly, it's all this rework construction research. First, we started out a new breakthrough. It's all to say, like the story. But their ratio of truthiness to height is
Frankly, most stuff in this scenario is made out of heat. But that stuff is here, but you know that. The only thing that's different is that you might do that without it. On the other hand, breakthrough is pretty rare. It's one of these big ones. Here's another one. It's still pure for cancer in mice. Now, pure cancer in mice is the same as Pure a lot of cancer in mice, and unfortunately, not so much. Now, maybe one other, but cancers, that's small, remember when it comes to scare stories and breakthrough stories, you see a lot of people that write something that doesn't make any sense. This story that is nicely with
It's like screaming, what gracefully covered my face. Oh, thank you. Excited as much. Both are I do it. Either that or I don't know spelling. See, you want also your spelling is correct.
Like I don't think the sound you would be true, because a lot of times, well, it is true. That doesn't necessarily mean that it isn't true. We approach every story with balance and surrounding instances. As Michael Shermer says, you should have an open mind, but not so open and frightful. And successful is because access to more information than ever possible. That's really a good thing. But it also means that anybody who wants to go to 2 cents, that is a really good thing of as a result, you continue to cover less and less science than ever before, which is clearly very easy. Or it can be a bad thing. They're all things I talked about before. But unfortunately, it flows uphill, as they say. And the more that writers, journalists, bloggers, wrong. It's the same stuff that's like as a whole. It's like a modern version of James, you're not an expert. Journalists are experts. And find the expert. Some people are way better at this than others. I'm going to put a list of my favorites down in the description. Who are doing it, getting things right, pointing out what's wrong, and every science person really has something like, well, we just have a little bit more information about science, but a lot more experiments to figure out if it's true. And come to think of it, I think science is never true, which is supported by evidence. And well, actually, it's best to don't take anybody there's a process. Yeah. On Twitter, Israel Fernandez asks, which has been your favorite video to make and why? Without a doubt, my favorite video to make was Is Big Data Getting Too Big? Who's dressed up? Cable access host has always been a dream of mine. That's probably the most fun I've had video. And it probably means to track somewhere inside me is a really broken easy, which is exactly what I actually am. And you did an incredible job with the graphics for that one. And here's your lunch in 240p. You might actually get a little VHS video. I also love my collab with Physics Girl and Architect. Chainmail, Lightning, awesome. And my collab with Jake. We saw 3 AI, awesome. Because Jake is awesome. We do really good Star Trek before. Also, our money bracket. You know what? I love all of these. On Instagram, Darwinning21 asks, what is your favorite type of biology and why? Also, what was it like working with Aaron? Working with Aaron was awesome. Aaron is awesome as a biologist. And we recently this was a life-changing experience. Being one of the richest universities on earth. And it was also stay tuned for reviews of groups starting. It would be impossible to think of a favorite part of biology. Wow, far out I can't be favorite because one, I feel it's connected to one of them. It's dimensional axis, genetics, evolution, ecology, physics, chemistry, that's this food makes them possible. It all feeds into this larger story about how life works. I love the whole story, not just one part. On Facebook, Joshua Freshwater asks, what's the most complicated video you've had to make, and was it worth it? So anytime you're trying to index these big, mind-blowing parts of science, yes, that's how it's up. But I think the most complicated I have been, I remote singular, and the most important actually wrote these 2 videos kind of go together well, because they describe 2 of the most important transition points in evolution, coming from bacteria, archaea, to complex cell and parts, and how life cellular things. But also just billions of years out, all of that chemistry, genetics, biology, those story we feel like entire college lives. And a lot of it I didn't learn or fully understand until I was in graduate school. So getting those into a couple of videos was a tough job. It's totally worth it. Those early moments in evolution of life just don't get enough attention. It's some of my favorite writing and research that I've ever done. On Instagram, @REWilliamW asks, what field did you get your PhD in? I got a PhD in cell and molecular biology from this place. I studied gene editing and its ancient weird genetic things that try to jump around inside genome. If you want to know more, I guess I'll put a link to my dissertation in the description. Should be great if you're having trouble sleeping. On Facebook, Wong Lin asks, can you travel to Thor? Yes, in the forward direction of the rate of 170%. One more than that. Okay, so get yourself going very close to the speed of light, or hang out near something massive like a black hole. Next relativity, time will pass more slowly for you compared to someone watching you very far away, which is pretty much the plot of Stellar, and also this recent video from South Street. Backwards time travel? Probably not. We'd sort of have to bend space-time back on itself to jump from one point either now to another, or here and then. It's the old wormhole thing. This is like Kip Thorne, who worked on a lot of science for Interstellar, keep that wormholes, those little theoretical doors that connect 2 different points in space and time, might be able to do this. The math works out, mostly, but it would involve A, a wormhole, and B, accelerating the closest to light, 2 things that we don't do, and which actually might be impossible. On Facebook, Marina that asks, and dogs come. Every day, I know exactly when it's 8 a.m. because my dogs look at me and start whining for breakfast like clockwork. They can't actually use clock, of course, but they can definitely sense time. Lots of animals can. Most complex organisms on Earth, from plants to dogs to birds to humans, have some kind of programmed biological clock we call circadian rhythms. They work a little differently in different organisms, but there's basically genes and cells that respond to things like light and dark, and adjust That's like the day that I recently thinking video, and we talked about how our brains sensing light and dark actually affects our sleep cycle and why we have to sleep. On Facebook, Sandra Thompson asks, what do you think is a superior weapon, a lightsaber or science? Definitely a lightsaber. That's because it's not a tool. It's more than a lightsaber. It's like Gallifreyan Doctrine. It's arguments, creativity, and stuff. Although, lightsaber does have one key advantage. On Instagram, at 13 asks, what's your favorite science fact? If you took all the viruses in the ocean and stopped them and reached 200 million light years, that's like 4 times farther away than Virgo Galaxy was. Totally true. On Twitter, at 1letter2men asks, is a pirate twice likely, or half as likely to win this? Excellent question. First one, Blake loses. I assume the pirate is near me like that. If the pirate is near non-I is near contest, then they have the same chance to win the contest as the non-pirates. I don't know about you, but I always set my eyes ahead. But if there's an eye patch eye, they're almost guaranteed to win. Just ask my old friend, one of them. That's for another Ask Joe Stuff episode. Thank you to everybody who sent in questions. Sorry we didn't get to all of them. We'll lose things. We did get one question from a bunch of, just how many videos? How this whole started? Turns out we're getting rid of most subscribers, which is totally bonkers to me. But if that happens, I think we should make that video. Like the story of all this. That's something you'd like to see. Let me know down in the comments. We will make that video. And now it is time to announce the winner of our challenge question from our first video a few weeks back. I asked, why Jupiter's red spot spins in the opposite direction you would expect it to be in a cyclonic storm? Well, hurricanes are low pressure storms. They're inside, or those effect works. Jupiter's red spot is a high pressure storm in the out in the middle, or those effect opposite directions. Here are the 5 Jupiters areas directly randomly shows that it will be a touch to get you an awesome experience. I'm sure. Science love. Thank you again. See you next time. So what's the orbit? The climate is a complex system influenced by everything from our orbit to gases in our atmosphere to we say orbit compared to what? For most of it, temperature is on ships cross the ocean by nations around the world. But none of this explains the laws. Activity, but it can also be so many other things.
Tomorrow is energy, so we need.
How far? $10 each this year. Learn from experts around the world on YouTube.com.
Since the dawn of time, one question has remained unanswered. Many scientists for thousands of years. And today, all the
all the students of so it depends. I'll call you back. 1 second. I'll call you back.
Yeah, I think yeah, that's very good. I think so. Right one is well. Because it will take time to push them. Let them those are finished lunch. Just after that, tell this way what he goes yesterday. I told him that Santosh and this way. There is a bell let them come inside, set it up. So that we'll start this, then time will be proper. Then time won't take to start without disturbance it will go on. Clear? Fine. So that's great.
I see anyone who must not be in that. I'm suspended.
Maybe one.
This episode is supported by Tony Green. This is a box, and it's empty. Well, not really. We can't see it, but it's still full of dust particles, water, air molecules, and a smaller scale, electrons, photons, and other things. But if we could somehow remove every last bit of matter, could we make that space really truly empty? Is space just an absence of things? Or is space a thing itself? Ancient Greeks gave us the word ether, which is used for centuries to describe space as a thing. Whether space is something or nothing sounds like one of those questions that philosophy majors might like asking. The very nature of reality hinges on this question. It all has to do with relativity. No, not his relativity. Old school relativity. Way before Einstein, physicists knew velocity was relative. To say an object is moving at a certain speed in a certain direction only has meaning relative to other objects. Two astronauts pass each other in deep space. Each can claim that they were aggressive, others moving, and they're both equally right. But accelerated motion is different. Changes in speed or direction, daily experience tells us these seem to have value thinking about other objects as reference units. Isaac Newton illustrated this with a living experiment. You have a bucket of water at the end of a rope. As you twist the rope, the bucket starts to spin. Eventually the water is pushed against the sides. You're probably like, so what? Think about it. The bucket and the water are moving together. All motion is relative to the water being pushed against it. It should be moving relatively slowly. That's fine. We have plenty of options. The rope, Earth. Now, there's a key experiment in space. Don't sudden that water gets you strapped. It starts to spin. You press it against the side. And why? All the bucket is in the still. What are you accelerating relative to? If the answer is nothing, why? You listen.
Presentation one and
just show it. Show me. Madam, this is yes. Copy. Second lunch. Sir, bunny. Yeah. Get this banana.
You must have been. How long? Like I can choose something.
The scenes. Thank you. What about that is true, sir.
The panel is on display. This panel is
Sir, open ಆಗಿದೆ. ಇಲ್ಲ ಇದನ್ನೇ ಆಲೋಚನೆ ಹೇಳ್ತೀನಿ. Somebody was how to get to very good. Very good stuff. Next. Okay. I haven't seen which passions. Sorry. Just before we came. Yes, just before we came. You know the can you talk more about it? I couldn't find information about how did you consider okay. None see Dr. Vijay. Using DNA immune properties. So everyone knows that DNA has additional properties. So we are trying to tap those additional properties in order to quantify and differentiate. So you would not just to run a spectrophotometer, no approach. That we are actually 150 start so what technique are you using to guide it? We're still figuring that out. So that's why the big grant has come in. It's supposed to get the POC right out by 15 months. That's everything.
Okay, very, very good. Looking very sharp.
Talk more about it. So we are interested in the electrical properties of bacteria and viruses. We should talk a little bit more.
Yes.
So you gave me a little more idea on how I can skip because I'm looking to do the process but the thing is do a PCR. So why don't you mind skip the PCR? Put the madam's slide. Now display I'll come back once the workshop starts. If the conductors have any issues, set it up for them, like it's been missing, then they'll come. Oh, very nice to be here. Very nice to be launched. What is
Welcome back. As said by Thomas Alva Edison, many of life's failures are people who did not realize how close they were to success when they gave up. Good afternoon to one and all present here. I, Vandya Rao of 4th semester BA Biotechnology, have the pleasure of taking you all to the second day of the session. We will begin the session with an expert lecture by Dr. Vijeta J. from Sidecare Cancer Hospitals. May I now request Mrs. A. Nivedita to kindly introduce Dr. Vijeta J.
Good afternoon all. Dr. Vijeta J. did a MBBS in Bangalore Medical College and Research Institute and DNP in Radiotherapy from Bangalore Institute of Oncology. She has a professional experience as a senior resident
in YDE Medical College and Research Center for a period of 3 years. She has worked in various contouring systems, including Plato, Eclipse, Vivista, Monaco, and Oncentra. She is also well versed in brachytherapy applicators like Fletcher Suite ICPT applicator, ISPT with Science Neglect, and MUPIP template, IC/ISPT with Science Neglect, and Vienna applicator. She has been expert assistant for MD radiotherapy examination for 4 batches of students. She has been active in all the academic activities during the senior residency. She has 4 publications to her credit. On behalf of the organizing committee, we welcome you, ma'am. Thank you, ma'am, for the
Hello everyone, good afternoon. It's just a 10-minute lecture, so I hope I don't bore you too much. So let's see about how radiation is used in cancer treatment. So once I tell the word radiation, what do you think of? It is about Hiroshima and Nagasaki. So it caused a very bad effect in the human race, including deaths and hereditary genetic abnormalities. So what were the characteristics of this radiation? It was given in a very high dose, which was even not measurable. So, and it was a single continuous exposure, and the entire body of the human was exposed to a very high dose. And the effects were obviously catastrophic, including the immediate death and also DNA mutations, which lasted for a long time, and many generations suffered with cancer and hereditary genetic abnormalities. So how do we use this same radiation to for the benefit of human race, like in curing cancer? So to change these effects, we have to change the characteristics of the radiation. That is, instead of making it a high dose, we have to give a small dose, and we give it in not in a single exposure, but in a multiple fractions. And instead of total body exposure, we give it to a small area of the body which is affected by cancer. So by changing the characteristics of the radiation, we can make the effects more beneficial. This is how we use radiation in cancer. So let's just have a small look at physics, specialties, and biological effects of radiation, including the clinical uses. So radiation can be ionizing or non-ionizing. So can anyone say what is the difference between these two? So the name says it all. That is, the ionizing radiation can cause ionization in the body cells. So the ionizing radiation definitely will have an effect on biological tissues, whereas non-ionizing radiation will not have any effect on biological tissues. So which one shall we use for radiation? Ionizing, okay, which can cause damage or which can damage the cells. So what is ionizing radiation? So a part of ionizing radiation comes from electromagnetic waves. We all know from our 12th standard physics that electromagnetic waves include a huge spectrum from gamma rays to radio waves. Gamma rays, X-rays, ultraviolet, visible light, infrared, and radio waves. So we can see that the wavelength is increasing as I go towards my right hand side. So as the wavelength is increasing, the energy decreases. Okay. So radio waves will have more wavelength and less energy. Gamma rays on the other end of the spectrum has less wavelength and higher energy. So for the ionization to happen, energy should be high. Hence, these X-rays and gamma rays are ionizing radiation, whereas ultraviolet, visible light, infrared, radio waves, these are non-ionizing radiation. So which one do we use here? Gamma rays and X-rays. Okay. So this is just summary of what I said. We use ionizing radiation for radiotherapy, and a part of it is from the electromagnetic spectrum, and majority of it is X-rays and gamma rays. So we also use particulate radiation. This is only electrons are widely used, whereas these alpha particles, protons, neutrons are not used here, at least in India till now. So our major discussion and major clinical applications is for X-rays and gamma rays. So how do we get these X-rays or gamma rays? So sources of X-rays. So basically X-rays are got from X-ray tube, which is the heated tungsten filament, and the electrons are released and it hits the tungsten target and releases the X-rays. So basically this is the same X-ray tube which is available in different machines. So where do we use this X-ray tube? Either X-ray machines or in the CT machines, or this is a linear accelerator through which we are delivering radiotherapy for cancer patients. So it is used either in diagnosis or in therapy. These two are a part of diagnosis and this is part of radiotherapy. Okay, so basically the same X-ray tube is used in all the three machines, but the energy of the X-rays varies from this to this to this. This is in the range of kilovoltage range and this is in the range of megavoltage. Okay. So sources of gamma rays definitely are radioactive elements and which are used in brachytherapy. I'll come to it later. So in radiotherapy, we have two main types. That is the teletherapy and the brachytherapy. Tele means what? So some radiation is coming from a distance. So this is the patient and at a distance, the radiation source is kept and it gives radiation. This is called teletherapy. And this is called brachytherapy. This white thing is the patient body and this dark tube inside the patient is a brachytherapy applicator, and the radioactive source is passed through this tube, treats the tumor and comes back. So this brachy means it is at a close distance. So radiation source is at a very close distance to the patient body. This is brachytherapy and this is teletherapy. Biological effects of radiation. This definitely you people will know better than me. And any radiation can cause small damage to high-end damage. Small damages like the single strand breaks in the DNA can be repaired immediately, whereas double strand breaks, which are very close to each other, will be irreparable. So what happens? DNA is a target site for radiation damage. So what happens when any DNA damage happens? So many of us undergo CT scan or X-ray. So it doesn't mean that we are badly affected all the time. So most of the times, if DNA undergoes repair mechanisms, which is usually very good in almost all the healthy individuals, and patient will be normal without any effect. And sometimes the repair mechanisms they do some sort of mistakes, and the DNA bases get changed, and it leads to mutation. So if the mutation happens in the somatic cells, it can lead to cancer, and if it happens in the germinal cell, it can lead to heritable genetic diseases, or it can directly lead to cell death, like radiation reactions, cancer cell death, or the death of the patient. So whatever I have highlighted in red are the harmful effects. Whatever is in black is something which is a part of the normal treatment. And as I said, in teletherapy there are various treatment planning techniques, including the 2D radiation, 3D CRT, IMRT, or VMAT. So this is a 2D plan. This is a target area that we want to treat. It is in this shape, inverted C shape. And this is the area which what we want to avoid radiation. And red is the area that is receiving a good dose of radiation. Okay. So in 2D planning, earlier days, if we want to treat this C-shaped area, the entire area till here, from here till here, from anteriorly from here till here, the entire box received full dose of radiation, and we could not spare the normal tissues, which is lying here. So then came 3D CRT. So this is the red area which we want to treat. So the distribution was like a box. So some amount of radiation still went to normal structures, but still outside areas could be spared. This is called 3D CRT. And then came IMRT technique. See here, there is a yellow spot which is a low dosage area. So we could spare the normal structures really well here with the IMRT technique. And here came VMAT, where we could see a nice C-shaped distribution of the dose. Hence, the radiation has evolved through the years from 2D to 3D CRT, 3D CRT to IMRT to VMAT. So where do we apply radiotherapy for clinical use? Basically in treating all the sorts of cancer, head and neck cancer, brain tumors, esophagus, stomach, lung, cervix, endometrium. And there is a specialty of radiation that we can also use in benign tumors, like in meningioma, schwannoma, and trigeminal neuralgia. So this is the machine that, which we have in side care cancer hospitals. This is Electa Versa HD, and it has all the latest techniques from 2D, 3D CRT, IMRT, VMAT, and also stereotactic radiosurgery. So I will conclude here. Thank you. If any of the workshop participants are here, registered workshop participants, please move to room number 017. I take this opportunity to thank our event sponsors, AICTE, ICMR, Himalaya, Aspartica, FNDR, Sidecare, SBI, Monsanto, Karnataka Antibiotics and Pharmaceutical Limited, PBC, CIII, ISTE, Ozone Scientific, Siddhartha, Cital, Airlift Container Line, Zastra Innovations, BBN Instruments, Foresight. Now I request Dr. Sridhar Narayanan to occupy the dais. I now request the panelists to occupy the dais. Mr. Manjunath Ramarao, Dr. U.P. Babu from Himalaya Drug Company. Dr. Vijeta J from Sidecare Cancer Hospital. Mr. Kashif Sharif from Mercury Biotechnology. Dr. Manjunath Ramarao and Dr. Vasanti Pannivedan will be joining us in a while. Now I request Mrs. A. Nivedita to introduce the chairperson of the session, Dr. Sridhar Narayanan.
Good afternoon again. Dr. Sridhar Narayanan, currently Director at NPR, has more than 12 years of experience in drug discovery and development in the Indian pharmaceutical industry in various therapeutic areas. He holds a basic degree in pharmaceutical sciences, a PhD in pharmacology from Ohio State University, and has postdoctorate in neuropharmacology at the University of California, Los Angeles. He has been the Executive Vice President, Discovery Biology and Drug Development at Orchid Chemicals and Pharmaceuticals. In this role, he has been responsible for the design and implementation of the scientific and business strategy for drug discovery and development across therapeutic areas, managing a team of scientists in biology, DMPK, safety pharmacology, and regulatory toxicology and clinical development. Recently, he was appointed Vice President and Head of Innovative Science for the infection at AstraZeneca India and led the discovery and development of 2 potential clinical candidates in TB and malaria. Now I request Sridhar Narayanan to introduce the other panelists and take over the proceedings.
Thank you, ma'am, for the kind introduction. That's what happens when you don't update your LinkedIn profile or your CV for a very long time. Right? So it's been a long time now since I've quit AstraZeneca. 3 years since I've started my own organization now called the Foundation for Neglected Disease Research. And I'm very happy to say that we are located here on campus. So MBIT is the organization, the university which has incubated us for these last years. So I'd like to introduce my panelists. A warm welcome to Dr. Manjunath Rao. He is the Group Director and Head of Discovery Biology and Translation Sciences at Bristol Myers Squibb. Dr. Manjunath holds a degree in chemistry, botany and zoology, a post-graduation degree in biochemistry from Bangalore University, a MS in physiology from the University of Illinois at Urbana-Champaign, and a PhD in physiology from the University of Illinois Urbana. He has a rich experience in applied biotechnology, disease sciences, and technology. He was also the principal research investigator in wild research for 8 years. He has worked in the capacity of instructor in Harvard Medical School for Neurobiology and a postdoctoral fellow in the Harvard Medical School for 3 years. Please join me in welcoming Mr. Manjunath. Dr. Yuri Babu is currently the head of phytochemistry at R&D of the R&D at Himalaya Drug Company. Dr. Babu holds a PhD in organic chemistry from CBRI Lucknow, which is a premier drug discovery lab of CSIR. He has 18 years of experience in natural products and drug discovery. He is the recipient of the Research Fellowship from Department of Ocean Development, New Delhi, a Senior Research Fellowship and Research Associateship from CSIR, New Delhi, and has extensively worked on marine organisms and terrestrial plants. He has been part of boards in various academic bodies, universities, and research councils, and has more than 20 international and national publications to his credit. He has contributed around 60 global and national patents, which is no mean feat at all. Dr. Babu has been working for cultivation of medicinal plants and sustainable supply involving small-scale farmers, women groups, and NGOs, so as to strengthen the backward integration, biotechnology, tissue culture, and quality research in herbal drug discovery, including natural and organic cosmetics. A very warm welcome to you, Dr. Babu, and I look forward to your views in this panel. Mr. Kashif Sharif is the co-director of Mercury Biologics. Kashif is registered with the Ministry of Corporate Affairs and is currently associated with Mercury Biotechnologies Private Limited, a company which recently won the Indo-Israel Innovation Award. Mercury Biotechnology is located in the Bangalore Bio-Innovation Center at Electronic City, and is a proud alumnus of MBIT. So big hands for our. And last but not the least, Dr. Vijayta from SiteCare Hospitals, who we just heard about. She's a radiation oncologist at SiteCare Hospitals, and she presented a beautiful introductory lecture on what X-ray and gamma radiations do for us, and the different instruments that are being used today in the treatment of cancer. So very warm welcome to you, madam. We're waiting for Dr. Basati anyway. I'll just finish her introduction as well so that the panel discussion can continue as such. She's a co-founder and chief scientific officer of InnoForesight Health and Biomedical Systems Private Limited. She was the senior scientist at Project Loan Bioservices for 3 years and has been the project leader for Avestagen Limited, Bangalore. She was also the research associate for Central Agricultural Research Institute, ICAR, Andaman and Nicobar Islands. She holds a degree in BSc in microbiology from Bharatiya University, MSc in biotechnology and immunology from Periyar University, a PG diploma in molecular biology and biotechnology in the gene tech, and she holds an MBA in pharma management in the IPA University. Dr. Vasanthi Pandive is a gold medalist in both BSc and MSc biotechnology. So when she comes, we give her a warm round of applause and welcome her. But if there was ever a dream team which somebody wants as a panel group, I have the dream team with me. So big round of applause. So, what I would like to do is start the panel discussion with asking each of my panel members to talk a little bit about their own organizations and the kind of work that they do within the organization. Just to give you a brief insight of where they are coming from and how their views can actually help shape your business. Let me start with Dr. Babu on my right.
Good afternoon. This is a panel discussion, so I would like all of you to interact when we discuss, when we put our views. So I would like to request all of you to interact as much as possible, whatever is there in the mind. So hopefully any one of us can answer all of the doubts here today. I belong to Himalaya company. Our company was established in 1930. There was a fascinating story behind the establishment of this company. Today we are more than 90 countries across the globe, and our vision is to spread wellness through the herbal healthcare. Okay, we have four verticals. The main core of our company is the pharmaceuticals, and then having an experience of herbals and pharmaceuticals, then we translated our food into the personal care, and then we are into the animal health care and nutrition. The Himalaya company was the first herbal company, I can say the first company in the world which introduced as an anti-hypertensive drug in 1934. That was the only anti-hypertensive drug at the time. The founder chairman of this company has found, when he was traveling to Burma, he found there is a herb which is feeding to the very aggressive elephants who used to work in the forest. So he amazed to see that what is there in that herb that is calming the aggressive elephants. Then a lot of research has gone into this, and then we found it's a huge potential as an anti-hypertensive. That is nothing but Robert Pia circuit. So once the Himalaya company has launched an anti-hypertensive drug, as we know as modern scientists, there's a lot of research has been done on this, and then finally a compound known as rizopin is isolated, and a lot of research has been done, and rizopin itself has been introduced as an anti-hypertensive for different various indications. Then it started showing as usual, a lot of side effects. Then here also there is a story of believing the traditional ancient wisdom called Ayurveda. Before I go into touch upon, just I would like to give some statistics today. If you know about the overall drug, because today the panel discussion is about pharmaceuticals and healthcare, so if you see what is the drug, that molecules or a tablet that you buy from the stores, on an average, it takes about 12 to 14 years a drug to be developed and successful. You start from the in vitro or synthetic chemist, approximately starts about 10,000 molecules, which may fall into 6 to 4 or 10 molecules in the clinical, and either one may be successful or not. The overall expenditure of the drug development today is about $1.2 billion. No company in this world can afford such a huge investment in drug discovery. So there are many MNCs which are working in the drug discovery, starting from base to the clinical trial. But there should be a lot of collaboration, that is interdepartmental, like industry and academia collaboration is much required. So while we are seeing today the pharmaceutical industry globally, including the biologicals, is about $800 billion market today. Then you can see for the last 2 decades there is a huge paradigm shift. People are now want to be seen to be more wellness, look healthy and beautiful. So we have more awareness towards our health and wellness today. That's how the herbal spectrum came into the picture. Now today you talk about dietary supplements or nutraceuticals or functional foods. It is being taken up slowly, and today it's about $450 billion as compared to the conventional drugs of $800 billion. It is expected that by 2050, it is touching about $5 trillion of the market of wellness. That is not like that. You have a disease, you buy medicine. It's not like that. To maintain your health and wellness. Because across the globe, everybody is now today aware how the drug is manufactured, what are these ingredients involved in this, what is the safety, etc. and all this. Now I would like to give you 2 examples, then I will share with them. Now when we started anti-hepatitis drugs with the single herb, and there are, if you talk about the herb, there are multiple compounds, okay? It may be hundreds of molecules in this. So what happens out of curiosity is the chemist try to purify those molecules and getting a pure molecules. Idea was to develop as a new modern medicine. As you all know that once you develop a drug, there will be always a possibility that it has got side effects, or it is not bioavailable, or it is easily absorbed. So that you have to do a lot of formulations. Like first of all, you try to ensure that it is safe and it is bioavailable, and then you will do all sustainable period release and all this stuff. Nature has given us an absolute balance of these small phytochemicals in the herbs. So it is up to the science or scientists or biotechnologists who like explore and maintain a balance of what are the compounds in the nature that has given us as a therapeutic agents, and what are the compounds that requires for improving the bioavailability. And a whole, the herb, when you use natural, that should be absolutely like a modern medicine. This is the art of science, that how we can explore and use the best benefits of nature's product. So in terms of biotechnology is concerned, and how the biotechnology will help in the drug discovery. So more towards the plant biotechnology. Today, give you a backdrop of an idea for, we have 17,000 of flora exist in this country. Okay? And you look at this, about 950 herbs are mentioned. You talk about Ayurveda, Siddha, Unani, all our traditional medicines. So once upon a time we had 950 herbs used in this formulations, okay, which we have used for this. Now today you won't get even 200 herbs if any companies like the small company or like companies like us, if you want to explore the research done by the college and the university, the biggest problem is how you will get source of this particular herb. So that means a lot of these herbs have been in the endangered list. There is a lot of rural biotechnologists here. If you see, as I said, $400 billion market in the world, the India's contribution is only 2 to 3%. So where the China is much more, but still we have a huge potential here. While this discussion move on, we can discuss further. But as Prime Minister said that we should aim at Make in India. If we have to look at the Make in India, the herbals or the nutraceuticals or dietary supplements, that is where which will take India into the next step, and we can explore. And particularly when you talk about drug discovery or in contrast to the herbal drug discovery, all sciences starting from an agriculturist to the biotechnologist, starting from a small chemist to the engineers, everybody was involved in this. Thank you so much. I expect a lot of queries from you.
to Dr. Babu for the good introduction into drug discovery and development and what Himalaya has been doing so far. I now request Dr. Manjunath to talk a little bit about his experience at BMS.
First of all, I want to thank Dr. Srikant who is my friend. And thanks to all of you for organizing this event and having all this here. So, probably some of you might have already heard what I do, but just to quickly give you an introduction to this. So we are a pharmaceutical company. It's an American company called Bristol Myers Squibb. We have a collaboration in India with Biocon. So it's called as BMS Biocon R&D Center. It's located in Bangalore. While the collaboration initiated with Biocon dates back to 1998, it was mostly CRO type of collaboration. In 2007, BMS decided that we should establish a full-fledged R&D center in India to do our drug discovery. So this is, by the way, one of the 4 innovative R&D center for Bristol Myers Squibb. 3 of them are in the United States. The only other R&D center is in Bangalore. So it means a lot to India and to Bangalore specifically. Why did BMS choose to come to Bangalore? Obviously because of the town. So that's you, right? Today we have 650 people working in this R&D center. Right? There are more than 150 PhDs, and the rest of them are divided mostly between master's level, MSc, and pharma. And as you probably know, last year we ventured out of that system and we took 6 of your students into the BTech students into our unit, and they're doing a fantastic job. So it means there's an opportunity for everyone. Now, why is there an opportunity? We are going to grow. As probably some of you might have already heard. We extended our contract with Syngene, with Biocon, for the next 10 years. And today we are 650 people. The next 2 years we are going to grow to 790 people. So those are your opportunities, right? And I really would like to see many of you take this as a way to reach out to us and see if you're interested in what we do, right? I can tell you what we do briefly. As I said, it's a novel drug discovery center. And we have the capability and capacity to do end-to-end research. That means we start with an idea, a hypothesis, take that idea all the way to drug development, right? And am I just saying that we can do all these things? Actually, no. The reason we got another 10-year extension into this is because we've been extraordinarily successful. In the last 7 years, 2009 is when we actually built this new building and we started this center. In the last 8 years, we have discovered 12 new drugs and molecules. 4 of them are in clinical trials in the United States. So these were actually discovered, these were ideated, these were everything that we needed to do to discover a drug in a pharma industry happened here in Bangalore. Right? So that means there is talent. We can certainly do it in India. We can do at the same quality, probably even higher quality than anywhere else in the world. So what it means is you should explore such opportunities, and I know that we are already providing one fellowship to one of the students. Hopefully we will continue to do that in the coming years as well. These are all your opportunities, and as Dr. Babu and Dr. Narayan said, I would like to hear from you. What are your thoughts? right? What is it that you want to do? If research is in your blood, is what you want to do, and drug discovery interests you, again, don't worry about what area you're looking at, what specialization you're looking at. You need to be have. We have electrical engineer to automation engineer to biologist to biopharmaceuticals, genomics, proteomics, chemistry, medicinal chemistry, organic chemistry, bioinformatics, computational sciences. You name what you're good at, what you want to do, most likely we will have something for you, right? I think, as I said, this is one of the few R&D centers in India involved in novel drug discovery, and it's a fantastic opportunity. And for all of you being in Bangalore, it cannot be better than that. Okay? I'd like to hear from you as well. So, it's all.
And congratulations on some of the great achievements that are happening. And we look forward to not only 10, but many more years of continued presence in Bangalore and continuing of supporting MBIT and other biotechnology students from your organization. So thank you very much for that. Dr. Vijay, if I can request you to talk a little bit about site care and the personalized medicine aspect, right? That would be very helpful.
So ours is around 100 to 200 bedded hospital, and it is exclusively for cancer care patients. And we have usually, as all of us know, cancer is mainly treated by 3 modalities, that is a surgery, chemotherapy, and radiotherapy. So what happens in cancer, in site care cancer hospital, is that there is an additional comprehensive cancer care oncology team, which includes palliative and pain specialists, and nutritionists, and patient navigators, psycho-oncologists. So there is a team which talks to each patient and delivers whatever is required for a person, as a patient, as a person. And we address not only the individual or the patients, but also the entire patient's family, because they are in as much distress as the patient most of the times. And so and what we study in our textbooks while doing our post graduation, not every patient comes with a classical stage and classical diagnosis. Sometimes it's like 2 tumors are there. Sometimes it's like very atypical histopathology that we get. So each case is discussed in the tumor board, where all 3 specialties along with comprehensive oncology team will be there. And we come to a multidisciplinary board. We come to a conclusion that which treatment has to be given to each patient. So,
thank you, Dr. Vijay. And for those of you who are not familiar with what site care is and where they are located on not very far from here, about a few kilometers from here. And they are probably one of the only cancer hospitals in this region of Bangalore, in the northern part of Bangalore, which is one of the most developing suburbs of Bangalore. So thank you very much for that. And last but not least, I'm sure all of you are tracking the Under-19 World Cup. How many of you are tracking the Under-19 World Cup? Really? Come on, that's great. So today we beat Pakistan. Come on. Massive 200 plus run victory over Pakistan. I don't think we could have asked for a better start to the year for the Under-19 team, right? Anyway, they play Australia in the final. I'm an absolute cricket fanatic. So now I want to talk to the Under-19 person of the panel, Kashif. I think Kashif, what I'd like you to talk about is your experience as an entrepreneur, and also a little bit about the India Israel Innovation Award that you got. Yeah.
Hi, so thank you for that really nice introduction. But I'm definitely not under 19, so that is but comparatively to all the most experienced people on the panel, I am the youngest here. And few months back, I think I was on the other side, but now I'm on this side. That is mainly thanks to our HOD, the G. Nagendra, who's always been a constant support and useful. So that shows how much you are, not only Nagendra sir, but also all the lecturers who have been there. They've built that constant backbone of support that you require to actually go to what you want. Because without the support and the open lab setup that the facility gave, I wouldn't have been able to try out all of my different ideas or whatever. Because the ideas that I proposed initially were so outrageous because people are like, why hasn't anyone done it? So, and they're like, why are you doing it? You're so young. Can you do it? Is the first question that anyone asks. But the support that comes is from Dr. Nagendra sir because when you tell that, see, this kind of a person is supporting you, he believes in you, it takes you a really long way. So always go back to your lecturers, discuss whatever it is there, get your foundations right because those foundations are what going to carry you all the way through even till the end. It doesn't matter how experienced you are, you can ask all the panel members here, those foundations are what come to you even in the end also. So that is the most important thing that is always there. I keep telling my juniors also, focus on your foundation, polish them, but I don't know why it doesn't get to you people. But yeah, so coming to what I work on. So my idea was basically, let me go a little bit slightly into the biology side. So we all know about DNA and DNA technologies. So you all run agarose gel electrophoresis and at the same time spectrophotometer and all of this. So I'm pretty sure all of you would have been cursing when you had to cast those gels because you are like, how long do I have to cast the gels? I have to wait for it to finish and then I have to load, then it has to run. So this is a pain. Honestly, it is a pain. Spectrophotometer was also a pain because you need like a huge amount of sample to actually run and get accurate readings. But then Thermo Fisher came out with the nanodrop and simplified the whole process. They do have some drawbacks because they're an optics-based technology, but then it was much faster. So what I set out to do was I tackled DNA with the DNA itself. So generally what everyone does is they go roundabout method called the fluorescence method, where since you cannot visualize DNA or use DNA directly, you take a fluorescence molecule, attach it to DNA and then say that, oh yes, DNA is there. But the problem with the fluorescence molecule on its own is it will also fluoresce without the DNA, right? So there is always an issue of whether the DNA is there or not there. So that is one of the issues. So what I tried to tackle was, we all know that DNA is negatively charged because that's how the whole agarose gel electrophoresis works on. So what I did was I picked up the negative charge of DNA and then I dwelled deeper into the electronic side of it to figure out whether I can tap this property of DNA in order to quantify DNA. So that was the main thing. But as I started doing it, quantification was the easy part. So when I went back to a lot of mentors like Nagendra sir and so many other people who have helped me throughout the entire journey, so everyone were like, quantifying is the easy challenge because your first challenge would be you have to build nanodrop. And that is okay because you might say you have a different technology or this thing. All of that, okay, fine. But then still, you have to go one more step ahead to differentiate yourself beyond everyone who's out there. So how do you do that? So one of the biggest challenges that people kept to me was, can you differentiate DNA based on size? If you can do that, that becomes a completely revolutionary technology which no one has worked on. So then it started. So I'm here after almost 3 years of struggle. I've jumped for internships in 2 or 3 companies. I worked in Aspartica here. I worked in a company called Azuka Life Sciences. Previous to that in Biotechnologies. So I've been through a long journey to come here. But it's been almost a 2-year journey in which I've developed this technology and come here. So the base of the story is you need a lot of patience in this field. It's not like IT that, oh, I came up with an idea today, in 1 week's time it's ready. That doesn't work at all in this field. We're all biotechnologists. So the core for us is patience. So you have patience, you can definitely do it with a lot of guidance that has always been given. So the other thing is also what I would like to say is, so coming back to the thing, so they were like, can you differentiate DNA? Because differentiation of DNA goes a long way because that is the main crux of the entire problem. Because let's say I put it into this is where the Indo-Israel part also comes in. Because the Indo-Israel challenge was a rural diagnostic scenario. So how do you translate a technology to a rural diagnostic scenario where you can apply this so that it becomes easier for them? Because if you go to the villages, all of us are from here, so we know the state in the villages that they have to travel a long way in order to get any of the diagnostics done. And that's a hard thing to do. How do you take diagnostics to them in the village? So the problems with the village is you don't have infrastructure, then they don't have money, then at the same time, you cannot use sophisticated equipment there. So the biggest problem with agarose gel or your nanodrop would be the optics. Optics cannot work in such an environment because they are very sensitive, delicate instruments. Then the agarose gel, as you all know, it's very hard to do. You cannot do that in a village setup. You need an entire full-fledged lab setup to do. So what the proposal was that I proposed to the government of India was, I told them that, see, if I can detect and differentiate DNA based on its electrical properties alone, how hard is it for me to integrate it with a system like a PCR? So once I can integrate it with PCR, what happens is the number of cycles that PCR has to run for the entire amplification to be noticed is also cut short. So what happens is I can theoretically, as of now, there is a little bit of practicals that has been done, but I can actually detect the amplification of DNA within 5 to 10 cycles. And that itself is a big leap ahead. And along with a lot of help from a few of the other, from FNDR also, I have got certain suggestions where if I can tap into the hybridization side of DNA, we can even eliminate the entire process of DNA. Since it's electronics, I can take it anywhere in any kind of scenario, you give it a little bit of battery power, and it works anywhere. So that way, I tackle almost all the problems that are associated with the rural setup, but I can take the solution straight to the people who are most concerned with it. So that is the main thing. So this is what the entire pitch of the Indo-Israel challenge was, and this is what is recognition that the government recognized and said that yes, this is a potential technology which we could actually try and get few more technologies from Israel, do a collaboration if possible in the near future, and see if we can help not only the Indian population but the entire world's population, because this can be applied anywhere in any kind of DNA-based technologies. So this is what is the background of the entire technology that I work on, and all of this would not be possible without Nagendra sir, so due credit to him again. Thank you.
Thank you very much. I think you are not the only person who's being bit by the entrepreneurial bug in this campus. My journey in entrepreneurship also started on this campus with my interactions with Professor Nagendra. So a lot of credit goes to him for us coming on campus as well. Might be a little late in life, but still you've been bitten by it. Never late. So, want to welcome our panel member, Dr. Vasantika anyway. Dr. What we've just done is we've gone through a round of introductions and talking about the organizations that the panel members are coming from. So if you could just give a few minutes of insight into the kind of work that your organization does, it would be very helpful.
Good afternoon, everybody. So I'm Vasanti Padnivel, co-founder, chief scientific officer of Foresight Health and Biomedical Systems. I take this opportunity to thank Nagendra sir for giving me this opportunity to be with you people today. Foresight is into it's a fraternity tech company. So we are a technology aggregators. We aggregate technologies from biomed, from medical device, biotechnology, bioinformatics, and we create a solution for infertility. So right now, we have a solution which is up and running. We have already implemented this with IVF experts. So this is a regenerative medicine-based solution. We prepare a protein concoction from patient's blood, which will be again infused into the uterine cavity or ovary or the testicles, wherever the problem is, and so it will naturally correct the defect by promoting the natural way of regeneration. This is the overall thing. So we have got a government grant to develop this as a product. We have concluded a 450 patient preliminary trial, and then we are moving on to a full-fledged clinical trial in next month. And this is where our journey, and happy to share that we are also the Indo-Israel Innovation Award winner. So there it is more of the award was more for a digital health innovation where we aggregate all these technologies. So patients come in and take the treatment with sitting at home, so they don't have to like go through social stigma or whatever associated with infertility. So this is what we about our company.
Thank you very much. So the challenge of being a chairperson is how to steer the panel discussion. So I have a list of questions with me which I can ask the panelists, but I would prefer if we open the floor to discussion first, based on what you've heard from the panelists. If you have some questions, maybe we can start with that, and if time permits, then I can go back to the questions that I have for the panelists. Is that okay with all of you? Yeah? Half of them are asleep? No? Post-lunch syndrome. Come on, students have to be, the reason why we came to the campus was that this is a place which is buzzing with activity, right? It has to be vibrant all the time. I mean, there is nothing called as a stupid question. It's absolutely fine. You can ask anything. And I have a list of really stupid questions which I want to ask them, but I'm holding off. So if you don't ask, then I will start. Yeah? So all yours.
My question. Okay, so Kasha was talking about DNA and electrons and stuff like that. So it's being negatively charged and all that. So the question. Okay, so it just struck my mind right now. So I'll just talk what is on top of my head. I haven't done any research on this. Do you think the same can be applied to proteins, and do you also think that this, because we can find out now the exact charge of the electron, can we use DNA like chips instead of silicon like chips? Both.
I have two questions, brilliant questions we've already asked. So, me and Nagendra sir have already discussed almost all the questions related to this. So, I luckily have all the answers, at least most of the answers that you could ask for. So, to proteins, yes, because I have done a few bit of preliminary studies with the same thing with proteins. And as far as we are saying is, we are looking at the clinical interaction of proteins, so more towards the antigen-antibody interaction wise. So we are in collaboration with a company called Indoor Biotechnologies that is there in BBC itself. So one of the main things that you have to understand in biology is you cannot do anything individually. Trust me, I've learned it the hard way because I have worked the entire time alone. So it's very hard to do it alone. So you need collaborators who are specialized or specific in their domains of expertise. So I'm not a protein guy. So I go to the protein guys and I'm like, see, this is the idea. Can we do this? And they gave me samples, they gave me everything on their own, this thing, and we have tried it out, and it works. It definitely works, but the thing is, it's a long ways down the road because no one knows how it works, what's the mechanism, why, what, nothing is known. So it takes a long time to do, but yes, we are exploring those possibilities also, and it does work. To the second point that could you do DNA into an electronics chip to replace it? Yes, actually, if you would consider there's something called Moore's law. So Moore's law says that a particular item can only go down to such a level, and that is what your silicon chips have come to. They have hit the basic base of the Moore's law, so they cannot go smaller than this. But that's where, if you go to the atomic level, because DNA is nothing but it goes down to the atomic level and molecular level. So there, once you go down to that and you're able to engineer chips with DNA itself, quite possible because DNA is a well-known documented capacitor, and also DNA is also known to be a very good known transistor. So that, how, don't ask me because there are papers, a lot of people are doing research on it, but that is more into it, that's full of electronics and all of that. But yes, it is possible, but not immediately. It will take some time because there are people who are trying to integrate it, but it's not as simple as it seems. Because to get the silicon chip to the level it is, it's taken us so long, and suddenly we cannot jump into a directly into an atomic level or anything, but it is possible. It will happen in the near future where your electronics will become even smaller than what it is there today. So yes.
So in that scenario, can we say that the DNA, everything which is stored in DNA is in thousands and will not between kidneys, those stuff is it. So can we study the atomics of the hybridization of these bonds and see how the message is being stored and probably correlate it to electronics?
That's already been done, right? Because if you take example of Amazon and Google, they are the topmost companies that are actually working on this, how to do data storage using DNA. So that is what they're burning millions of dollars in order to get the answer to this particular question. And it is being done by Google and it is being done by Amazon. So they are both are the leaders in this technology. It's being done.
We have a question there.
Everyone, my name is Sandeep Kumar. I am a student of technology from River University, Bangalore. So my question is to Gita ma'am. And you were talking about cancer treatment processes like surgery, chemo, and radiation. So as I have read to, as we heard about melanoma, it's a acute tumor in the brain, and I have also heard that that process cannot be surgically operated. So, can you tell me what are the critical conditions that can be used to treat that kind of cancer patients?
See, brain is a critical structure. Okay? A meningioma, if at all, theoretically, it's somewhere in the skin. Okay, it need not have to be treated unless you are cosmetically worried about it. Okay, but something which is inside the skull, it will only increase the pressure inside the brain, and it will affect the entire brain functions. And first, it starts as a local symptom, like somewhere in the occipital lobe. Occipital lobe, we all know that the vision is controlled by that. Okay, so some meningioma which is close to occipital lobe will affect the vision. So because of its critical position, we have to treat it, even though it is not systematic. But anywhere else, okay, it is not causing any symptoms for the patient. We can still observe. We can ask for an MRI every 6 months. We can keep a closer follow-up. Suppose at some point we think that it is growing or it has started causing symptoms to the patient, then if it is surgically inoperable, we can directly treat it with radiation. But the only problem with radiation is it will not immediately shrink the tumor. It will take around 6 months to 1 year.
Ma'am, I have one more question. I am interested in doing research. Okay. So I'm thinking of a process like in immunological studies I have studied that any foreign particle introduced to our body or any organism can induce an immune response. Mm-hmm. So I am thinking of like developing a tumor in the mice, since mouse and the human have the same anatomy and genome. So as by producing the tumor in the mice, and then as it start producing antibodies against it, like any antigen introduced in the body will produce antibodies against it. So as that antibodies are produced, and that we can isolate and for the cancer drugs.
Yeah, some immunotherapy are in market, but the thing is we don't use it in India majorly because of the cost effect. Okay, and for it to become a standard of care, it has to be proven in phase 3 trials. So only after that we give an option to the patient. Otherwise, we still don't give, especially immunotherapy. So I think there are many other areas of research also which you can see, like the efficiency. We know that in breast cancer, these chemotherapy works. Okay, in some patients we see it doesn't work. Why does that happen? Okay, probably something, sensitivity to any chemotherapy. I think those are still upcoming areas of research.
Ma'am, up to what stage, up to what stage the cancer can be treated through surgical treatment or chemo?
It's a little vague question. So, firstly, it depends upon the site of the cancer. Okay. So, like for example, brain tumor, it has to be surgically operated most of the times. Okay. Something in the oral cavity has to be surgically operated. Okay. Then radiation we add later on to kill the microscopic cells. Okay. And then something beyond oral cavity, something like nasopharynx, pharynx, larynx, posteriorly. These can be tackled with radiation alone in early stages. Okay, in later stages, surgery and radiation both has to be treated. Something like lung initial stages, something like stage 1, stage 2, can be treated with surgery, and stage 3, stage 4, which are inoperable, can be treated with radiation alone. So same thing in a breast cancer, surgery is the main thing. Okay. Then in all the GI cancers, esophagus, stomach, rectum, colon, these are the areas where surgery plays a main role. If it is not operable, then there is a very thin chance of cure. Okay. Then all the what you say as blood cancer in normal people, like leukemias, lymphomas, these are mainly treated by chemotherapy. It is in the blood. Okay, so once you give a chemotherapy injection through the blood, it reaches everywhere. So something which is localized, okay, has less tendency to spread. That can be tackled with surgery or radiation. Something which is which has a tendency to spread more, that has to be treated with chemotherapy.
And then is there any treatment process which can be used to cure the cancer at any stage?
Can you repeat the question?
And is there any treatment process which can be used to cure or treat the cancer in any stage, in whatever stage it is, like in the first stage or the last stage?
No, we can't say that using this particular treatment I'll just cure that entire thing. There is nothing. Always, all these three modalities will work together: surgery, chemotherapy, and radiation. And that also applies in depending upon the stage. Sometimes stage 1 only one treatment is enough. Stage 2 you add one more. Stage 3 you add all three. Stage 4 also you try to give maximum chances of cure. So it is basically like this. And different chemotherapy. It's not the same chemotherapy what you give for all the cancers. It's different.
And ma'am, what about the drugs? What kind of drugs can be used for the chemotherapy?
Chemotherapy, it has many different classes of drugs. Okay. Sometimes when small chemotherapy agents are given to increase the benefit of radiation, like it directly affects the DNA most of the times. So as I told, the ionization to fix the ionization-induced damage, you can give small doses of cisplatin, platinum drugs are there, and then there are other alkylating agents like adriamycin, cyclophosphamide. So these are also good. And if it interests you, now the focus has changed from just breast cancer. It's not just breast cancer, PR positive or HER2 negative. I think now it's more of molecular treatment that has evolved. Like in brain, till 2000 we had just astrocytoma, glioblastoma. Now it is all molecular subtypes. IDH positive, IDH negative, ATRX positive, TP53 positive, negative. So all those molecular components have been added right from breast cancer, brain tumors, everything. So if suppose some molecule is positive, then we add that treatment like tyrosine kinase inhibitors or targeted therapy towards that monthly. So that is in evolution now.
Yes, so that was a wonderful summary of all the different options. So just to add to what Jayla talked about, the immunotherapy, whether I don't know you know it or not, PMS is actually a pioneer in this area. We have two of the most well-studied and most popular immunotherapy drugs in the market. One is Opdivo, which is anti-PD-1, and the other is Arroy, which is anti-CTLA-4. Now, if you look at these, basically the mechanism what you just referring to, there are different modalities people think about immunotherapy. It could be a vaccine, you can just create a tumor and use that as an antigenic substance to vaccinate. Then there are ways you can look at antibodies. There are ways in which you can actually, in the immunotherapy context, you are actually activating the T cells. The T cells which are called silent, though it has seen the tumor, though it has seen there's something wrong in the body, though it fought for a while probably, after a while it kind of loses its ability to fight. Right? So in such cases, one way to do this, identify those mechanisms which made these T cells silent. If you remove that break, the hope is that the T cells will revive, and then will activate, and then will kill those tumors. So that's the concept we have known. Right? Now the question, as Dr. Vijay said, not all tumors respond to it. That means not all tumors are antigenic enough to respond to a immunotherapy. So the question is, why that is the case? The second is, some tumors are resistant to immunotherapy, though you have your activated T cells or whatever, so they don't work on it. So the current areas of research, intense research, including in our own company, including labs within my group, is to look at these resistance layers. Why certain tumor? First of all, why not all tumors respond to immunotherapy? Even in cases where, let's say, take melanoma, for example, skin cancer, for example, some patients respond to it 100%. In fact, in those patients, we call it as cure. Right? And we've been tracking for the last 10 years, and there is no cancer coming back at all in these patients. This is pretty much one set of treatment, and following that, they are not being treated, it's gone. So, in that 20% population of melanoma patients where we see complete cure of cancer, the 80% of the population still don't respond to treatment. It is still melanoma. Right? So the question is why some of those patients respond, some of them don't respond. And to what Dr. Vijay said, there's a lot of patient stratification we are making into. She also mentioned about the cost of it. Right? Now, if someone is with cancer has to take this $100,000 drug, I'm just giving a number here, if it cures it, well and good. If it doesn't do anything, why should that patient pay $100,000 for nothing? As they will pay for it. Right? So, those are all social questions, economic questions, there are many ways in which we are trying to deal with that. But in general, so the best is to, even for us, right? We don't want to give drugs to people or patients just like that, because we want to sell those drugs. That's not what we want to do. We want to make sure that whatever we discover, whatever we find out, helps us, helps patients at the end of the day. That's where our reduction is, right? So, so what we do is, therefore, do patient stratification. We have biomarkers that we try to identify specific for patients, right? And therefore, from there, we take it forward and say, these patient populations will have a high likelihood of getting treated with this particular drug. So we call it the companion diagnostic. So for every treatment, we have a diagnostic. We let this patient go through this diagnostic marker analysis, and then we figure out, based on all of the software and on statistical analysis and biology and whatnot, we kind of predict what's the likelihood this patient population will respond. So there's all these researches, as she said, is our current way of work. But immunotherapy is going to be a very good, it's actually a very transformative way of looking at treatment options. And I'm very hopeful. In fact, I'm honestly trying my best to bring it to India in a major format, form. Hopefully, we will have that option soon. But the idea is, now we are actually looking to combination as well. Combination with chemotherapy, combination with radiation, targeted oncology, and so on. The whole idea is, if you can reduce the toxicity due to chemotherapy, or if you can reduce the toxicity due to radiation therapy, and combine it with something like this, we would have a major transformative treatment.
My area is actually, my interest is in aerospace, but just since focus is on treatment now, I just want to get a little question about what is the current medical standard research on glaucoma and cure for glaucoma and HIV.
Have you done anything on that?
No, sir.
Your interest is okay. If you are done
Just a lemon question, like, right? And
Can you repeat the diseases that you're interested in?
glaucoma and
Glaucoma.
is advanced stage glaucoma and HIV. Could you shed some light on?
Can you spell the disease? Glaucoma, then eye disease?
Yes.
I heard glaucoma, so I was like, okay, that's a totally different disease. That's why I wanted to make sure that I heard it right.
So, I'm not sure if someone wants to answer the question. I'm not completely aware of that area of research, so I should excuse myself from answering that.
So let me try if I can answer the HIV part. So this is something where a lot of advances are being made, right? And today you're looking at once a day dosing or even longer than that for treatment of HIV, even in pediatric population. So there's a lot of advances. Like earlier it used to be a 3-drug combination. Now they're talking about single pill that can be used for treatment of HIV. So those are advances. I'm not sure that all those are available in India today. I think we still continue with the 3 antiviral combinations that is being used, right? But there is a lot of advances that are happening globally in terms of treatment of HIV. In terms of glaucoma, I'm not aware. That's not an area of interest for me. So I'm not aware of all the recent developments that have happened in that space. I'm not sure if anybody else has. Yes.
Glaucoma is just a rise in the intraocular pressure in the eyeball.
Correct.
Like we have 2 stages of glaucoma where it infects the optic nerve, and one more stage is before infecting the optic nerve. Like the main problem in glaucoma is like we have a uveoscleral canal here where the aqueous humor drained is not draining, so there's a block in the uveoscleral canal. Based on that, we have acute glaucoma, congestive glaucoma, and chronic glaucoma. For acute glaucoma, surgery is the last option for acute glaucoma. And for chronic glaucoma, we have many drugs like based on osmosis, osmotically reducing agents are there, such as mannitol and all. And we have prostaglandins, latanoprost, and we have latanoprost. We have carbidopa, levodopa, we have cyclostigmine, neostigmine. Cyclostigmine, neostigmine, and all they are actually the dopaminergic dephosphorylating agents. So this is a treatment for glaucoma, and if it infects the optic nerve, and if the vision is lost, only thing is replacement of the eyeball, and the percentage is very less because the optic nerve is damaged, and chances are very less to regain the eyesight. And, so this is the answer for the question of what he asked. And I have one more question for you. And actually, I'm a medical student. The question is, we have so many diseases. For example, hypobacterium tuberculosis has leprosy, and we have HIV, it's called by human adenoviruses, and we have, there are so many diseases where still the drugs are not even known since many years. So the thing is, I've been interested in gene therapy. Gene therapy is mostly related to biotechnology. Just is research going on in biotechnology, and what is the current stage of biotechnology is helping on medicine? How is biotechnology helping to cure diseases based on gene therapy? I'm not interested in other things. Based on gene therapy.
Are you a medical student?
Yes, sir.
Which college?
I'm from Saptagiri Institute of Medical Science and Research Center.
Very good. MBBS.
When you spoke about gene therapy, I worked with the gene therapy laboratory in 2006 and 7. So whatever I will share may not be the latest information, but I can just throw some light on gene therapy. I worked for melanoma, skin cancer, where we wanted to design a vector which will help in increasing the pigment epithelial growth factor, which will prevent the angiogenesis so that the entire melanoma can be controlled. So this was the overall idea. So we tried on multiple animal models, hairless guinea pigs and things. Though it was working, but the effect was very temporary. The gene has to delivered at the right place, and the protein expression has to be much stronger. There is the gene therapy. Whatever we have done is called DNA vaccination, as against the conventional protein vaccination, where you challenge the animal with protein and which will raise antibodies or it will trigger any inflammation or any other reaction by which the entire cleaning cascade will be happening. So here it is more of a DNA vaccination, where the entire DNA construct with the particular gene of interest, whatever it can be. The delivery mechanism of this construct was very difficult. This was the only challenge what we were facing. So I had a chance to work with most of the human genes like AGF, FGF, VGF, whatever. And in every case, this was the only challenge. So we were optimizing many different technologies like what with viral mediated transfer, again the chances of virus causing any other it will stay in your system, and after some time you may not count it. 10 years, for 10 years it may be silent. Then all of a sudden it will just start appearing, and then it will spread and create some other unwanted consequences. So we want to always go with the non-viral mediated the gene transfer. So again, the expression was the major challenge what we have seen, and even till date I am following up. But again, that is the only challenge. So maybe with the technological advancements that can be sorted out in the near future, so gene therapy can be really one of the advancements for the treatment or management perspective. But again, like the earlier concept, like one gene, one protein, that concept is no more there. So one gene and multiple proteins, and every protein will have its subunits, and the active site of the subunit will be different, and n number of other proteins will come and sit on these receptors, and it will trigger multiple functions. So one protein, multiple functions. So you will never know. You may be targeting by introducing this particular gene and expecting one particular function, but other functions you have to really monitor. So whole body scanning after your gene therapy has to be very proper, and it has to be periodical, and you have to follow up. So it's a huge. The entire work is very magnanimous, and that is where the gene therapy might take some time. Yeah, and And with respect to glaucoma, I just wanted to share my chat with the ophthalmologist. Uh, I have mentioned about the product what I am developing. It is nothing but a growth factor concoction which can trigger regeneration of any tissue. So glaucoma, optical nerves will get damaged. So now doctors are rethinking whether because of accumulation of pressure inside, the nerves are getting affected, or because the nerves are affected, the pressure is getting built up. So the entire story is being rethought now. So they don't know. It is still under debate. So
I have a controversy to warriors. Like, if the nerves get affected, why should the pressure get increased? Because nerves are all the parts of the body. Like, if it is affected in the leg also, there should be some pressure increase in the leg, but it doesn't happen.
No, it is because whether it was because of optical nerve getting affected for any reasons. So I was under the impression that because of too much of pressure, optical nerves are affected, and if there is a way of introducing my protein concoction to that site and regenerate the nerves, can be controlled, because it is out of my personal interest, because few of my friends are affected with glaucoma. So I wanted to give them a solution. So I just was casually asking my ophthalmologist. So she said the entire glaucoma is being looked at a different perspective now. So we don't really know. So she said I will come back once I get a clear answer. So this is what her response was. And with respect to AIDS, the latest development from regenerative medicine side, the entire bone marrow will be, the circulating cells will be destroyed by high-dose chemotherapy, and healthy bone marrow transplantations can eliminate the virus for at least about up to 5 years. Yeah. So once the bone marrow will be repopulated with the recipient stem cells and the cells, the virus can be eliminated for quite some time. This is one of the developments.
So I have one. Yeah. Sorry. Can I ask?
Yes, sir.
So one of the ways in which treatment is being looked at today is a very holistic way of treatment. So it's not just doing allopathic treatment or surgery or radiation or regenerative medicine. There's a lot of emphasis coming on Ayurveda, yoga, and a variety of other factors coming into play to help the patient. So Dr. Babu, can you comment on some of that?
First of all, if you look at all the questions which you are asking about the diseases and the drugs, and your intention is that, can I do some kind of research? Can I get the molecules for the disease? At the same time, to keep in mind, the affordable healthcare system, that is the most important for a country like India. You can discover an anti-cancer molecule. You go to the patient today, they went to the doctor and he has to prescribe the anti-cancer drugs. And there will be an intermediate company agent. He will say to the patient that, okay, this is 35,000 rupees a kit. But if you take this kit, there will be one kit for free. Okay? This is absolutely the drug discovery where, as I also told you, the development itself takes $1 billion, a molecule to develop. So when we are discovering, we have to see the question relevantly asked is about holistic system. Okay, if you see the cancer therapy today, you see the in terms of the chemotherapy. So many drugs itself kills the patients. And then we have the question of immunotherapy. So this is the future where immunotherapy comes. When you talk about immunotherapy, you have hundreds of natural sources around you, where it will improve your immune system. That is where it is well researched in Ayurveda, and that is also our traditional medicines. If you talk about even immunotherapy or drugs which can come, maybe there are many companies which can discover, but the ultimate goal should be that should be affordable. So we have been working on especially the immunology, and we have researched more than 1,000 plants for the last 12 years. And then while screening that we found that there are 2 to 4 plants that can revolutionize the improving the immune system of the patients. And then we have come up with a drug that which is an absolutely herbal pharmaceutical drug, which is called Imisantin, which we have launched last year. And the clinical trials were done across all the hospitals, including AIDS, and to understand that how this is going to help the cancer patients when they are on chemotherapy. So there are very, very encouraging results for that. So therefore, while we are looking at a particular molecule or a drug, the more emphasis is a holistic approach. Apart from drug discovery and the molecules, especially the diseases like cancer, it is more important that your personal touch, how your willpower. So as long as you take a drugs, but you himself or like you yourself feel that so something is destroying the body, no drug will help you. That is where ultimately we go back to ultimately where we go back. Somebody asks questions at what stage cancer can be treated. So it's nothing that only he can treat the cancer. So that is where. But in terms to come back to my kind of research, I would like to tell you 2 points. Like all of you know about the Taxol. Okay, Taxol is a natural anti-cancer drug. Okay, but to get 1 kilo of the Taxol pure molecule, you require hundreds of tons of Taxus baccata bark. Okay. Now the question is that if you depend on a particular natural sources, then you cannot afford. Okay. And there is a synthesis. If you see that the Taxol synthesis is about 45-50 steps of synthesis. The scientist has been proposed for Nobel Prize for the synthesis. But again, it is not an affordable. Okay, the 50 step synthesis we can understand. If you are in organic chemistry, you can understand how it is. Ultimately, the biotechnology that is helped where through tissue culture, 50% of that Taxol molecules can be developed into biotechnologies and they go further 3-4 steps. So that is much more affordable. That is the first invention if you really want to look at from biotechnology point of view. In terms of holistic, we all know about malaria. Okay, and artemisinin was the one, and the last year the discoverer got Nobel Prize. Then now artemisinin was the one which is replaced all kinds of drug resistance, malaria and all. So now it is happening in many of African countries that this is developing a resistance. Now WHO last year has said that probably there are 50 other molecules in the Artemisia EUA itself. So those are very looks like molecule. Probably we need to look at holisticism of the drug development rather than a single molecule. Probably if we have similar kinds of molecules, you can mimic the organisms, like you can fool them, I can say in simple words, then it will not develop a resistance. So that's the one. So if you look at the opportunities in drug discovery or kinds of from biotechnology point of view, so there will be plant biotechnology, of course, what other areas are to be my industry is concerned. And you study about enzyme biotechnology, fermentation biotechnology, okay, and microbial biotechnology and food biotechnology. So it is a huge potential. Today people want, if you buy a tablet or a natural medicine, people ask you, is this free from preservatives? But we know that all parabens, preservatives are well researched and it is safe to use. But still people think that as much as natural or as much as safe drugs which you give, that is useful.
So before we go to that question, you mentioned about your interest in aerospace. Are you interested in aerospace biology or just aerospace? You are an aeronautical engineering student. Wonderful. Are you from Bangalore? Okay. Then you must visit Team Indus, which is there in Jaipur. I'm sure you're aware of them and they are moonshot. Yeah. So I happened to visit them a couple months ago and went saw the rover and the entire facility. And there is a beautiful synergy collaboration that happens between engineers, biologists in that place. And so if you're really interested in something in the aerospace biology part, I think that's the place to go and at least get a first feel of how things are being done. Right? Sorry, question from you.
Sir, with the permission of Chair, I would like to thank both of you, the medical student and aeronautic teacher, for attending the biotechnology conference. So I'm so happy that you are here. Actually, sir, I want to share a few things as a faculty. See, during admissions, to biotechnology, if not, I used to tell, if not MBBS, you can join biotechnology. I used to tell and advertise so and so because it has to happen. So actually, frankly speaking, with due respect to doctors and all, I don't know how much research happens after MBBS and MD, MS. Right? I think in the US and all other countries, there are a lot of hospitals who do research and all. But in India, I don't know if you forgive me if I missed it. So after MBBS and MD and MS, they do start getting the patient or getting to hospitals. So that's what there is a lot of gap between, because I understood that you asked that how biotechnology to like whatever medicine, etc. So there is a lot of gap. That's why me and Professor always will discuss. We need a there is no understanding between doctors and so on. So there is a gap between both of us. So if you join a biotechnology, if not MBBS, what we do, like many of our students started working on cancer, we do on neurology, neuroinformatics, we work on Alzheimer's, so on, so on. Some of the students work on diabetes. And they pursue later in respective fields. And I know Manya sir and all, when you enter a company, if there is a project, so we'll have doctors, we'll have engineers, so there everything is same. Only difference is here, like MBBS, dental, medicine, whatever, biotechnology. So that is what, this is what a platform we wanted to do from so many years. We do conduct conferences to make biotechnology, that's what, biology plus technology, but most of us were looking at the software after BE. So that's a problem here. So we study biology, we never think of technology, biotechnology, that's what we plan. So that is what, thank you very much for attending the conference, and we'll see that next time the most, actually we have communicated pharma also. Like, we want all the medical pharma students to come and discuss for here so that we can share. Morning the sir was showing lines, right? Sitting in the opposite direction, we have a meeting, so on. So this is what happening in dental, pharmacy, and so on. So that's one thing. Sir, thank you. Sir, my question is, yesterday we had this agri and food and dairy entrepreneurship panel discussions. Many of our students were happy with food entrepreneurs as to become, because it's easy. But if I want to become any of the students drug discovery entrepreneur, I feel it's very, very difficult. So what are the challenges are there on today's team if they want to become an entrepreneur? Because we know that if drug has to come, it takes 15 years and finance also. And that is one thing you all can. And my question to doctor is, what are the innovative challenges you face in healthcare? Like, can you highlight that this is the innovation and this instrument which is not there in healthcare, we want that instrument. Like we should discuss that pain detector is not there as of now. Likewise, during giving injection for L3 or L4 in between, it's very difficult to find out L3 and L4 during that some of these before pregnancy, so on, so they give injection anesthesia. So can you highlight that what is the innovation is required for your healthcare? Like, this instrument is a must. We are facing difficulty in treating the patients. We cannot do that. Can you highlight in that way if you have? And other question to all sirs, how much this entrepreneur in drug discovery is easy or difficult, because the team will be justified. So they cannot jump into drug discovery tomorrow. Maybe they can start with preparing ice cream or yesterday's food and nutrition. It's easy, but this is difficult. I request you to highlight this because the theme is that. Even I was also thinking to become an entrepreneur. Drug discovery is very, very difficult. Maybe you request you to highlight this. It will be justified. Thank you.
So let me probably take a shot at answering that question, because I've been a drug discoverer and I'm an entrepreneur, and today my organization combines the two, and we are trying to do drug discovery in the true sense of drug discovery in India, right? And we are combining affordable healthcare along with the drug discovery. So my organization works exclusively on diseases of interest to India. We work on finding new drugs, new diagnostics for diseases like tuberculosis, malaria, chikungunya, dengue, leishmania. So if you feel that there is a need for any other disease which is of interest to India, we're very happy to work on that as well. Right? We can, if you have an idea, you want to come work with us, please do come. It'll be your idea, we give you the labs, we give you the infrastructure, we give you the resources, you do the work. Right? So we are open to that extent. Right? Is drug discovery easy? By no means. Right? Dr. Manjunath told about the successes. I think the reason why BMS continues to stay invested is because of that success, which is a very rare phenomenon. Right? It's not that every company enjoys that kind of success. I would say, and I'm being very optimistic, that 5% of every effort in the drug discovery space actually becomes successful. 95 times you will fail. So if you're ready for taking that kind of challenge, then yes, this is the way to go. And whether a single organization can do this all the way through, obviously the answer is no. An organization like Bristol Myers Squibb, which has a turnover of probably $20 billion or more a year, collaborates a lot to get this done. So whether as an individual you can take it all the way, the answer is probably no, right? But can you do it with collaboration? Yes, the answer is yes, right? And which is where we are looking at. As an organization, we look for active collaborations with individuals, with companies, with academia, and we are constantly talking to people about new technologies that are coming up. And I was talking to Kashif this just before the session about the electronics and how you could use it for some of the drug discovery efforts. Today you talk about technology and drug discovery. I would say 20 years ago, biologists would have and chemists would have said, technology, keep away. We really don't want to even talk to you guys. We are a separate elite species, right? Today that's no longer the case. We're talking about artificial intelligence coming into drug discovery. And that's the level of depth into which technology has immersed itself in every way of life, including drug discovery and development. So if you have ideas in artificial intelligence which could impact the way we do any biotechnology related aspect, any cultivation of herbal related aspect, any new chemistry related aspect, or new biology related aspect, I think the thoughts are very welcome and you can be a very successful entrepreneur who kind of bridges that gap very, very efficiently, right? So I would say it's an absolute greenfield today. If you want to be an entrepreneur in the drug discovery space, I would definitely encourage you to be part of it, right? There's nothing to lose. You are at 24, 25 maximum, right? And you've got a whole life ahead of you. So what if you fail in your first hurdle? That's okay. You can always get up, brush it off, and find another job, right? But if you don't do it now, when you get to my age, it's a probably a little more difficult. Yeah, I can tell you that. If today I have to live on an entrepreneur's salary, I don't think I can survive. So if you want to do something, do it now. Now is the right time. Yeah? Dr. Manjunath, your views.
I think he really he said something eloquently about the opportunities. So there are a few things I want to highlight in addition to what he said. Now, the number of sites is extraordinarily important if you want to succeed as an entrepreneur. Now, you don't need to be a millionaire, you don't need to be a billionaire to start a company, right? You have a fantastic idea. You understand the nitty-gritty details of what that idea is about, and what are the surrounding aspects of biology, chemistry, technology, and so on. In drug discovery, if I want to give an example of drug discovery, there are small companies which are formed on a regular basis in the US and other countries, where they pick one target, one disease, one target, right? They are not interested in developing, as Dr. Sridhar said. You are not able to go all the way by yourself, but your idea will go all the way, and can go all the way. What is it that we are looking for? If BMS wants to, let's say want to collaborate, let's say you start a company and you want to collaborate, there are two aspects. One, I'm interested in your idea of a particular target, interested in solving a disease problem, right? And but exactly, in fact, we continue to do that. In fact, we continue to build those relationships. Even today, we continue to do that. So, what exactly we're looking for? If you start a project, if you have a chemical matter that you can patent yourself, right? Or or a molecule that you think it's yours, and you have an IP on that. And if I can actually repeat that study and then prove that whatever you say in terms of the biology of that particular compound and the mechanism of that particular compound, and if that disease area is of interest to me, I'll be very happy to collaborate. That's your opportunity in drug discovery. You don't need to be thinking about a large thing and how can I do genomics, proteomics. All those things are just they're not needed. All you have to start with is a good idea. And take it to a stage where you can actually make a molecule, inhibitor of a particular enzyme, or activator, or an antibody, or a protein, whatever it is, right? Or recombinant protein. That can actually, you can show both preclinically in cell, in the in vitro setting as well as in the animal setting that it works. You come to me, we can talk about it. That's one way of doing it. The other thing was what Sridhar said is about the technology. Technology these days are completely interwoven with what we do. I talked about some of the examples. I want to understand, I have a question today, which we still cannot solve. I want to understand why certain patients respond to a particular treatment or not. Right? It's a purely bioinformatics analysis to a great extent. I can give you clinical data of 20,000 patients. How do I take that data? How do I analyze that data? The big data analytics. Do you have a method to tell me this is the patient population you should be looking at in your clinical trial? You have a data as an idea, right? You don't need a big instrument to do that. It takes your analytical skills, your ability to look at a large amount of data, a good computational capacity, and solving a problem that is of interest to a big company like ours. And it can be $1 billion deal. Right? So you have to understand what those opportunities are. And as I first said, unless you're scientifically sound, unless your way of doing science is fundamentally on a strong footing, it is very difficult to win in a larger context. Okay?
So, just can I add one more thing? And don't be afraid to talk to people, right? Don't be worried that somebody is going to take your idea and run away with it and do something. Yeah, because that's something that can always happen. But if you don't talk, you won't even know whether you're on the right track or not. So come talk to any of us on campus. Professor Nagendra is there, Jagdish is there, myself, there is Srinivas. Come talk to us. We're very happy to at least mentor you and guide you in a direction which we feel will benefit you in the long run, right? And please do not hesitate to do that. I'm sure all the panel members are very happy to nurture younger talent coming in and asking questions, right? And that's where you will go forward. So don't hesitate to ask that question. Yeah.
One comment. One comment about your aerospace engineering. One of the best opportunity you have is protein crystallography in space. That's becoming more popular these days. Protein crystallography in space, because it is far, you can get a better type of crystals in space. If you can start a company saying that I'm going to do this, you have an opportunity there.
Okay, NASA has a one website of biology. If you go to NASA website, biology. So there are a lot of physiology of human beings who travels there, and also what is the food they can consume. So you can go to NASA, and the biology option is there. You will get a lot of ideas about into biology. Space biology.
Yeah, it's called astrobiology, and I believe there were some MIT students who were interested in it. The last time there was a question on that.
Yes, yes.
I think scope for research is same as Dr. Manjunath told us, why some patients respond to certain drugs and why other patients do not. Coming to the usual problems that we face is our cancer patients undergo many cycles of chemotherapy, and hence most of the veins, peripheral veins, are damaged. So to get a proper IV access later on gets difficult. So that is one area where we find it difficult. And next is probably we depend upon radiologists most often, like for ultrasound like tapping. All these things have become more rapid now. So I think a small ultrasound sort of machine, which can be handy for all the OPD doctors. So that would be a good idea.
Anything related to early detection now, issues associated with the cancer, in the sense like any innovations which is not yet solved in early detection. Of course, proteomics, clinical proteomics is happening. So which as a doctor you face, like this is third stage, patient has come. So is that required?
I think in brain tumors there is hardly any screening things that is happening. So in brain tumors and in abdominal tumors, lung is quite okay. Lung, oral cavity. It's just that our people do not come to medical attention most of the time. That is the major problem in our country. But as such, research-wise, probably brain tumors and abdominal, all the gastric cancers, intestinal cancers, pancreas, these are very much fatal and do not respond to treatment at all. And most of them gets diagnosed at a very, very late stage.
We have one last question.
Sir, I have a question for Babu sir. Sir, I am a research scholar from Yoga University. I am working on herbal medicine in the stream of nanotechnology. So, can I know that are there any fellowship programs offered by Himalaya company for the non-strikingly legal business models?
You're from which place?
Currently, you are doing research.
Yes, sir. The business scholars.
Okay, you can write to us if you have a research problem, which you are facing for your PhD. Definitely, we will look into that. We will give an opportunity to solve the problem if it requires we have to work there in our labs. That's fine.
One last question. One last question. Okay.
My question is for Dr. Babu. As you said, there are many herbs that have either been endangered or are going extinct, and several companies use them. So, is it possible to use GMOs instead of those herbs? Is it being used currently?
First of all, especially when you talk about herbals, okay, it is more towards wellness. Okay, it's more towards nutrition and treatments. It is more the consumer's requirement than the regulatory. Okay. So if I say the drug is developed using GMOs, the majority of the consumers today know GMOs. So many of products which we export many countries, they ask if the consumers demand that you get it certified your product is non-GMOs. So that's a consumer-driven market. So apart from the technology science, because we are in business, so we need to handle that. That's the first thing. But to develop this kind of herbs that we are getting endangered, you don't really require GMOs for that. The more importantly, because if you want to develop some kind of manipulation of bioactive markers into the plants, maybe you have to apply some gene modifications and stuff. But if you have to regenerate that old kind of wealth what we had, this is more a plant biotechnology. Because we need to develop a lot of through tissue culture and develop the cultivation practices. So how it is to be. You will be fascinated to know that in Ayurveda, if they say that these are particular drugs are used to, okay, followed by a lot of research is done, and then there are a lot of publications saying, oh, it doesn't work. So there are modern science say that it doesn't work because we have very rich culture and text, ancient text which says that it is absolute. The problem is understanding the herb itself. Because since we have different kinds of languages across from the south to north, the same herb is understood differently at different places in vernacular names. The first is ethnicity. Okay? And many of those herbs actually is from wild collection. The same herbs, when you cultivate particularly, where you are providing a nice nutrient environment, therefore the bioactives which are sourced from the wild collection are entirely different. So that is the main challenge when we want to create those endangered plants into cultivation mode. We have to ensure, we do a lot of trials of starting from soil testing to different kinds of stress conditions to ensure that same bioactive profile will be there. So that is a major area, like there's a lot of scope from biotechnology, a lot of fundings are available from our department of, now it is the Ministry of Forest, different state medicinal plant boards.
Yes, sir. So my question is to Dr. Vasanthi, Dr. Sridhar and Mr. Kaushik. After fixating upon an idea which you want to develop into a product or a tool, and after getting the proof of concept, how do you go about managing the financial and managerial aspects of setting up a company?
Okay. So I don't know where to begin. Too much of a story I have to tell you. I was keen on blood-derived therapeutics. The very moment I thought, okay, I'm not technologically, I'm quite sound. Now I have to go to the next level. So where should I start? Then at that point, my expertise was in stem cell culturing. This was in 2007. So I had to think about doing something like really, which I can really scale up. So I thought, okay, blood banking, everything, blood fractionation, all these things are like well-established procedures where blood banks are like following, and all the regulatory aspects are very clear. Because that's one of the major challenges that you will face when you really want to go larger scale and commercial. So blood-derived therapeutics was my focus, and when I had developed a concoction which works on in vitro proliferation of cells, I wanted to test it on in vivo proliferation. That is basically regenerating any damaged tissue. And so at that point in time, my friend, she was facing a problem of endometrial regeneration. Endometrium is the innermost lining of uterus, which was not growing, because of which multiple IVF cycles got failed. And she was told by a leading IVF expert that either you have to go for surrogacy or adoption. So she was telling me like, okay, you are doing so many things, then this is also a problem. Why don't you look at this, and why don't you do something to manage this? Then I had to really because the protein is with me, but how do I give it? I mean, it is again, it has to be infused into the system, right, inside the body. So then I discussed with IVF experts, and then they said there is a process called IUI. That is how we access the uterine cavity. So you can give us the concoction. And my friend is also a biotechnologist, so she understood what we are doing, how safely we can prepare this. And I have prepared the protein concoction from her blood only. So from 40 ml blood, I had managed to give her 1 ml of the concoction, and which was infused. 3 preparations I prepared and gave her the protein, and she took it with her, and the consulting doctor, she infused into her uterine cavity. And 4th day, she called me and said, my endometrium started growing. So that was my success. So then, for me, technically that was a success. But for her, pregnancy and baby is the success. And for the doctor, pregnancy outcome is a success. So now, after the endometrium has grown beyond 7 mm, which is they set as a standard, They have done the embryo transfer, and fortunately, in the same cycle, she conceived, and now the baby is 4.5 years old. So yeah, that is when I wanted to do okay. Whatever I have is working, but with one success, I cannot say that it is really working. So I had to do a pilot, and infertility is like 1 in every 5 couple in India they are facing infertility. So now I have to do a pilot. And again, because she is my close friend, she agreed to undergo anything and everything, right? The same thing will not work with everybody. So now I have to go to a doctor, approach a doctor, convince her, saying that this is prepared from patient's blood, I don't use any chemicals, the preparation is absolutely safe, and all that. But from the regulatory point of view, from government will catch me, ICMR will catch me, BCJ will catch me. If I don't take an approval and do it, then I have to go back and read the regulations, and they say clearly, if it is autologous, you have to have form an IEC, Institutional Ethical Committee, submit your proposal saying that for 5 or 10 patients you want to do this, and take an approval, make every documentation very transparent, and then the hospital also should have an IEC, company should have an IEC, together you prepare a protocol which has to be submitted to DCJ for their approval. All this is a big 1.5 year cycle. So, I mean, because it is autologous, first 5 patients we just wanted to go ahead. Just we want to take the risk. So we did it. Out of 5 patients, 3 patients were pregnant. And all of them undergone multiple cycles of failed IVF cycles basically. So this gave me the confidence that yes, my product works for infertility. I was developing it for cosmetology and diabetic foot ulcer, but now it is working for infertility. Should I have to really I will be defocused totally. Now I don't have to leave this and come. But infertility is, giving conception, pregnancy, all this gives you huge satisfaction, and there is a bond. So I wanted to really do it, and now I thought I'll apply because I don't have fund. So I have applied to DBT, and they have gone through the proposal and they have selected the proposal for funding. Okay, now I got the fund. With this, I'm developing it, and last 2 years we are doing lots of research, basic research, animal studies, and because it is autologous parallelly, we are doing it for many patients, recurrent failed patients and stuff. And the overall procedure, we made it so simple that it can be easily integrated with IVF cycle. So every IVF expert I'm talking to, they are willing to test it, and every doctor who tested, they are convinced with the results, so they refer multiple doctors. So I am working with more than 150 IVF experts today. And we have seen out of 450 patients, 60% success rate in terms of ongoing pregnancy, while national average success of an IVF hospital itself is 20 to 30%. 30% is the max. So this is how we have grown now, and this is a first 450 patients a non-randomized trial, and then with this data we have applied for a randomized clinical trial. Post this, I will take a DCJ license, marketing license, then I can go global. So with this, when for the first 450 patients, we have even charged the patients. They were very happy to pay and take the treatment. They say, when I spend 30 lakhs for my marriage, when I spend 25 lakhs for my car, why can't I spend 25,000 rupees for my project? So they are very happy to do this. So we are, doing service to the IVF hospitals now. So this is how we have grown so far. Thank you.
So I'm not as far ahead as Vasanthi now. So way more early stage, way more this thing. So I think the middle portion will be covered by Dr. Sridhar. So what I will do is I will tell you how I came about. So that will give you an idea of how it came. So initially I had an idea. So everyone, all of you will also start with an idea. But how do you take that idea forward is the biggest challenge that comes. And trust me, that is not the biggest challenge. The biggest challenge comes after that again. So I went straight up one day to Nagendra sir. I sat with him and then I explained the entire concept. This is what it is. And then he bombarded me with enough of questions to ensure that it's viable. That is your first test. Check whether it is scientifically plausible. Not possibility, plausible. Theoretically, should it be possible, and all of that. So all of that was cleared and everything. And then he said, "You come over to the this thing college. Come back to college. I'll give you a lab setup. Sit and work on the POC." So you need to find a lecturer or you need to find a small little lab like FNDR or any of them who are willing to help you or support you for that idea. So the first and the foremost important thing would be how you are going to pitch the idea and showcase that what you are trying to target at. See, because an idea is just an idea, but how are you going to take that idea forward? What is the pipeline for the idea? Where is it going to go? What is it applying for? So these are some of the things that gives the person who's supporting you more, let's say credibility to the idea. So when I told this is the idea, this is how it is going, this is where it will go, this is the possibilities. And imagine a world without agarose gel electrophoresis. So that is the thing. So everyone instantly connects because all of us have done agarose gel electrophoresis. All of us have cursed it. For 40 years people have cursed it. But imagine when I say, okay, see, I can eliminate this process. Everyone wants it. Right? So that's how you see. At the end of it, I told DNA quantification by its own property. Yes, it doesn't sound that fancy, sounds so nice. But there's a problem. What is the problem? No one wants to run an agarose gel. Hit the problem. So hit the problem which is relevant to everyone, and everyone will line up for it and say, I'll support you, I will help you. So, but Nagendra sir is different. So he will, either ways he will put trust into you and all of that. But in general, I'm saying you because the world outside isn't as friendly or as helpful as Nagendra sir. But that's how you have to approach the problem. So tell the problem that everyone can connect to and say that, see, this is the problem I'm trying to solve. Then they will give you the support and this thing. And there are a lot of people who will support out of their own pocket and their own money, like how sir has also supported me. But I'm pretty sure there are a lot of people, even Dr. Shekhar Narayan, Manjunath Ramarao sir, all of them will be very supportive in this case and they will put their own money to support you for such a cause because it's a beneficial for everyone, not only you, for them, the society, whatever. So this is the first step towards all of this. The second step comes at networking. Collect enough of people who are experts in those domains. As I told, alone, it is not possible for you to do anything. Trust me, it is not possible to do anything. I need experts who will guide me in a lot of aspects because idea is one side of the problem. The next problem is, okay, I told I will eliminate agarose gel, but how do I go about it? Because it's a completely new idea. So that first step, how do I go? What is the basics behind it? What is the electronics behind it? What is the chemistry behind it? Then how does it work out? Can I read the software? There's so many things that come into play, which all make up different pictures or parts of the picture. And then going further, you are trying to build a product. So now you have to market the product. You have to make a business. You have to start a startup. So these are all the other problems that start coming. So you need to find a business partner who's done it before. So he will guide you, tell you, okay, this is what you have to focus on. This is how you focus on. See, your idea is good. Okay, yeah, you can replace agarose gel and electrophoresis. Yeah, fine. But how are you going to make it commercially viable? That is the next thing. How are you going to make money out of it? See, everyone will support you. Yeah, okay, fine. But you say, no, mine is very expensive. No one is going to line up for it. As simple as that. See, the idea is one point where people line up. Commercial aspect is one more line where people line up. Then the societal impact that you are going to give is the third thing that people line up towards. So after all of this, that is the most important thing. See, now by saying I'm going to eliminate this, what I'm saying is I can reduce the burden of PCR or the time taken for PCR. What happens automatically? The pricing and the costing, the time, everything comes down. So it becomes more affordable. I can take it to people and I can do it on the spot. So this is the societal impact that it is creating. So these are some of the three main pillars that you have to focus on any idea as to how to take it forward. And if you cover these, I think it will really help for the idea to give someone from outside to give you a foundation for that idea or the support to take that idea forward. So this is what you'll have to do. So similarly, if you cover all of these points, the government of India is very helpful in this thing. They have a lot of funding schemes such as the big grant which I have got. So the same way, when you pitch it like this, they recognize it and they give you the money and they say that yes, go ahead, show us the proof of concept, show us that it is possible. See, even the government knows that by giving you money, not necessarily it can work. But they're putting the trust saying that yes, you have the right people, you have the right idea, let's see if it works. If it works, it's a win-win for everyone. So that is the idea. At the same time, even Karnataka government also has its own idea to POC, which is there, which is again a very supportive thing. So all these things are there to support you and get the POC to a level. And then post that, I think how Vasanthi ma'am has gone further, that's how it grows into whatever it has to.
I think Kashif has answered everything. I'd just like to touch on one point. Most of us as scientists get so involved with the science that we forget the business part. Right? And at the end of the day, we are trying to sell the science. So one has to be very, very careful in how you're looking at the business. Right? And as much as it is important to put a scientific plan in place and say, okay, in 3 years I'm going to go from point A to B to C to D, it's very important for you to have a business plan, which also does the same thing. From going from point A to B to C to D, what is it going to cost you, right? And when is it that anybody who's putting money in your organization is going to see a return on that investment, right? And that is very, very important. If you tell somebody, oh, you start putting in money into me today, and probably 10 years later, I might be able to give you 3x return, instead I put money in a fixed deposit. And here you don't need to come to you, right? The investor, if he's a pure investor, is looking for a return on investment, which is giving him returns, which is much more than what FD gives or a mutual fund gives or something like that, right? So you're looking at a business plan which gives you the cost, which gives you what your market is, which gives you what you can sell the product for, right? So today, before you have even got a POC, you're thinking about what is it that I'm going to charge the person, and that has to be your ultimate goal towards which you are working. When we talk about point of care, we are talking about making things affordable, right? And what is affordable? Affordable is a very subjective term. What is affordable in India is probably not affordable in some countries of Africa, and probably what is affordable in the US is not affordable in India. So we have to look at that affordability and look at who's the patient population whom we are targeting. So your entire concept has to cover not only the science but also the business. You asked about the source of money. Be prepared to shell out some money on your own to start the process. Because if you don't believe in your idea enough to put in some skin in the game, nobody else is going to. Right? So yeah, for the POC, maybe you have to shell out some money. Even any of the grants from the government of India will require to see some POC data before they will fund you. So to get that POC, you have to be willing to fund yourself. It may be a few lakh of rupees, right? But yes, there are people like Kashif said, maybe Manju, yeah, he has a lot of money. Willing to donate some. Organizations like mine, we may not be able to give you the money, but we'll give you the infrastructure and the consumables to come and do the work. So there are ways and means in which you can raise the funding, but that is something that you will, I would say, get to the POC on your own, patent it. That's where you have created the value, right? Don't go to somebody and say, invest in me today, I have an idea, because that's not going to give you much leverage on the idea itself, because the other person will start dictating terms, right? So you build your POC, you create your patent, and then you go to something, right? That would be my suggestion. Sure.
I kind of missed out on this, so very valid because you have to shell out money for your initial POC. I thought of telling, I forgot. So yeah, very important because as far as I said, I worked in the lab over there and everything. Maybe the consumables was taken care by HOD sir, but then anything beyond it, see, there are so many other things that you have to do. You have to go to places, you have to meet people, you have to find out ideas, you have to go to prototype electrical engineers, you need to find so many other people. There are so many other things that come into play. For all this, you need to put in money. No one's going to come and work for free unless they're invested in it. So if they have to be personally invested, they'll be like, okay, you give me a part of your company or a part of your idea, I will also become a part of it. But at that stage, are you willing to part with something with it? Definitely no. So then you go to them, you tell, see, I pay you so much, you do this service for me and give. So there you have to shell out money and it doesn't matter. Because I've shelled out money for almost close to 2 years to get to here so that the government funds me for this. So to show those results, you have to put in money, be ready for the sacrifice, time-based sacrifice, money-based sacrifice, most important.
So just to control the money part. I personally don't have the kind of money, but I know that we've been giving fellowships to many students. This is not a huge amount of money, but substantial amount of money as you start a kind of a seeding money, for example. Now, this is a no string attached fellowship certificate. We don't ask you what you want to do, we don't ask you how you spend it, we don't ask what is your project is going to look like, is it going to be associated with anything that we are interested in, none of those things. We are not going to ask any of those things. So, and we've done, we already on an average give about $100,000 grant per year. That's a lot of money, right? And of course, I won't give $100,000 to one person or one institution. We spread this across India, and it's a sufficient enough money. But for a PhD student, we give up to 10 lakhs per year. For a master's level, we give up to 5 lakhs a year. It's a free money to you, right? If you have such an idea that you are so passionate about, that you believe in, right? Apply for such grants. Apply through your HOD, your department. Again, again, this year I'm honestly trying to give at least 2 awards to this college, but I cannot guarantee that. But let's see. So there is, all these are things that you should be able to take advantage of. So money should be your least of concern.
So I hope that was informative and entertaining session as well. Yeah. So I want to thank all my panelists for their time and sharing of their experiences. It's been quite a learning for me personally as well, to understand about regenerative medicine and DNA technologies and oncology. And I know both these gentlemen for a few years now, so I know what they do. So, but thank you all for the interest that you have shown and the kind of enthusiasm that has come out. So, if there are no more questions, I'd like to conclude the session. And please join me in thanking the panel for a wonderful session.
Thank you so much, sir. And I think it's been a wonderful session. We thoroughly enjoyed it. And like my colleague was saying, I think we have already started bridging this gap. Right? So we have doctors, we have engineers, we have scientists, we have entrepreneurs. So everybody is there in one single room. And this is something that we have always dreamed about. And thank you, Nagendra, sir, for this. We really are very, very privileged to be part of this. And of course, I would also take this opportunity to thank Dr. Manjunath Ramarao, who has, especially for the BMS fellowship, that he has actually granted. Thank you so much for that encouragement, because it means a lot for young researchers. And on behalf of the organizing committee, I request Dr. Shikhar Narayan to kindly present a memento to each of our panelists. Dr. Manjunath Ramarao. Dr. U.V. Babu. Dr. Vasanthi. Dr. Vijayanta.
Careful.
Mr. Kashif Sharif. Another round of applause to this entire panel.
Nagendra to kindly present the memento to Dr. Sridhar Narayan. Thank you so much once again, and of course, thank you very much to all the participants who have really taken part in this show. Thank you so much. Thank you once again. I request everyone to go for the seats. And please have a look at the posters, room number 017. Poster. The posters have been put up in the foyer because Mother is trying to move to the foyer for the presentation. And I request all the participants to kindly reassemble at the seminar hall tomorrow by 9:15 for the sessions. Thank you so much. The poster evaluation is also being done in the foyer. Thank you.